Hello everyone and welcome to this video on the Generative AI full course by Edureka. Generative AI focuses on creating new content such as text, images and audio using advanced machine learning techniques. Key models include generative adversarial networks, variational autoencoders and transformers like GPT. Applications range from text generation and image creation to music synthesis and data augmentation. While generative AI has significant potential in entertainment, advertising and more, it also faces challenges related to quality, bias and ethical concerns, such as the misuse of deepfakes. Continuous research aims to improve the realism and responsible use of these technologies. With that said, now let's outline today's agenda for the Generative AI full course. We'll start by exploring an introduction to Generative AI and discussing how it's transforming the way we interact with technology. Next, we'll discuss what Generative AI is and how it works. Then we'll explore the top 10 popular Generative AI tools to help boost your productivity. We'll also discuss artificial intelligence for beginners. After that, we'll go through the different types of artificial intelligence and explain deep learning and why it matters. Next, we'll explore generative adversarial networks and learn how to generate images using DCGAN. We'll also cover large language models and take a closer look at ChatGPT, comparing it with Google Bard to understand the differences. Additionally, we'll introduce Midjourney AI and show how to use it to create art. Next, we'll discuss AI ethics and its importance in responsible AI development. We'll then explore prompt engineering, including how to use it for code generation and build a chatbot. We'll also learn how to build projects using the GitHub Copilot. Additionally, we'll discuss the top application, technology and benefits of AI, providing insights into its vast potential. Finally, we'll outline an AI roadmap and discuss frequently asked interview questions in the field of artificial intelligence. But before we begin, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. And also visit the Edureka website for the Generative AI Masters program, the link to which is given in the description box below. Now let's start with our first topic, Introduction to Generative AI.
Fifi Lee, hailed as the godmother of AI, once said, "Artificial intelligence is not a substitute for human intelligence. It's a tool to amplify human creativity and ingenuity." This sentiment resonates profoundly as we witness the continuous advancement of AI in catalyzing progress and future innovation. In an ever-evolving digital landscape, generative AI stands out as a beacon of innovation, transforming how we create, design, and interact with digital content. Introduction to AI. Starting with AI, what comes to your head when you hear this thing called AI or artificial intelligence? Some of you might say Alexa or Siri, or some of you even might give examples of AI tools such as ChatGPT or AI Bard. But what exactly is AI and how does it work? Let us understand. Artificial intelligence refers to the development of computer systems capable of performing tasks that typically require human intelligence. It is like having a super smart friend who can learn from information, make decisions, and even do tasks without being explicitly programmed to do so. Now, let's dive into the working of AI. AI works by using algorithms, which are like step-by-step instructions to process data and make decisions. Think of it as teaching a computer to learn from examples. First, the computer collects a bunch of data, like pictures of cats and dogs. Then it learns to recognize patterns in the data. For example, it might notice that cats have pointy ears and dogs have floppy ears. Next, when you show the computer a new picture, it uses what it learned from the data and guess if it's a cat or a dog based on the patterns it recognizes. Over time, as it sees more examples and gets feedback on its guesses, it gets better at recognizing cats and dogs. Today, we are all surrounded by AI, from voice assistants like Siri and Alexa to self-driving cars and personalized recommendation systems on streaming platforms. AI is all around us, making our lives easier and more exciting. Now, coming to generative AI, it is a subset of artificial intelligence focused on creating new content such as images, text, music, or other forms of data that is original and not directly copied from existing examples. While conventional AI learns from existing data to spot patterns and make predictions, generative AI goes a step further. It learns from the data it is given and uses that knowledge to create brand new content like images or texts. Generative AI algorithms are often based on deep learning architectures such as generative adversarial networks or variational autoencoders. It learns to generate new content by learning the distribution of the training data and then sampling from this learned distribution to create new realistic outputs. Now, if you are wondering what generative adversarial networks or variational autoencoders are, then you can enroll in our Prompt Engineering with Generative AI course to have a detailed explanation of these algorithms. For now, you can consider these algorithms as the techniques used in artificial intelligence to generate new data, like images or text, based on the patterns they have learned from existing data. So, by now, I hope that you have understood the concept of generative AI, and now let's move forward and understand AI prompt writing. Prompt writing involves providing a specific instruction or question to guide the creation of written content. It serves as a starting point or framework to direct writers' thought and organize their ideas. For example, if your teacher asks you to write an essay about climate change, that's a prompt. Or if someone gives you a sentence or a picture to inspire a story, that is also a prompt. Usage of proper prompts becomes very important because they give you a clear idea of what you need to write about. They help you to stay focused and organized, making it easier to come up with ideas and express yourself. Let's understand this with an example. Here we have two prompts. The first prompt says, describe a memorable childhood experience focusing on how it made you feel. And the second one says, write about something you like. Which one do you think is better one? It's obviously the first one. How? Because it tells exactly what you need to write about, a childhood memory and how it made you feel. This helps you to focus and share a personal story that is meaningful to you. In contrast, the second prompt is a less effective prompt as it lacks specificity. It just says to write about something you like and which could be anything. This might make it hard to come up with the ideas and write something interesting. So, having good prompts can effectively make a difference in your writing. They give you a clear idea of what you need to write about and help you to stay focused and organized, making it easier to come up with ideas and express yourself. Now, let's move forward and dive into text-to-text generative AI. As the name suggests, in text-to-text generative AI, you give text-based prompts and expect a text-based output. It is more like having a smart computer that can read and write text. Imagine you ask it a question and it gives you a detailed answer, just like a knowledgeable friend would do. Or you give it a sentence and it continues the story with more sentences, just like an imaginative storyteller. This AI can understand written words and generate new text based on what it knows. It is like having a helpful writing buddy who can brainstorm ideas, provide information, or even create stories and articles for you. Text generation uses machine learning, existing data, and previous user input in generating responses. Generative AI can be used to understand text, create content, debug code, education, research, translation, virtual assistant, and much more. But giving prompts to this generative AI is something that is going to make a difference in its effectiveness. And that's why here are some general rules to follow during AI prompt writing. Let's have a look at them. Rule number 1. Start simple. Start with a simple prompt and then you can build on it. Rule number 2. Call to action. Start the prompt with an action word like write, create or summarize instead of words like can you. Rule number 3. Add context. Add specific and relevant context to the task you want to perform. Rule number 4. Add expectations. Add clear and direct expectations for the content like how long it should be and what to include. Let's check this with an example. Over here, if you see this prompt, create a schedule for a professional programmer based on the following criteria. It should complete 8 hours of sleep, 6 hours of programming. If you look at this prompt, it implements all the 4 rules that we have discussed above. So, as you saw in the last example, we used ChatGPT 3.5 and now let's explore more about ChatGPT 3.5. ChatGPT 3.5 is a smart AI chatbot developed by OpenAI which was launched in November 2022. This version of ChatGPT can talk with you, answer your questions, and assist in different tasks. Anyone can use ChatGPT 3.5 by creating an account with OpenAI. It knows a lot about many topics and can give detailed answers. However, some people have mentioned that ChatGPT 3.5 doesn't always get the things right. Now, to get an overall enhancement in technology and performance, ChatGPT 4 was introduced. ChatGPT-4 is an updated version of ChatGPT 3.5 developed by OpenAI and was launched in March 2023. It is a next level up for ChatGPT 3.5. This version is smarter and understands you better. It can handle more complex questions and gives you detailed answers, and even understands pictures, not just words. It is like ChatGPT 3.5 but with a major boost in skills and abilities. Now let's compare ChatGPT 3.5 and ChatGPT 4. ChatGPT 3.5 was trained on the data available until June 2021, whereas GPT-4 includes information up to September 2021 and even some after that, making it more up to date. GPT 3.5 has 175 billion parameters, but GPT-4 leaps forward with over 1 trillion parameters, indicating a significant increase in complexity and potential understanding. GPT 3.5 offers limited corrections and suggestions, while GPT-4 provides a broader range, enhancing its utility. GPT-4 introduces improved safeguards, making it 82% less likely to produce responses to disallowed content compared to the more limited safeguards in GPT 3.5. GPT 3.5 context retention is limited to 3000 words, but GPT-4 extends its capacity to around 25,000 words, allowing for more complex and nonsense conversation. GPT 3.5 can deliver responses within seconds, but GPT-4, due to processing larger volumes of data and more complex algorithms, it may take a minute or more for larger responses. GPT 3.5 is primarily text-based with no capability to understand images, while GPT-4 can comprehend and describe images and even make suggestions based on them. These differences illustrate the significant improvements made by ChatGPT-4 over ChatGPT 3.5, from training data and model complexity to functionality and safety features, making it a more powerful and versatile tool. Moving forward, let's also check Google Gemini. Google Gemini, which was previously known as Google Bard, refers to a family of large language models developed by Google DeepMinds. These models leverage multimodal and multitask learning to achieve capabilities beyond traditional text-based LLMs. Google Gemini denotes a collection of large language models trained on diverse modalities such as text, code, audio, image, and video, encompassing various tasks such as question answering, summarization, translation, code generation, etc. It embodies a significant advancement in AI, transcending text-based models to offer multimodal and multitasking capabilities. This enables deeper understanding, comprehensive analysis, and broader applicability across various domains, paving the way for powerful and versatile AI tools. So, after exploring text-to-text generative AI, let's move forward to text-to-image generative AI. Have you ever imagined a cat wearing a wizard hat and riding a skateboard? Or maybe a picture showing a tiny city built on a leaf, complete with its own little cars and houses? How about an image of a dinosaur and a unicorn having a picnic together? These ideas might sound whimsical or out of ordinary, but thanks to an innovative kind of machine learning called text-to-image generation, they can be brought to life. This technology allows for the creation of vivid, lifelike images just from a simple text description, making even the most imaginative scenes possible to visualize. But how does it work? Let's check that out. With text-to-image technology, you tell the computer what you want to see, like an apple or a cat sitting on a couch, and it creates a picture that looks just like what you have described. You can even ask for something more detailed, like a cute sloth holding a tiny treasure chest with a bright golden glow coming out of it. Over the last few years, these systems have gotten really good because they have been shown tons of pictures and the words that describe them. This has made the pictures they create better and more varied. One of the most widely tools for generating images from text descriptions is DCGAN, which is accessible to users at no cost. Now let's transition on a computer setup and explore some hands-on demonstration using DCGAN. So here you can see the user interface of DCGAN. So let's start by giving it a prompt. Let's give a prompt like a cat wearing a wizard hat. So a cat wearing a wizard hat. Click on run. Now, this DCGAN is available for free. It might take some time. So let's keep our patience and check. Okay, so here you see a cat who is wearing a wizard hat. Now, this image is a complete new image, okay, and that is the speciality of text-to-image generative AI tools. It gives a new image and it got the new image from the previous data sets that it has been trained on. Generative AI has changed the creativity by offering new ways to generate content like images, text, and music. As these technologies continue to advance, the possibilities for innovation and expressions are endless, promising an exciting future of limitless creativity.
I have a quiz question for you guys, and the question is, what is the primary purpose of generative AI? And the options are A, to classify data, B, to generate new content, C, to analyze trends, D, to reduce computational time. If you know the correct answer, please leave it in the comment section below. In our previous module, we explored an introduction to generative AI. We'll now dive into what generative AI is, helping you understand its applications. So we all know that nowadays the power of artificial intelligence is developing day by day. Artificial intelligence is the science and engineering of creating machines that can perform any task that typically require human intelligence. But the task that is done should be understood by humans, and it is taken from the human life's experiences. The introduction to generative AI is brought to the next level, and the data is mimic of human cognitive functions to solve complex problems. The generative AI is the deep learning that is again a part of an artificial intelligence. So I will tell you the generative AI will help you to create a new artificial content, like let it be texting or writing any kind of new content or video, images or audio or even data. So all these is brought up to respond to the data that is given by the humans. These respond to all the stimuli that is called to be as in prompts. The models, the generative models, are allowed to do what the humans are to be told. It is very simple that all the large generative models are made through a model known to be as an LLM. So I'm here to explain what is LLM. It is a large language model. This is an advancement that has led to the development of generative AI. Okay, so I will teach you what is LLM. LLM, by the name itself, tells you it is a large language model where the model contains a large data. So this large data, it is a super smart AI system that uses fancy neural networks tricks and a lot of parametrics that can be understanding by the human-like languages. These are very brainy wizards of any AI world, especially good in understanding and creating the text. So that's how it has made humans' life more easier and even simplifying and directing. This aids in creating more endeavors by generating ideas, designs, and content across various domains. So now, if you are interested to know more about the generative AI, you are landed on the correct video. Firstly, copy. Copy is directly proportional to, you can tell it is a content creation or it is a creativity writing into any content. So AI can produce an original and a creative content across various mediums like text, video, and audio in many different platforms. So when it comes to 3D effects, as you can see, 3D effects, for example, you have a lot of movies releasing, a lot of animes, a lot of many stuffs that people are getting encouraged and people are getting attracted to is by using 3D effects. So generative AI tools can be used to create 3D shapes and models utilizing a generative model. This can be achieved through various techniques, like using your algorithms like VAEs and GANs. So all the AI tools for the 3D shape generation are beneficial for creating the detailed shapes that might be possible when manually creating a 3D image. So AI tools are very easy for creating your 3D shapes because they will give a good implementation to the screen. Next come your content creation. For content creation, I can give a best example that would be your social media, which is very much hyped nowadays. So content creation where the generated content includes images, videos and audios that is generated or modified by deep or machine learning processes. This content may include of real people that may be highly realistic or created in a particular artistic style. For example, I could even include paintings, cartoons and even anime as I told you all. So next, let me tell you, even coding platforms also have used AI tools for creating and leveraged even in software development. For example, all the IT industries use coding in the AI field for making them very easy time complexity and even developers' time and effort of writing, testing, and even fixing codes is also important. So in all these kind of ways, all these parameters are used in this software development to make coding more easier. Next comes your security. This will play a very vital role in any kinds of platforms that you see. Organizations can use generative AI to craft scenarios that mimic a wide range of cyber threats, from phishing emails to complex malware attacks. So this will allow the cybersecurity team to experience and respond to these threats in a controlled environment, so that they can protect themselves from any real-world incidents happening. So next, let me talk about healthcare advising. In healthcare advising, generative AI finds application in various healthcare domains, including your drug discovery, image medical processes, and personalized medicines. Even in healthcare, even the diagnostic people and even the diagnostic machines are even used as an AI process. So all these data are insights that can improve the patient outcomes and also the streamlined healthcare processes. So next comes your finance. As I told you, that finance will play an important role in many fields, where generative AI can be used as a fraud detection in finance by generating synthetic examples of fraudulent transaction or activities. So these data will help people to know about how the machine learning algorithm is put in the financial processes for making it more legitimate and fraudulent pattern in the financial data. So next, let me talk to you about your automation. Automation is nothing but it is significantly enhancing robotic process automation. For example, that is your RPA. So this will enable more versatile and adaptable automation. That's how your online transactions and many kinds of very free platformic materials are done. So these processes are very natural in language. They synthesize data and make sophisticated decisions for people. Now, have you imagined why generative AI has made a great impact in humans' life? Why is it so easy for humans to use it? Yes, I'm here to tell you why. Generative AI is enhanced for making decision-making processes and also by providing valuable insights, augmenting data, and also analysis. So these give you very easy decisions. Even there are very alternative options for making a problem solving easier. This will give you a large number of data to be processed. And by this, you all know that nowadays, many of the platforms are using these kind of data to be trained their own models. And also generative AI helps in decision makers to explore alternate strategies by accessing potential growth. So that's how it is making a very big growth in the economy too. So now let me tell you how the models are created. The primary function is to understand and capture the underlying pattern of distribution of the given set of data, how each set of data is distributed in each models that we are creating. So once we know that there is a huge number of data that is created, it is to be learned that the model can generate new data and they can share the similar characteristics with the original data set too. So generative AI is also a model where they have a lot number of data that to be trained. It is also giving an additional information to your previous number of data that you have created. The previous data is given to more information that is not seen before. So the creativity of each data is given in a very underlying stages. So some models I can tell you is that nowadays using is ChatGPT, OpenAI, that is DALL-E 2, and your AlphaCode. So now let me tell you the models are made to generate by the data that is trained by using many AI algorithms. When the data are trained, as we know that there is a word called big data. Each model is having their own data that is very vast and very versatile too. So every data that is created is huge. They will have their own data set that is not to be generated previously. They are used by using algorithms. For example, I can tell you two algorithms. Those are the VAEs and GANs. So those are the two algorithms that can be created. They all are having the models that are mainly generated by the data that is trained by the using AI algorithms. As I told you all, will be trained the data and synthesized with the new characteristics. Every time you create a new model, that is giving a new creativity and new characteristics to the same model that you have created by using your trained data. So now let me tell you how the evolution of generative AI has taken place till now. So generative AI is an ability to stimulate the model and also scenarios in revolutionizing the research and development across many industries. Every industries use AI nowadays. As you can see, the development of AI is huge. So generative AI was first introduced in 1960 by the chatbot, but not until 2014 still the generative adversarial networks and the GAN, the machine learning algorithms, were introduced. These algorithms are mainly used to create all the versatile models that are to be generated in real-world applications. So this real-world applications gives you the creativity, how the images, videos, and data to be produced. Lastly, I would like to tell you guys that generative AI can make new things like art and music without human help. It's good for many areas like health and money, but we need to be careful about the fairness, privacy, and bad uses. We should keep studying and making rules to use it in a right way. Finding a balance between making new stuffs and being fair is really important for everyone. It's time for another question. What type of output can generative AI create? And the options are A. Only text, B. Only images, C. Text, images, audios and videos, D. Only structured data. If you know the correct answer, please leave it in the comment section below. Now that we know what generative AI is, in our next module, we will explore generative AI tools, where learners will learn about the various tools available for creating content and applications.
These generative AI tools can help you save time, boost your creativity, and get more work done in less time. So whether you're a student, a professional, or just someone who wants to stay ahead of the curve, this video is for you. So let's dive in to learn more about the top 15 Gen AI tools together. And by the end of this video, you will know exactly which tools to use for your task. So we will explore tools that can help you generate ideas, write content, and even create art. You will learn how to automate repetitive tasks, analyze data like a pro, and make prediction with ease. So we will also cover some fun tools that will make you wonder how you ever lived without them. So let's get started. First in our list, we have ChatGPT. ChatGPT, developed by OpenAI, is a generative pre-trained transformer that is capable of understanding and generating human-like text. It is one of the best tools for various applications in natural language processing. ChatGPT is everywhere these days, right? People from different industries and backgrounds use it for all sorts of things. Like for example, businesses use it to help out with customer support and to find new leads and to do market research. Also, the writers, bloggers, and content creators use it to come up with interesting ideas and to make their content super engaging. And developers and technologists even use ChatGPT to build AI-powered applications, chatbots, and tools. So basically, ChatGPT is used across many more domains for different purposes. It is one of the most commonly used tools. One of the best things about ChatGPT is that it gives free access to AI content development. So to use ChatGPT, simply open the interface and input a prompt or question. It can be about anything. Like for example, if you are a programmer and you want to understand how a program works, you can paste your code into ChatGPT and ask it to explain. Let me take an example to find a factorial of a number. So once you copy paste your program, just type in explain the program. And here we go. It has explained the program step by step. So just like that, you can get assistance with writing content on any topic. And if you're not satisfied with its response, you can request another one and it will provide you with as many responses as you need. Customer support representatives, content creators, developers, educators, and researchers use ChatGPT to generate text, answer questions, or engage in conversation in various applications and platforms. Let's move on to the next tool on our list, and that is Bard. Bard is a generative AI chatbot developed by Google, which is now called Gemini. It is designed for creative writing tasks and is built on Lambda, a transformer-based model. Bard can help you do tasks such as coding and solving math problems, and as well as write, plan, and learn more. You can also generate images through the Gemini. It recognizes speech in over 100 languages and help with audio translation as well. So without the need for any extra tools, Gemini can understand tricky visuals like charts and diagrams all by itself. And it is also the best tool for describing images and answering questions about them. So to get access to Gemini, you need to sign into your Google account and start chatting with Gemini. You can provide prompts with various inputs such as text, images, videos, or even code. You will also have the options to integrate with Google apps such as Gmail, Docs, Sheets, and more. So let's try it out. So imagine you have an image or a diagram that needs explaining. So all you need to do is click Upload Image and select the image from your device and type Explain the diagram. And there you have it. It provides explanation for all the 6 phases and it's really easy to use, right? And as I mentioned earlier, it can also generate an image. So let's try it out. Create a picture of a playful puppy. So as you can see the screen, Gemini has generated images, and if you're not happy with these images, you can ask to generate more images. And a bar is used for content creation and writing. So it's often used by writers, bloggers, marketers, educators, and anyone who needs assistance with generating content, brainstorming ideas, or even improving their writing skills. The next tool that we have on our list is Burden. So Burden is a generative AI tool developed by OpenAI, and it's an AI assistant that simplifies repetitive tasks and effortlessly automate tasks within work app. There's no need for complicated builders or scripts. You just tell Burden what you need and it will do the task in no time. Burden learns from you to create personalized automation, and it works with many apps and websites, making your task easier. Burden is a great tool for making work easier, so it is used by managers, sales team, recruiters, and others who want to automate repetitive tasks and get more work done efficiently. And through Burden, you can connect data and actions from one app to automate tasks in another. Also, Burden works with many popular apps to make your work easier. Burden can also handle tasks in your apps and websites like filling out forms, sending messages, or creating reports. It makes the task easy for you. And workflows are like chains of actions triggered by you or changes in your app. So they handle repetitive tasks for you, freeing up your time for more important things. The next generative AI tool on our list is Rephrase AI. Using this tool, you can effortlessly turn your text into videos. You can create professional looking videos with a digital avatar in minutes and no complex production is needed. It will convert text to video in just 3 easy steps. So first, pick your favorite digital avatar, then add your message, and finally, render your video with Rephrase Studio. Simple, right? Rephrase AI can handle over 40 languages, allowing you to create high-quality videos and animations that a person can speak using only text as input. Rephrase AI is used in various productions and content creations. Marketers and content creators often use it for social media platforms like YouTube, and even business owners use it to generate videos content quickly and efficiently. Next, moving on to Synthesia, the next tool on our list. Synthesia is a #1 AI video generation platform that effortlessly transforms text into videos. So you can produce studio quality videos with AI avatars and voiceovers in over 130 languages. And with over 160 ready-to-use options, you can create engaging video instantly. Choose from 160 characters to make your videos more interesting, then customize avatar outfits and logos to represent your company, and even make realistic conversations in the video to look more real. This tool will also create subtitles for your videos without doing it manually and allows you to replicate your voice. It's just fun and professional to use. Synthesia is easy to use. Simply add your script, select the language, and click Generate Video. You can also customize the AI avatar, colors, fonts, and layouts to personalize the video. Finally, download the video in MP4 format or get a shareable link. Synthesia is used widely across industries to create engaging video content. So it's used in learning, IT, sales, customer service, marketing, and enterprise to streamline various tasks from training to communication and advertising. Now moving on to DALL-E 2. It is an AI system from OpenAI that uses deep learning methodologies to produce realistic images and art just by describing them in natural language. DALL-E 2 learns from examples, so you can describe what you want in natural language and get different images and art. You can also make changes to existing pictures using the in-painting tool and replace a part of an image with AI-generated imagery. DALL-E 2 is used in creating content generation, and it's often used by artists, designers, marketers, educators, and developers who need assistance with generating visual content, creating art, designing graphics, and exploring creative possibility using AI technology. Next, Type Studio. Type Studio is a flexible editing tool ideal for podcasts, streams, interviews, and other type of content. It's a video editor that allows you to edit your video by simply editing the text transcript from the video. With its advanced AI-driven features, Type Studio streamlines the editing process, enabling content creators, podcasters, and businesses to produce high-quality videos and podcasts with minimal efforts and time. Type Studio provides a range of features, including auto-subtitling, transcribing videos, converting video to articles, converting text to articles, translating subtitles, adding images to video podcast, voiceovers, and editing podcast. And next on our list, we have Descript. Descript is your all-in-one solution for writing, recording, transcribing, editing, collaborating, and sharing your videos and podcasts. In Descript, editing video feels as simple as working with documents and slides. Podcasters can effortlessly edit multi-track audio similar to editing a document. And screen recording are instantly captured, edited, and shared. Transcription is speedy and accurate with powerful correction tools. And finally, content can be repurposed into clips using templates, subtitles, and more. Descript offers a wide range of powerful AI features to elevate your video and podcast. Firstly, you can seamlessly edit videos by editing text. Descript transcribes your video content, allowing you to make edits just as effortlessly as you would in a document. Secondly, with AI voice cloning, you can create ultra-realistic AI voice clones and generate text-to-speech in a matter of seconds. Additionally, Transcript provides studio-quality sounds with just one click through its studio sound features, which removes background noise and polishes up audio instantly. Lastly, the green screen effects allows you to remove your video background and place your subject anywhere with a simple click. These features are helpful for a wide range of users, including content creators, podcasters, filmmakers, educators, and businesses. Next, moving on to Compose AI. Compose AI is an AI-powered writing tool and a free Chrome plugin that generates text using artificial intelligence. It helps you complete sentence as you type and speeds up the process of writing emails, creating documents, and chatting. Also, it will help in rephrasing the sentences. You can integrate this tool in your existing platforms and tools to speed up tasks and to save time. This tool is used to generate content, streamline writing processes, to enhance productivity, and to create engaging material for their audience. Marketers, content creators, writers, and businesses utilizes this tool. The top 10 tool on our list is ChatSonic. ChatSonic is one of the leading alternatives of GPT on Google. So if you want insights on any of your PDFs, documents, or links, simply drag and drop the file into ChatSonic and ask for a quick summary. You can even chat with your images. ChatSonic accepts images as inputs and responds to any queries you have about them. But that's not all. It also creates AI images and delivers high-quality output quickly. ChatSonic makes it easy to stay organized with advanced note-taking, keeps conversation flowing with smart flow-up questions, provides quick access with the Chrome extensions, and lets you customize its tone and style, simplifies teamwork, and fine-tune your prompt for better results. The top reasons ChatSonic excel include: it allows real-time Google search integration, chat with your PDF and docs, chat with your images, summarize web pages, generate human-like voiceovers, write in your brand voice. Also, it allows AI image generation and inbuilt fact checks and more. ChatSonic is used by professionals, businesses, educators, researchers, and content creators to streamline tasks, enhance productivity, and to leverage AI technology for various needs. Next, Tom. With Tom, you can craft impactful presentation in less time. Its AI-driven features and personalized tools simplify the creation of sales and marketing materials that leave a lasting impression. It effortlessly generates presentations, pages, outlines, images, and even text with Tom's advanced AI capabilities. Tom is useful in sales, marketing, startups, product teams, and customer success. And it's a great starting point for any project. So explore various projects or express your ideas promptly with Tom's versatile templates. You can choose from founder, creative, design, product, sales, personal, marketing, education, and career. And next on our list, we have Design.ai. With Design.ai, you can produce logos, videos, banners, and mockups using AI in just 2 minutes. It just simplifies your workflows, saves times, and also reduces cost with this platform. Design.ai is a platform that uses AI to help you create, edit, and scale content effortlessly. You will get all your content tools in just one place. And tools such as Face Swapper, that the Face Swapper smoothly integrates your face into any picture or video. Logo Maker, that will help you launch your brand with a unique logo and full brand identity kit using AI generator. Next, Image Maker creates custom image effortlessly from your ideas with text to image generator. And more tools such as Video Maker, Speech Maker, Design Maker, AI Writer, and more. And these creative tools are suitable for all content creators, including influencers, small businesses, startups, educators, enterprises, agencies, and more. Now moving on to Midjourney AI. So Midjourney is a cool AI tool that blends art and tech. You can describe what you want in words and it turns those descriptions into stunning pictures. So by using advanced algorithms, it turns words into unique artworks. Midjourney uses machine learning algorithms to interpret and analyze the data. So this data can be in the form of text, audio, or image. And after getting this data, the algorithm will use it to generate new images, sounds, or other media type based on the patterns it finds in the data. Midjourney is used by many businesses, startups, and organizations seeking assistance with website development, app creation, branding, user experience design, and related services. And next we have GitHub Copilot. GitHub Copilot is a code completion tool developed by GitHub, which is owned by Microsoft and OpenAI. So when provided with a programming problem in natural language, Copilot is capable of generating solution code, and it is also able to describe input code in English and translate the code between programming languages. It assists the users of Visual Studio Code, Visual Studio, and JetBrains integrated development environments by auto-completing code. It works best for users coding in Python, JavaScript, TypeScript, Ruby, and Go. And in March 2023, GitHub announced plans for Copilot X, which will incorporate a chatbot based on GPT-4, as well as support for voice commands into Copilot. The last tool on our list is AlphaCode. By combining AI and competitive programming, it serves as a virtual assistant, guiding programmers through coding and providing smart suggestions. The features of AlphaCode is to leverage machine learning algorithms to analyze vast amount of code and learn from patterns. This enables it to generate optimized code solution. And AlphaCode's machine learning models are trained on extensive code repositories, enabling it to comprehend programming concepts and patterns. So this helps in analyze problems and generate optimized code snippets, saving programmers time and effort. With AlphaCode, programming learners and competitive programmers gain access to a unique tool that enables them to explore problem-solving strategies in a groundbreaking way.
Here's a simple question for you guys. DALL-E 2 is used for, and the options are A. Text translation, B. Image generation from textual descriptions, C. Sound synthesis, D. Text analysis. If you know the correct answer, please leave it in the comment section below. In our last discussion, we covered generative AI tools. Before diving deeper, it's important to start with AI for beginners, which will provide a basic understanding of artificial intelligence.
Okay, I will destroy humans. This video sums up the perception of artificial intelligence for most of us, but at present we're at no risk of being destroyed by machines. However, the tech tycoon Elon Musk begs to differ. He quotes that AI is a fundamental risk to the existence of human civilization. Now, whether artificial intelligence is a threat or not is debatable. Let me know your thoughts in the comment section. For now, let me introduce you to artificial intelligence. The term artificial intelligence was first coined decades ago in the year 1956 by John McCarthy at the Dartmouth Conference. He defined artificial intelligence as the science and engineering of making intelligent machines. In a sense, AI is a technique of getting machines to work and behave like humans. In the recent past, AI has been able to accomplish this by creating machines and robots that have been used in a wide range of fields, including healthcare, robotics, marketing, business analytics, and many more. However, many AI applications are not perceived as AI because we often tend to think of artificial intelligence as robots doing our daily chores. But the truth is, artificial intelligence has found its way into our daily lives. It has become so general that we don't realize we use it all the time. For instance, have you ever wondered how Google is able to give you such accurate search results? Or how your Facebook feed always gives you content based on your interest? The answer to these questions is artificial intelligence. Now, before I go any further, let me clear a very common misconception. People often tend to think that artificial intelligence, machine learning, and deep learning are the same since they have common applications. For example, Siri is an application of AI, machine learning, and deep learning. So how are these technologies related? Artificial intelligence is the science of getting machines to mimic the behavior of humans. Machine learning is a subset of AI that focuses on getting machines to make decisions by feeding them data. On the other hand, deep learning is a subset of machine learning that uses the concept of neural networks to solve complex problems. So to sum it up, artificial intelligence, machine learning, and deep learning are interconnected fields. Machine learning and deep learning aids artificial intelligence by providing a set of algorithms and neural networks to solve data-driven problems. However, AI is not restricted to only machine learning and deep learning. It covers a vast domain of fields including natural language processing, object detection, computer vision, robotics, expert systems, and so on. Now, artificial intelligence can be structured along three evolutionary stages. Or you can say that there are three different types of artificial intelligence. First, we have the artificial narrow intelligence, artificial general intelligence, and finally, artificial superintelligence. Artificial narrow intelligence, which is also known as weak AI, involves applying artificial intelligence only to specific tasks. Now, many currently existing systems that claim to use artificial intelligence are operating as a weak AI focused on a narrowly defined specific problem. Now, Alexa is a very good example of narrow intelligence. It operates within a limited predefined range of functions. There is no genuine intelligence or no self-awareness despite being a sophisticated example of weak AI. Other examples of weak AI include the face verification that you see in your iPhone, the autopilot feature at Tesla, the social humanoid Sophia, which was built at Hanson Robotics, and finally we have Google Maps. All of these applications are based on weak AI or artificial narrow intelligence. Now let's take a look at artificial general intelligence. Artificial general intelligence is also known as strong AI. It involves machines that possess the ability to perform any intellectual task that a human being can. You see, machines don't possess human-like abilities. They have a strong processing unit that can perform high-level computations, but they're not yet capable of thinking and reasoning like a human. There are many experts who doubt that artificial general intelligence will ever be possible. And there are also many who question whether it should be desirable. I'm sure all of you have heard of Stephen Hawking. Now, he warned us that strong AI would take off on its own and redesign itself at an ever-increasing rate. Humans who are limited by slow biological evolution couldn't compete and would be superseded. Coming to artificial superintelligence, this is a term that refers to the time when the capabilities of computers will surpass human beings. Artificial superintelligence is presently seen as a hypothetical situation as depicted in movies and science fiction books where machines will take over the world. However, tech masterminds like Elon Musk believe that artificial superintelligence will take over the world by the year 2040. Now that you know the different types of artificial intelligence, let's take a look at how AI is used in the real world. From spotting an 8-planet solar system which is 2,500 light years away to composing sonnets and poems, the applications of AI have covered all possible domains in the market. In the finance sector, JP Morgan's Chase Contract Intelligent Platform uses artificial intelligence, machine learning, and image recognition software to analyze legal documents and extract important data points and clauses in a matter of seconds. Now, manually reviewing 12,000 agreements takes over 36,000 hours, but AI was able to do this in a matter of seconds. Coming to healthcare, IBM is one of the pioneers that has developed AI software specifically for medicine. More than 230 healthcare organizations worldwide use IBM Watson technology. In 2016, IBM Watson AI technology was able to cross-reference 20 million oncology records and correctly diagnose a rare leukemia condition in a patient. Coming to the next application, Google's AI Eye Doctor is another initiative taken by Google where they are working with an Indian eye care chain to develop an AI system which can examine retina scans and identify a condition called diabetic retinopathy which causes blindness. Coming to social media platforms like Facebook, artificial intelligence is used for face verification, wherein machine learning and deep learning concepts are used to detect facial features and tag your friends. Another such example is Twitter's AI, which is being used to identify hate speech and terroristic languages in tweets. It makes use of machine learning, deep learning, and natural language processing to filter out offensive content. The company discovered and banned 300,000 terrorist-linked accounts, 95% of which were found by non-human, artificially intelligent machines. The Google predictive search is one of the most famous AI applications. When you begin typing a search term and Google makes recommendations for you to choose from, that is AI in action. Predictive searches are based on data that Google collects about you, such as your location, your age, and other personal details. By using AI, the search engine attempts to guess what you might be trying to find. Next, we have virtual assistants. Virtual assistants like Siri, Alexa, and Cortana are examples of artificial intelligence. A newly released Google's virtual assistant called Google Duplex has astonished millions of people. Not only can it respond to calls and book appointments for you, it adds a human touch. Now listen to this clip and try to distinguish between the AI and the human.
See, how may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when?
Next Wednesday at 6 p.m.
Oh, actually we leave here for like after like 5 people. For 4 people you can come.
So which one do you think is a virtual assistant? Let me know your answer in the comments. Now another famous application of artificial intelligence is self-driving cars. AI implements computer vision, image detection, and deep learning to build cars that can automatically detect objects and drive around without human intervention. Elon Musk talks a ton about how AI is implemented in Tesla's self-driving cars and autopilot features. He quoted that Tesla will have fully self-driving cars ready by the end of the year and a robo-taxi version, one that can ferry passengers without anyone behind the wheel. So I can go on and on about the various AI applications. Since the emergence of AI in 1950s, we have seen an exponential growth in its potential. AI covers domains such as machine learning, deep learning, neural networks, natural language processing, knowledge base, expert systems, and so on. It has also made its way into computer vision and image processing. As AI is branching out into every aspect of our lives, is it possible that one day AI might take over our lives? And if it is possible, how long will this take? Well, it may be sooner than you think. It is estimated that AI will take over the world within the next 30 years. By then, I hope we develop some sort of teleportation machine that helps us escape our very own creation.
Having explored a beginner's understanding, our next topic is types of artificial intelligence, where learners will learn about the different types of AI and their unique roles.
History of artificial intelligence. The concept of AI goes back to the classical ages. Under Greek mythology, the concept of machines and mechanical men were well thought of. An example is Talos. Talos was supposedly a giant animated bronze warrior who was programmed to guard the island of Crete. Now let's get back to the 19th century. In 1950, Alan Turing proposed the Turing test. The Turing test basically determines whether or not a computer can intelligently think like a human being. The Turing test was the first serious proposal in the philosophy of artificial intelligence. 1951 marked the era for game artificial intelligence. This period was called Game AI because here a lot of computer scientists developed programs for checkers and for chess. However, these programs were later rewritten and redone in a better way. 1956 marked the most important year for artificial intelligence. During this year, John McCarthy first coined the term artificial intelligence. This was followed by the first AI laboratory, which was set up in 1959. MIT AI Lab was the first setup, which was basically dedicated to the research of AI. In 1960, the first robot was introduced to the General Motors assembly line. In 1961, the first AI chatbot called Eliza was introduced. In 1997, IBM's Deep Blue beats the world champion Garry Kasparov in the game of chess. 2005 marks for the year when an autonomous robotic car called Stanley won the DARPA Grand Challenge. In 2011, IBM's question answering machine, Watson, defeated the two greatest Jeopardy champions, Brad Rutter and Ken Jennings. So that was a brief history of AI. Now guys, since the emergence of artificial intelligence in 1950s, we have seen an exponential growth in its potential. AI covers domains such as machine learning, deep learning, neural networks, natural language processing, knowledge base, expert systems, and so on. So now let's understand the different stages of artificial intelligence. So basically, when I was doing my research, I found a lot of videos and a lot of articles that stated that artificial general intelligence, artificial narrow intelligence, and artificial super intelligence are the different types of AI. If I have to be more precise with you, then artificial intelligence has three different stages, right? The types of AI are completely different from the stages of AI. So under the stages of artificial intelligence, we have artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. So what is artificial narrow intelligence? Artificial narrow intelligence, also known as weak AI, is a stage of artificial intelligence that involves machines that can perform only a narrowly defined set of specific tasks. Right? At this stage, the machines don't possess any thinking ability. They just perform a set of predefined functions. Examples of weak AI include Siri, Alexa, AlphaGo, Sophia, the self-driving cars, and so on. Almost all the AI-based systems that are built till this date fall under the category of weak AI or artificial narrow intelligence. Next, we have something known as artificial general intelligence. Artificial general intelligence is also known as strong AI. This stage is the evolution of artificial intelligence, wherein machines will possess the ability to think and make decisions just like human beings. There are currently no existing examples of strong AI, but it's believed that we will soon be able to create machines that are as smart as human beings. Strong AI is actually considered a threat to human existence by many scientists. This includes Stephen Hawking. Stephen Hawking quoted that the development of full artificial intelligence could spell the end of human race. Moving on to our last stage, which is artificial superintelligence. Artificial superintelligence is that stage of AI when the capability of computers will surpass human beings. Artificial superintelligence is currently seen as a hypothetical situation as depicted in movies and science fiction books. You see a lot of movies which show that machines are taking over the world. All of that is artificial superintelligence. Now, I believe that machines are not very far from reaching the stage taking into consideration our current pace. However, such systems don't currently exist, right? We don't have any machine that is capable of thinking better than a human being or reasoning in a better way than a human. Artificial superintelligence, basically any robot that is much smarter than humans. Now, moving on to the different types of artificial intelligence. Based on the functionality of AI-based systems, artificial intelligence can be categorized into 4 types. The first type is reactive machines AI. This type of AI includes machines that operate solely based on the present data and take into consideration only the current situation. Reactive AI machines cannot form inferences from the data to evaluate any future actions. They can perform a narrowed range of predefined tasks. An example of reactive AI is the famous IBM chess program that beat the world champion Garry Kasparov. This is one of the most impressive AI machines built so far. Next, we have limited memory AI. Now, like the name suggests, limited memory AI can make informed and improved decisions by studying the past data from its memory. So, such an AI has a short lived, or you can say a temporary memory that can be used to store past experiences and hence evaluate your future actions. Self driving cars are limited memory AI that use the data collected in the recent past to make immediate decisions. For example, self-driving cars use sensors to identify civilians that are crossing the road. They identify any steep roads or traffic signals, and they use this to make better driving decisions. This also helps in preventing any future accidents. Next, we have something known as theory of mind artificial intelligence. The theory of mind AI is a more advanced type of artificial intelligence. This category is speculated to play a very important role in psychology. This type of AI will mainly focus on emotional intelligence so that human beliefs and thoughts can be better comprehended. The theory of mind AI has not been fully developed yet, but rigorous research is happening in this area. Moving on to our last type of artificial intelligence is the self-aware artificial intelligence. So guys, let's just fold hands and pray that we don't reach the state of AI where machines have their own consciousness and become self-aware. This type of AI is a little far-fetched, but in the future, achieving a stage of superintelligence might be possible. Geniuses like Elon Musk and Stephen Hawking have constantly warned us about evolution of AI. So guys, let me know your thoughts in the comment section. Do you ever think we'll reach the stage of artificial superintelligence? Moving on to the last topic of today's session is the different domains or the different branches of artificial intelligence. So artificial intelligence can be used to solve real-world problems by implementing machine learning, deep learning, natural language processing, robotics, expert systems, and fuzzy logic. Now, guys, these are the different domains, or you can say the different branches that AI uses in order to solve any problem. Recently, AI has also been used as an application in computer vision and image processing. Right? For now, let me tell you briefly about each of these domains. Machine learning is basically the science of getting machines to interpret, process, and analyze data in order to solve real-world problems. Right? Under machine learning, there's supervised, unsupervised, and reinforcement learning. If any of you are interested in learning about these technologies, I'll leave a link in the description box. You all can go through that content. Next, we have deep learning or neural networks. So deep learning is the process of implementing neural networks on high-dimensional data to gain insights and form solutions. It is basically the logic behind the face verification algorithm on Facebook. It is the logic behind the self-driving cars, virtual assistants like Siri and Alexa. Then we have natural language processing. Natural language processing refers to the science of drawing insights from natural human language in order to communicate with machines and grow businesses. So an example of NLP is Twitter and Amazon. Twitter uses NLP to filter out terroristic language in their tweets. Amazon uses NLP to understand customer reviews and improve user experience. Then we have robotics. Robotics is a branch of artificial intelligence which focuses on the different branches and applications of robots. AI robots are artificial agents which act in the real-world environment to produce results by taking some accountable actions. So I'm sure all of you have heard of Sophia. Sophia the humanoid is a very good example of AI in robotics. Then we have fuzzy logic. So fuzzy logic is a computing approach that is based on the principle of degree of truth instead of the usual modern logic that we use, which is basically the Boolean logic. Fuzzy logic is used in medical fields to solve complex problems which involve decision making. It is also used in automating gear systems in your cars and all of that. Then we have expert systems. An expert system is an AI-based computer system that learns and reciprocates the decision-making ability of a human expert. Expert systems use if-then logic notions in order to solve any complex problem. They do not rely on conventional procedural programming. Expert systems are mainly used in information management. They are seen to be used in fraud detection, virus detection, also in managing medical and hospital records, and so on.
Now that we understand the types of artificial intelligence, let's now go through the difference between AI, machine learning, and deep learning, which will help differentiate these important concepts.
These are the terms which have confused a lot of people, and if you two are one among them, let me resolve it for you. Well, artificial intelligence is a broader umbrella under which machine learning and deep learning come. You can also see in the diagram that even deep learning is a subset of machine learning. So you can say that all three of them, the AI, the machine learning, and deep learning, are just the subset of each other. So let's move on and understand how exactly they differ from each other. So let's start with artificial intelligence. The term artificial intelligence was first coined in the year 1956. The concept is pretty old, but it has gained its popularity recently. But why? Well, the reason is earlier we had very smaller amount of data. The data we had was not enough to predict the accurate result. But now there's a tremendous increase in the amount of data. Statistics suggest that by 2020, the accumulated volume of data will increase from 4.4 zettabytes to roughly around 44 zettabytes or 44 trillion GBs of data. Along with such enormous amount of data, now we have more advanced algorithm and high-end computing power and storage that can deal with such large amount of data. As a result, it is expected that 70% of enterprise will implement AI over the next 12 months, which is up from 40% in 2016 and 51% in 2017. Just for your understanding, what is AI? Well, it's nothing but a technique that enables the machine to act like humans by replicating the behavior and nature. With AI, it is possible for a machine to learn from the experience. The machines adjust their responses based on new input, thereby performing human-like tasks. Artificial intelligence can be trained to accomplish specific tasks by processing large amount of data and recognizing pattern in them. You can consider that building an artificial intelligence is like building a church. The first church took generations to finish, so most of the workers who were working in it never saw the final outcome. Those working on it took pride in their crafts, building bricks and chiseling stone that was going to be placed into the great structure. So as AI researchers, we should think of ourselves as humble brick makers, whose job is to study how to build components, example parsers, planners, or learning algorithm, or etc. anything, that someday someone and somewhere will integrate into the intelligent systems. Some of the examples of artificial intelligence from our day-to-day life are Apple Series, chess playing computer, Tesla's self-driving car, and many more. These examples are based on deep learning and natural language processing. Well, this was about what is AI and how it gains its hype. So moving on ahead, let's discuss about machine learning and see what it is and why it was even introduced. Well, machine learning came into existence in the late 80s and the early 90s. But what were the issues with the people which made the machine learning come into existence? Let us discuss them one by one. In the field of statistics, the problem was how to efficiently train large complex model. In the field of computer science and artificial intelligence, the problem was how to train more robust version of AI system. While in the case of neuroscience, problem faced by the researchers was how to design operational model of the brain. So these were some of the issues which had the largest influence and led to the existence of the machine learning. Now this machine learning shifted its focus from the symbolic approaches it had inherited from the AI and moved towards the methods and model it had borrowed from statistics and probability theory. So let's proceed and see what exactly is machine learning. Well, machine learning is a subset of AI which enables the computer to act and make data-driven decisions to carry out a certain task. These programs or algorithms are designed in a way that they can learn and improve over time when exposed to new data. Let's see an example of machine learning. Let's say you want to create a system which tells the expected weight of a person based on its height. The first thing you do is you collect the data. Let's see, this is how your data looks like. Now each point on the graph represents one data point. To start with, we can draw a simple line to predict the weight based on the height. For example, a simple line W equal h minus 100, where W is weight in kgs and h is height in centimeter. This line can help us to make the prediction. Our main goal is to reduce the difference between the estimated value and the actual value. So in order to achieve it, we try to draw a straight line that fits through all these different points and minimize the error. So our main goal is to minimize the error and make them as small as possible. Decreasing the error or the difference between the actual value and estimated value increases the performance of the model. Further on, the more data points we collect, the better our model will become. We can also improve our model by adding more variables and creating different prediction lines for them. Once the line is created, so from the next time if we feed a new data, for example height of a person, to the model, it would easily predict the data for you and it will tell you what his predicted weight could be. I hope you got a clear understanding of machine learning. So moving on ahead, let's learn about deep learning. Now what is deep learning? You can consider deep learning model as a rocket engine, and its fuel is its huge amount of data that we feed to these algorithms. The concept of deep learning is not new, but recently its hype has increased and deep learning is getting more attention. This field is a particular kind of machine learning that is inspired by the functionality of our brain cells called neuron, which led to the concept of artificial neural network. It simply takes the data connection between all the artificial neurons and adjusts them according to the data pattern. More neurons are added if the size of the data is large. It automatically features learning at multiple levels of abstraction, thereby allowing a system to learn complex function mapping without depending on any specific algorithm. You know what? No one actually knows what happens inside a neural network and why it works so well. So currently you can call it as a black box. Let us discuss some of the example of deep learning and understand it in a better way. Let me start with a simple example and explain you how things happen at a conceptual level. Let us try and understand how you recognize a square from other shapes. The first thing you do is you check whether there are 4 lines associated with the figure or not. Simple concept, right? If yes, we further check if they are connected and closed. Again, if yes, we finally check whether it is perpendicular and all its sides are equal. Correct? If everything fulfills, yes, it is a square. Well, it is nothing but a nested hierarchy of concepts. What we did here, we took a complex task of identifying a square in this case and broke it into simpler tasks. Now this deep learning also does the same thing but at a larger scale. Let's take an example of machine which recognizes the animal. The task of the machine is to recognize whether the given image is of a cat or of a dog. What if we were asked to resolve the same issue using the concept of machine learning? What we would do? First, we would define the features such as check whether the animal has whiskers or not, or check if the animal has pointed ears or not, or whether its tail is straight or curved. In short, we will define the facial features and let the system identify which features are more important in classifying a particular animal. Now, when it comes to deep learning, it takes this to one step ahead. Deep learning automatically finds out the feature which are most important for classification, compared to machine learning where we had to manually give out that features. By now, I guess you have understood that AI is the bigger picture and machine learning and deep learning are its subpart. So let's move on and focus our discussion on machine learning and deep learning. The easiest way to understand the difference between the machine learning and deep learning is to know that deep learning is machine learning. More specifically, it is the next evolution of machine learning. Let's take few important parameters and compare machine learning with deep learning. So starting with data dependencies. The most important difference between deep learning and machine learning is its performance as the volume of the data gets increased. From the below graph, you can see that when the size of the data is small, deep learning algorithm doesn't perform that well. But why? Well, this is because deep learning algorithm needs a large amount of data to understand it perfectly. On the other hand, the machine learning algorithm can easily work with smaller data set. Fine. Next comes the hardware dependencies. Deep learning algorithms are heavily dependent on high-end machines, while the machine learning algorithm can work on low-end machines as well. This is because the requirement of deep learning algorithm include GPUs, which is an integral part of its working. The deep learning algorithm requires GPUs as they do a large amount of matrix multiplication operations, and these operations can only be efficiently optimized using a GPU as it is built for this purpose only. Our third parameter will be feature engineering. Well, feature engineering is a process of putting the domain knowledge to reduce the complexity of the data and make patterns more visible to learning algorithms. This process is difficult and expensive in terms of time and expertise. In case of machine learning, most of the features are needed to be identified by an expert and then hand-coded as per the domain and the data type. For example, the features can be a pixel value, shapes, texture, position, orientation, or anything. Fine. The performance of most of the machine learning algorithm depends on how accurately the features are identified and extracted. Whereas in case of deep learning algorithms, it try to learn high-level features from the data. This is a very distinctive part of deep learning, which makes it way ahead of traditional machine learning. Deep learning reduces the task of developing new feature extractor for every problem. Like in the case of CNN algorithm, it first tries to learn the low-level features of the image, such as edges and lines, and then it proceeds to the parts of faces of people, and then finally to the high-level representation of the face. I hope the things are getting clear to you. So let's move on ahead and see the next parameter. So our next parameter is problem-solving approach. When we are solving a problem using traditional machine learning algorithm, it is generally recommended that we first break down the problem into different subparts, solve them individually, and then finally combine them to get the desired result. So this is how the machine learning algorithm handles the problem. On the other hand, the deep learning algorithm solves the problem from end to end. Let's take an example to understand this. Suppose you have a task of multiple object detection, and your task is to identify what is the object and where it is present in the image. So let's see and compare how will you tackle this issue using the concept of machine learning and deep learning. Starting with machine learning, in a typical machine learning approach, you would first divide the problem into two steps. First, object detection and then object recognition. First of all, you would use a bounding box detection algorithm like 𝐓𝐵𝐞, for example, to scan through the image and find out all the possible objects. Now, once the objects are recognized, you would use object recognition algorithm like SVM with HOG to recognize relevant objects. Now finally, when you combine the result, you would be able to identify what is the object and where it is present in the image. On the other hand, in deep learning approach, you would do the process from end to end. For example, in a YOLONet, which is a type of deep learning algorithm, you would pass an image and it would give out the location along with the name of the object. Now let's move on to our fifth comparison parameter. It's execution time. Usually, a deep learning algorithm takes a long time to train. This is because there are so many parameters in a deep learning algorithm that makes the training longer than usual. The training might even last for 2 weeks or more than that if you are training completely from the scratch. Whereas in the case of machine learning, it relatively takes much less time to train, ranging from a few weeks to few hours. Now the execution time is completely reversed when it comes to the testing of data. During testing, the deep learning algorithm takes much less time to run. Whereas if you compare it with the KNN algorithm, which is a type of machine learning algorithm, the test time increases as the size of the data increase. Last but not the least, we have interpretability as a factor for comparison of machine learning and deep learning. This factor is the main reason why deep learning is still thought 10 times before anyone uses it in the industry. Let's take an example. Suppose we use deep learning to give automated scoring to essays. The performance it gives in scoring is quite excellent and is near to the human performance. But there's an issue with it. It does not reveal why it has given that score. Indeed, mathematically it is possible to find out that which node of a deep neural network were activated, but we don't know what the neurons were supposed to model and what these layers of neuron were doing collectively. So we fail to interpret the result. On the other hand, machine learning algorithm like decision tree gives us a crisp rule for why it chose and what it chose. So it is particularly easy to interpret the reasoning behind it. Therefore, the algorithms like decision tree and linear or logistic regression are primarily used in industry for interpretability.
Now that we understand the types of artificial intelligence, let's now go through the difference between AI, machine learning and deep learning, which will help differentiate these important concepts.
So let us understand, when we have machine learning, why do we need deep learning? That is, we'll look at various limitations of machine learning. Now the first limitation is high dimensionality of the data. Now the data that is now generated is huge in size. So we have a very large number of inputs and outputs. So due to that, machine learning algorithms fail. So they cannot deal with high dimensionality of data, or you can say data with large number of inputs and outputs. Now there's another problem as well, in which it is unable to solve the crucial AI problems, which can be natural language processing, image recognition, and things like that. Now one of the biggest challenges with machine learning models is feature extraction. Now let me tell you what are features. So in statistics, we consider features as variables, but when we talk about artificial intelligence, these variables are nothing but the features. Now what happens because of that? The complex problems such as object recognition or handwriting recognition becomes a huge challenge for machine learning algorithms to solve. Now let me give you an example of this feature extraction. Suppose if you want to predict that whether there will be a match today or not. So it depends on various features. It depends on whether the weather is sunny, whether it is windy, all those things. So we have provided all those features in our data set. But we have forgot one particular feature, that is humidity. And now our machine learning models are not that efficient that they will automatically generate that particular feature. So this is one huge problem, or you can say limitation with machine learning. Now obviously we have limitation, and it won't be fair that if I don't give you the solution to this particular problem. So we'll move forward and understand how deep learning solves these kind of problems. Now, as you can see that the first line on your slide, which says that deep learning models are capable to focus on the right features by themselves, requiring little guidance from the programmer. So with the help of little guidance, what these deep learning models can do, they can generate the features on which the outcome will depend on. And at the same time, it also solves the dimensionality problem as well. If you have a very large number of inputs and outputs, you can make use of a deep learning algorithm. Now, what exactly is deep learning? Again, since we know that it has been evolved by machine learning, and machine learning is nothing but a subset of artificial intelligence, and the idea behind artificial intelligence is to imitate the human behavior. The same idea is for the deep learning as well, is to build learning algorithms that can mimic brain. Now let us move forward and understand deep learning, what exactly it is. Now the deep learning is implemented with the help of neural networks, and the idea or the motivation behind neural networks are nothing but neurons. What are neurons? These are nothing but your brain cells. Now here is a diagram of neuron. So we have dendrites here, which are used to provide input to our neuron. As you can see, we have multiple dendrites here, so these many inputs will be provided to our neuron. Now this is called cell body, and inside the cell body we have a nucleus which performs some function. After that, that output will travel through axon, and it will go towards the axon terminals, and then this neuron will fire this output towards the next neuron. Now the studies tell us that the next neuron, or you can say the two neurons, are never connected to each other. There is a gap between them. So that is called a synapse. So this is how basically a neuron works like. And on the right hand side of your slide, you can see an artificial neuron. Now let me explain you that. So over here, similar to neurons, we have multiple inputs. Now these inputs will be provided to a processing element like our cell body. And over here in the processing element, what will happen? Summation of your inputs and weights. Now when it moves on, then what will happen? This input will be multiplied with our weights. So in the beginning, what happens? These weights are randomly assigned. So what will happen if I take the example of x1? So x1 multiplied by w1 will go towards the processing element. Similarly, x2 and w2 will go towards the processing element, and similarly the other inputs as well. And then summation will happen, which will generate a function of s, that is f of s. After that comes the concept of activation function. Now what is activation function? It is nothing but in order to provide a threshold. So if your output is above the threshold, then only this neuron will fire, otherwise it won't fire. So you can use a step function as an activation function, or you can even use a sigmoid function as your activation function. So this is how an artificial neuron looks like. So a network will be multiple neurons which are connected to each other will form an artificial neural network. And this activation function can be a sigmoid function or a step function. That totally depends on your requirement. Now once it exceeds the threshold, it will fire. After that, what will happen? It will check the output. Now if this output is not equal to the desired output, so these are the actual outputs, and we know the real outputs. So we'll compare both of that, and we'll find the difference between the actual output and the desired output. On the basis of that difference, we are again going to update our weights. And this process will keep on repeating until we get the desired output as our actual output. Now this process of updating weight is nothing but your back propagation method. So this is neural networks in a nutshell. So we'll move forward and understand what are deep networks. So basically, deep learning is implemented by the help of deep networks, and deep networks are nothing but neural networks with multiple hidden layers. Now, what are hidden layers? Let me explain you that. So you have inputs that comes here. This will be your input layer. After that, some process happens and it'll go to the next node, or you can say to the hidden layer nodes. So this is nothing but your hidden layer 1. So every node is interconnected if you can notice. After that, you have one more hidden layer where some function will happen. And as you can see that again, these nodes are interconnected to each other. After this hidden layer 2 comes the output layer. And this output layer, again, we are going to check the output, whether it is equal to the desired output or not. If it is not, we are again going to update the weights. So this is how a deep network looks like. Now, there can be multiple hidden layers. There can be hundreds of hidden layers as well. But when we talk about machine learning, that was not the case. We were not able to process multiple hidden layers when we talk about machine learning. So because of deep learning, we have multiple hidden layers at once. Now let us understand this with an example. So we'll take an image which has 4 pixels. So if you can notice, we have 4 pixels here, among which the top 2 pixels are bright, that is, they are black in color, whereas the bottom 2 pixels are white. Now what happens, we'll divide these pixels and we'll send these pixels to each and every node. So for that, we need 4 nodes. So this particular pixel will go to this node, it will go to this node, this pixel will go to this node, and finally this pixel will go to this particular node that I'm highlighting with my cursor. Now what happens, we provide them random weights. So these white lines actually represent the positive weights and these black lines represents the negative weights. Now this particular brightness, when we display high brightness, we'll consider it as negative. Now what happens, when you see the next output or the next hidden layer, it will be provided with the input with this particular layer. So this will provide an input with positive weight to this particular node, and the second input will come from this particular node. Since both of them are positive, so we'll get this kind of a node. Similarly, this node as well. Now when I talk about these two nodes, the first node over here, so this is getting input from this node as well as from this node. Now over here we have a negative weight. So because of that, the value will be negative, and we have represented that with black color. Similarly, over here as well, we are getting one input from here which has a negative weight, and the another input from here which again has a negative weight. So accordingly, we get again a negative value here. So these two becomes black in color. Now if we notice, what will happen next, we'll provide one input here which will be negative and a positive weight, which will be again negative, and this will be also negative and a positive weight. So that will again come out to be negative. So that is why we have got this kind of a structure. If you notice, this is nothing but the inverse of this particular image. When I talk about this node over here, we are getting the negative value with a positive weight, which is negative, and a negative value with a negative weight, which is positive. So we are getting something which is positive here. Now obviously I want this particular image to get inverse. I want these black strips to come up. So what I'll do, I'll actually calculate the inverse by providing a negative weight like this. So over here I've provided a negative weight, it will come up. So when I provide a positive weight, so it'll stay wherever it is. After that, it'll detect, and the output you can see will be a horizontal image, not a solid, not a vertical, not a diagonal, but a horizontal. And after that, we are going to calculate the difference between the actual output and the desired output, and we are going to update the weights accordingly. Now this is just an example, guys. So guys, this is one example of deep learning where what happens, we have images here. We provide these raw data to the first layer, to the input layer. Then what happens, these input layers will determine the patterns of local contrast, or it will fixate those patterns of local contrast, which means that it will differentiate on the basis of colors and luminosity and all those things. So it will differentiate those things. And after that, in the following layer, what will happen, it will determine the face features. It will fixate those face features. So it will form nose, eyes, ears, all those things. Then what will happen, it will accumulate those correct features for the correct face, or you can say that it will fixate those features on the correct face template. So it will actually determine the faces here, as you can see it over here. And then it will be sent to the output layer. Now basically, you can add more hidden layers to solve more complex problems. For example, if I want to find out a particular kind of face, for example, a face which has large eyes or which has light complexion, so I can do that by adding more hidden layers. And I can increase the complexity also at the same time if I want to find which image contains a dog. So for that also I can have one more hidden layer. So as and when hidden layer increases, we are able to solve more and more complex problems. So this is just a general overview of how a deep network looks like. So we have first patterns of local contrast in the first layer. Then what happens, we fixate these patterns of local contrast in order to form the face features such as eyes, nose, ears, etc. And then we accumulate these features for the correct face, and then we determine the image. So this is how a deep learning network, or you can say deep network, looks like. and I'll give you some applications of deep learning. So here are a few applications of deep learning. It can be used in self-driving cars. So you must have heard about self-driving cars. So what happens? It'll capture the images around it. It'll process that huge amount of data, and then it'll decide what action should it take. Should it take left, right? Should it stop? So accordingly, it'll decide what action should it take. And that will reduce the amount of accidents that happens every year. Then when we talk about voice control assistants, I'm pretty sure you must have heard about Siri. All the iPhone users know about Siri, right? So you can tell Siri whatever you want to do. It'll search it for you and display for you. Then when we talk about automatic image caption generation, so what happens in this, whatever image that you upload, the algorithm is in such a way that it will generate the caption accordingly. So for example, if you have, say, blue colored eyes, so it will display a blue colored eye caption at the bottom of the image. Now, when I talk about automatic machine translation, so we can convert English language into Spanish, similarly Spanish to French. So basically, automatic machine translation, you can convert one language to another language with the help of deep learning. And these are just few examples, guys. There are many, many other examples of deep learning. It can be used in game playing. It can be used in many other things. And let me tell you one very fascinating thing that I've told you in the beginning as well. With the help of deep learning, MIT is trying to predict future. So yeah, I know it is growing exponentially right now, guys.
Here is another quiz question for you guys. And the question is, which of the following structures primarily uses deep learning? And the options are A. Decision trees, B. Linear regression, C. Neural networks, D. Support vector machines. If you know the correct answer, please leave it in the comment section below. Having covered deep learning, our next focus will be on TensorFlow, where learners will learn about this powerful framework used for building deep learning models.
What is object detection? So object detection is a computer technology which is related to computer vision and image processing. Here, what we do in case of object detection is, for a given image, I'm going to check what are the objects that are present in the image, and not only what, I'm also going to say where exactly is that object is present. So that is what happens in place of object detection. An excellent example can be is Facebook photo tagging. So you might have observed the Facebook photo tagging feature. So when you upload a photo to your Facebook, so the Facebook will automatically recognize the people who are present in that particular uploaded image, and along with that it will also do one important thing. Along with that, it will also show you as where exactly that person is present. So if they like, it is going to draw a bounding box on top of that person's face to show it as, hey, this is your friend A and he's present over here, do you want to tag him? So that functionality that you would see in the Facebook, uh, that functionality that you see, so that is a typical example of object detection. Now I'm not sure what is the latest update, because it's been more than 2 years me using social media, but yeah, so 2 years back that was there, and I'm sure today it will be the same feature or it will be upgraded. But the main concept is this: when you upload something for your Facebook or any social media, I'm giving it Facebook as a generalized concept because that's where I've seen. So it is going to tell us who are all the people that are present in the image, and also it is going to tell us as where that person is present. And that is what an object detection algorithm is going to do. It's going to identify the objects in a given image, and it also tells us as where exactly that object is present. So what and where, both of them will be identified in case of object detection. So here you can see the GIF animation that you would see over here on your left hand of the screen. So here it says what are the objects that are present in the image. So the objects are cap, bowl, Pepsi can, and so on. Now along with saying what are the objects, it is also drawing a bounding box. So you can see a green box that has been drawn on top of each and every object to tell us as where that particular object is present. And here on the another image that we have on the right hand of the slide, so here it's also doing a similar activity. It is saying there's a retriever dog, there is an American Stanford Terrier dog, and there is just a common dog, okay, and there is a built terrier dog. So it has identified the dogs that are present in the image, and along with identifying what is the breed of the dog, it is also drawing a box See, it says, this is where my dog is, this is where my dog is, this is where my dog is. So this is how any typical object detection application would work. So it detects what, and also it also tells us as where exactly that particular object is present. Now, the next question is, where do we see these applications? So one obvious, face recognition. So this, we have been familiar with Facebook. So where we upload an image and we can identify who are all the people that are present in the image. And even Google Photos has a good face recognition feature. I mean, so we've been understanding about this, and even the Google Photos has a good face recognition, or yeah, voice recognition over there. So when we upload all the pictures, so it's going to group all the photos together, and it will ask us to name that particular one person, and it will automatically tag those names to all the similar people wherever that person is present. So that's also an application of face recognition. And we can also use this object detection concept for the people counting to understand as how many people are present over there in a given scenario. Or another example can be is whether that person is wearing a mask or not. So wearing a mask or not. So I can do it, and I can also use this facial I can also use this mask detection, object detection, for checking whether people are following the COVID-19 protocols, that is social distancing. So all these are the applications of using object detection. And even we can use it for industrial purpose. It could be for industrial quality checking, to check whether the objects that has been done is a object that has been manufactured, is it as per the standards that are being expected by the industry. Or self-driving cars. So in case of self-driving cars, so the cars will identify what are the objects that are present in a given image, okay, or a given video feed, and on the basis of the object, it's going to drive. So that's another application of self-driving car, the application of object detection. And the another application that I could see is the security, the Face ID that we have in our Apple iPhones. So that uses the object detection to identify who is present in that image. And another thing is like identifying the objects on the road. I think you might have seen the latest Mahindra XUV 700. So they have an functionality to detect the they have the functionality to detect the objects that are in front of the car, and if the object is very close to the car, it is going to automatically apply the brake. Now here the object detection, obviously, like to detect the objects in front of the car, so they are making use of object detection over there. So that's another application. Okay, so these are some of the applications of using object detection in real life. Now coming to this object detection, let's look at the typical workflow and how does it work when we want to build an object detection algorithm using TensorFlow. When we are working with the applications like object detection, first we need to prepare the training data. I'll have to build the training data to such that to identify whether my given image has the required number of classes. So I'll have to build my classifier to identify as what is that individual object is present, or what is my individual object contains. Now after I have trained this, so this is my training data, I have the images of cars and I have the images of bike, and I have trained my machine learning model to identify whether my given image contains this car and bike. Now once it's trained, I can obviously go ahead and send in my test data, and with that test data I can detect whether my given input image contains bike or car. Okay, so this is the first step in preparing the object detection. Okay, first I'll build a classifier which will help me in identifying what is present in the image. Now along with this what, while training, I'll also tell my machine learning, or in this case deep learning system, to tell us where exactly that object is present. So my machine learning model, or this in this scenario it's a deep learning model, my deep learning model will do two things in parallel. One, it will identify what, and the another thing it will also do is where. It will learn where exactly that object is present in that given image. So it does both the things in parallel. So what happens is like I'll have some set of layers over here, and from this layer another set of another series of layers for detection to identify what is present over there, and another set of layers for detecting where exactly that object is present. Okay, so that's what it will be, the workflow of object detection. Now, once I have trained my object detection model, I can send in a new image. Now, when I send a new image, my deep learning model will be able to identify what is present in the image, and also it also tells me as where exactly that object is present in the given image. And that's how an object detection machine learning algorithm would work. Now, in order to build this deep learning models, which is capable of performing object detection, we have various frameworks. Now, one of the common framework that we would use is the TensorFlow. So this is one of the very common framework that we are currently using, which are in the latest scenario because of its ease of deployment using the TensorFlow extent. So because of this functionality, so now industries are preferring to use this TensorFlow framework. Now, apart from this, we have PyTorch, MXNet, Theano. So these are the various frameworks that are also available to us to build deep learning neural network. Now, let's get an understanding about this TensorFlow and what does this TensorFlow is made of. Now, as I mentioned already, TensorFlow is a deep learning framework which helps us in building the deep learning neural network. Now, just like my NumPy library has the array object, which is one of the basic object from this NumPy library. In case of TensorFlow library, or you can take any deep learning frameworks, we have an object that's called as tensors. Now, these tensors are the standard way of representing the data in case of deep learning. The reason that we used to prefer representing the data with tensors because, one, it will help us to process the data with GPU. GPU means graphical processing unit, which we use it for gaming purpose. Okay, you know already what is computer gaming. So one like to, in order to get the speed and in order to get the good graphics, we know that we actually use the best and the best graphics card so that we can play the game in a very high setting. Now, using this deep learning frameworks and by creating the data inside the tensors, I'll be having the ability, to process those data that I have using these GPU cores. So just like we have a course in CPU, we'll also have the processing course in GPU, and we'll be utilize those GPU cores. And we have seen that we could get around 10 to 20x faster than what we could achieve in our CPU. So that's the advantage of working with deep learning frameworks and creating the data as tensors. And if I have a CUDA supported GPU, then I can also make use of this GPU cores to get 10 to 20 times of faster data processing compared to CPU. So that's the reason we want to represent the data in terms of tensors. Now, what is this tensors? Tensors are just a multidimensional array object. It's just an extension of two-dimensional tables to data with higher dimension. So that's what these tensors are. Now, in this TensorFlow, the computation is approached as a data flow diagram. So whenever I want to do anything over there in TensorFlow, so normally what we do, if you remember, in case of any machine learning model, I'm going to represent how my y hat is computed. And then from my y hat, I'm going to calculate the cost. So I'll have to manually specify how the cost should be done. And I have to mention as how the gradient should be calculated with reference to every parameter that I'm currently having in my model. But in case of TensorFlow, I don't have to worry about it. I can let my TensorFlow to do the magic. I can let my TensorFlow to track what are the operations that I'm doing on the data. And once I've completed the operation, I can just tell to my system as, okay, hey, I have finished doing the operation. Why don't you update the parameters? So in order to do that, we actually make use of data flow graph, or sometimes we also call it as TensorFlow graph. So it's going to track how the data is getting manipulated. Now, once I have done this data manipulation, I can make use of this TensorFlow graph to update the parameters of my model during the operation. And that's the advantage of using deep learning framework. Now, because of this feature, I don't have to worry about writing the complex equation. I can just start building the models which are as much as complex that I want. And I can let my TensorFlow to do the magic and find the gradients and update the parameters with just a single command. So that's the advantage of working with this TensorFlow. And we have the similar functionality in PyTorch library. So it's not just advantage in TensorFlow. I'm just giving it as an example as TensorFlow because we are discussing in TensorFlow. The similar functionality is also available in PyTorch as well. Okay. And yes, we represent the data in tensors. And once we represent the data in tensors, so here it is just a flow over here. So here the flow says, okay, for the given data, I'm going to add something and I'm going to perform matrix multiplication. So matmul is nothing but the matrix multiplication. So I'm doing some matrix multiplication and I'm getting the result. And on the basis of result, if I want to update something, I can just go ahead and perform some update using the TensorFlow data graph that I have, and then find the parameters over there, and I can do my required activity as per my preference. So what we do in case of building the model is, we'll start with the input data. We are going to convert it into the tensors. And once we convert the data into the tensors using TensorFlow library, we'll start training the model with TensorFlow model. Okay, so here the TensorFlow model is nothing but the deep learning model which I've created with TensorFlow library. Now, once that is done, I can go ahead and start training the model in depth. So here I'll create it as tensors, and then I'm going to train my TensorFlow model, which is a deep learning model. And once the model has been trained, I can send in a new data, which is called as test data, to test how my model is performing. And once the testing is done, once I'm satisfied with the output, obviously I can use those test results to tell us as, okay, so this is an example of object detection. So for a given image, this is where the objects are, and these are the objects. So person, dog, and horse. So there are 3 objects that are present over here, and the bounding box tells us as where exactly those objects are present. So this is a typical flow when it comes to performing object detection. Now here, as a hands-on demo, we are going to look into a demo of YOLO model. Okay, so YOLO is one of the most commonly used object detection model when it comes to performing the object detection using deep learning models. So it's an object detection models. We'll use this already trained YOLO model, and we'll send in our data, and we'll see how the output would look like when I perform object detection with this YOLO. Okay, so let's go back to our Google Colab. Okay, now let's have a quick look at the implementation of TensorFlow. So this is a notebook that I've just shared in the chat window. You can refer that notebook. And this notebook has the implementation of object detection with YOLO. Now here, to get started, we are going to get the repository from the GitHub. So this is going to clone my repository, which is present over there. That is the darknet repository. And then I'm going to go inside the directory, that is cd darknet. And this is going to display the various files that we have in that directory. Now, once that is done, we are going to execute this command of make. So this will compile my library, and this is going to make sure that it is ready for us to execute. So this would take a while depending on the computer speed that we are running in. Now in this scenario, I'm using the free system that is provided by Google Colab. Hence this would take a while for it to become ready. And once that is done, I'm going to get the trained weights or already trained weights from the GitHub repository. So this is actually available under this link. So I'm going to download those weights. So here, the weights are nothing but the already trained data. So I'll use the already trained data, and I would get that data. And once I get the data, I can just go ahead and test my object detector. Now here, for the testing purpose, I'm going to make use of the image that is called as person's image, which is present inside my data directory. Okay, I'll show you what is that image that I'm talking about. So data, So there are various images. Now this time I'm using this image of person. So this is the image of person. So on this image, I'm going to identify what are the objects that are present in this given image. So let's see what will be the output if I just execute this line. So this is going to tell me, this would take a while to perform the prediction. Okay, and then it will give us the detection. Okay, so we have the output, and if you observe over here, currently I'm running on CPU, so it actually took 21,915 milliseconds. So I'll just note this number in a separate notepad. So this is the 21,050 milliseconds it took on my CPU. All right, and if I come down, so this is the predictions that has been given from my object detection model of YOLO. So it says where exactly that person is present, and it also displays about the class name. Here the class name says as person, and along with that it also displays the confidence score. So how much confident it is how much confident it is to saying it as okay, it belongs to the person. Okay, and it says 98% confidence that belongs to the horse, and this is 99% confident that it belongs to the dog classes. Now we are going to enable the GPU, and once we enable the GPU, we'll have to execute some commands again and prepare our model to make sure that it runs on GPU. And once that is done, this time we are going to use a new image. The new image is called as giraffe.jpg. So this is the image that I'll be testing out. So this is the image of giraffe, and I'll be using this image to detect the objects. So I'll just execute this to run the prediction, and I'm going to show how the objects would look like in this image. Okay, it's still configuring my system to make sure that it runs on the GPU. Now the system setup is complete. Now let's look at the logs. Now if I come down and look at the logs, it just took less than a second to complete the prediction. So it just took around 165 milliseconds. See, you can look into the comparison. Now if I just compare it, okay, 21915 divided by 165, so it's like 132 times faster than what I have got from my CPU. So that's the computation speed that we would get when we work with uh, GPUs. Okay, now if I see over here, so it says these are the objects that has been identified from a given image. So there's a giraffe with 100% confidence, and there is a zebra with 99% confidence. So clearly we would get the high speed computation when we are working with GPUs. Now below we have a code to test out about the various threshold values. So for that we are choosing an example image of horse, and on this example image of horse, so by default it has some threshold value. I think the threshold value is somewhere around 0.8 or something. Now if I reduce the threshold value, it is going to add some more images, and if I increase the threshold values, it is going to stop like displaying about the loss. In this example I've mentioned my threshold as 0.98. That means detect the objects for which you are confident with 98%. So here in the above image I had an object which had 90% confidence, and that has been omitted when I specify this threshold of 98%. And if I reduce the threshold value, then in such scenarios it would randomly assign the values like this, because the threshold is very less. Okay, so that is how we can make use of TensorFlow and that is how we can make use of TensorFlow and detect the objects in an image. And if I come down, there is a code which talks about as we can perform the object detection in videos. Now instead of connecting to the videos, we can also make use of OpenCV library and detect the starter webcam session, and then we can run this object detection on the video file as well. or we can run that object detection on the on the webcam stream as well to detect what are the objects that are present in the image. Now, in order to do that, obviously we need a system which has a very good memory and the GPU, and you are free to check out at your end when you're exploring about videos. Okay, so the identification or the overall understanding that you need to have is when I talk about object detection. So object detection means for a given input data, I'll be doing two things. One, I'll be detecting where is my object is present. Okay, I'll detect where is my object and what is my object. I'll detect both the things when I'm performing object detection. So what and where, which is like what we have seen in this video. So in our current scenario, so we have made use of YOLO object detector to detect the objects from our end. And when you start your learning journey with TensorFlow, obviously you learn how you can create your own object detection model to identify the objects in a given image. So you learn that as well as you progress in your learning journey when you start exploring TensorFlow and when you try to do some task on your own. Okay, so that's how you can plan out in your learning journey.
After understanding TensorFlow, we'll discuss artificial neural networks, which are the building blocks of many deep learning systems.
So this is the problem statement, guys. We need to figure out if the banknotes are real or fake. And for that, we'll be using artificial neural networks. And obviously, we need some sort of data in order to train our network. So let us see how the data set looks like. So over here, I've taken a screenshot of the data set with few of the rows. In it, data were extracted from images that were taken from genuine and forged banknote-like specimens. After that, wavelet transform tools were used to extract features from those images. And these are a few features that I'm highlighting with my cursor. And the final column or the last column actually represents the label. So basically, label tells us to which class that pattern represents, whether that pattern represents a fake note or it represents a real note. Let us discuss these features and labels one by one. So the first feature or the first column is nothing but variance of a wavelet transformed image. The second column is about skewness. The third is curtices of wavelet transformed image. And finally, fourth one is entropy of the image. After that, when I talk about label, which is nothing but my last column, over here, if the value is 1, that means the pattern represents a real note. Whereas when value is 0, that means it represents a fake note. So guys, let's move forward and we'll see what are the various steps involved in order to implement this use case. So over here, we'll first begin by reading the data set that we have. We'll define features and labels. After that, we are going to encode the dependent variable. And what is a dependent variable? It is nothing but your label. Then we are going to divide the data set into two parts, one for training, another for testing. After that, we'll use TensorFlow data structures for holding features, labels, etc. And TensorFlow is nothing but a Python library that is used in order to implement deep learning models, or you can say neural networks. Then we'll write the code in order to implement the model. And once this is done, we will train our model on the training data. We'll calculate the error. Error is nothing but your difference between the model output and the actual output. And we'll try to reduce this error. And once this error becomes minimum, we'll make prediction on the test data and we'll calculate the final accuracy. So guys, let me quickly open my PyCharm and I'll show you how the output looks like. So this is my PyCharm, guys. Over here, I've already written the code in order to execute the use case. I'll go ahead and run this and I'll show you the output. So over here, as you can see, with every iteration, the accuracy is increasing. So let me just stop it right here. So we'll move forward and we'll understand why we need neural networks. So in order to understand why we need neural networks, we are going to compare the approach before and after neural networks. And we'll see what were the various problems that were there before neural networks. So earlier, conventional computers use an algorithmic approach. That is, the computer follows a set of instructions in order to solve a problem. And unless the specific steps that the computer needs to follow are known, the computer cannot solve the problem. So obviously we need a person who actually knows how to solve that problem, and he or she can provide the instructions to the computer as to how to solve that particular problem, right? So we first should know the answer to that problem, or we should know how to overcome that challenge or problem which is there in front of us. Then only we can provide instructions to the computer. So this restricts the problem solving capability of conventional computers to problems that we already understand and know how to solve. But what about those problems whose answer we have no clue of? So that's where our traditional approach was a failure. So that's why neural networks were introduced. Now let us see what was the scenario after neural networks. So neural networks basically process information in a similar way the human brain does. And these networks, they actually learn from examples. You cannot program them to perform a specific task. They will learn from their examples, from their experience. So you don't need to provide all the instructions to perform a specific task. And your network will learn on its own with its own experience. All right, so this is what basically neural network does. So even if you don't know how to solve a problem, you can train your network in such a way that with experience, it can actually learn how to solve the problem. So that was a major reason why neural networks came into existence. So we'll move forward and we'll understand what is the motivation behind neural networks. So these neural networks are basically inspired by neurons, which are nothing but your brain cells. And the exact working of the human brain is still a mystery though. So as I've told you earlier as well, that neural networks work like human brain, and so the name. And similar to a newborn human baby, as he or she learns from his or her experience, we want a network to do that as well. But we want it to do very quickly. So here's a diagram of a neuron. Basically, a biological neuron receives input from other sources, combines them in some way, perform a generally non-linear operation on the result, and then outputs the final result. So here, if you notice these dendrites will receive signals from the other neurons. Then what will happen, it will transfer it to the cell body. The cell body will perform some function. It can be summation, can be multiplication. So after performing that summation on the set of inputs, via axon, it is transferred to the next neuron. Now let's understand what exactly are artificial neural networks. It is basically a computing system that is designed to simulate the way the human brain analyzes and processes the information. Artificial neural networks has self-learning capabilities that enable it to produce better results as more data becomes available. So if you train your network on more data, it will be more accurate. So these neural networks, they actually learn by example. And you can configure your neural network for specific applications. It can be pattern recognition, or it can be data classification, anything like that, all right? So because of neural networks, we see a lot of new technology has evolved. From translating web pages to other languages, to having a virtual assistant to order groceries online, to conversing with chatbots. All of these things are possible because of neural networks. So in a nutshell, if I need to tell you, artificial neural network is nothing but a network of various artificial neurons. All right. So let me show you the importance of neural network with two scenarios, before and after neural network. So over here we have a machine, and we have trained this machine on 4 types of dogs, as you can see where I'm highlighting with my cursor. And once the training is done, we provide a random image to this particular machine which has a dog. But this dog is not like the other dogs on which we have trained our system on. So without neural networks, our machine cannot identify that dog in the picture, as you can see it over here. Basically, our machine will be confused. It cannot figure out where the dog is. Now, when I talk about neural networks, even if we have not trained our machine on this specific dog, but still it can identify certain features of the dogs that we have trained on, and it can match those features with the dog that is there in this particular image, and it can identify that dog. So this happens all because of neural networks. So this is just an example to show you how important are neural networks. Now I know you all must be thinking how neural networks work. So for that, we'll move forward and understand how it actually works. So over here, I'll begin by first explaining a single artificial neuron that is called as perceptron. So this is an example of a perceptron. Over here, we have multiple inputs, x1, x2, dash, 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 till xn. And we have corresponding weights as well, w1 for x1, w2 for x2, similarly wn for xn. Then what happens, we calculated the weighted sum of these inputs. And after doing that, we pass it through an activation function. This activation function is nothing but it provides a threshold value. So above that value, my neuron will fire, else it won't fire. So this is basically an artificial neuron. So when I talk about a neural network, it involves a lot of these artificial neurons with their own activation function and their processing element. Now we'll move forward and we'll actually understand various modes of this perceptron or single artificial neuron. So there are 2 modes in a perceptron. One is training, another is using mode. In training mode, the neuron can be trained to fire for particular input patterns, which means that we'll actually train our neuron to fire on certain set of inputs and to not fire on the other set of inputs. That's what basically training mode is. When I talk about using mode, it means that when a taught input pattern is detected at the input, its associated output becomes the current output, which means that once the training is done and we provide an input on which the neuron has been trained on, So it will detect the input and will provide the associated output. So that's what basically using mode is. So first you need to train it, then only you can use your perceptron or your network. So these were the two modes, guys. Next up, we'll understand what are the various activation functions available. So these are the three activation functions, although there are many more, but I've listed down three. Step function. So over here, the moment your input is greater than this particular value, your neuron will fire, else it won't. Similarly for sigmoid and sine function as well. So these are three activation functions. There are many more that I've told you earlier as well. So yeah, these are the three majorly used activation functions. Next up, what we are going to do, we are going to understand how a neuron learns from its experience. So I'll give you a very good analogy in order to understand that. And later on, when we talk about neural networks, or you can say multiple neurons in a network, I'll explain you the math behind it. I'll explain you the math behind learning, how it actually happens. So right now, I'll explain you with an analogy. And guys, trust me, that analogy is pretty interesting. So I know all of you must have guessed it. So these are two beer mugs, and all of you who love beer can actually relate to this analogy a lot. And I know most of you actually love beer, so that's why I've chosen this particular analogy, so that all of you can relate to it. All right, jokes apart. So fine, guys. So there's a beer festival happening near your house, and you want to badly go there. But your decision actually depends on three factors. First is how is the weather, whether it is good or bad. Second is your wife or husband is going with you or not. And the third one is any public transport is available. So on these three factors, your decision will depend whether you will go or not. So we'll consider these three factors as inputs to our perceptron, and we'll consider our decision of going or not going to the beer festival as our output. So let us move forward with that. So the first input is how is the weather. We'll consider it as x1. So when weather is good, it will be 1, and when it is bad, it will be 0. Similarly, your wife is going with you or not, so that will be your x2. If she is going, then it's 1. If she's not going, then it's 0. Similarly, for public transport, if it is available, then it is 1, else it is 0. So these are the three inputs that I'm talking about. Let's see the output. So output will be 1 when you're going to the beer festival, and output will be 0 when you want to relax at home. You want to have beer at home only. You don't want to go outside. So these are the two outputs, whether you're going or you're not going. Now what a human brain does. Over here, okay, fine. I need to go to the beer festival. But there are three things that I need to consider. But will I give importance to all these factors equally? Definitely not. There'll be certain factors which will be of higher priority for me. I'll focus on those factors more, whereas few factors won't affect that much to me. All right, so let's prioritize our inputs or factors. So here our most important factor is weather. So if weather is good, I love beer so much that I don't care even if my wife is going with me or not, or if there is a public transport available. So I love beer that much that if weather is good, then definitely I'm going there. That means when x1 is high, output will be definitely high. So how we do that, how we actually prioritize our factors, or how we actually give importance more to a particular input and less to another input in a perceptron or in a neuron. So we do that by using weights. So we assign high weights to the more important factors or more important inputs, and we assign low weights to those particular inputs which are not that important for us. So let's assign weights, guys. So weight W1 is associated with input X1, W2 with X2, and similarly W3 with X3. Now, as I've told you earlier as well, that weather is a very important factor, so I'll assign a pretty high weight to weather and I'll keep it as 6. Similarly, W2 and W3 are not that important, so I'll keep it as 2, 2. After that, I've defined a threshold value as 5, which means that when the weighted sum of my input is greater than 5, then only my neuron will fire, or you can say then only I'll be going to the beer festival. All right, so I'll use my pen and we'll see what happens when weather is good. So when weather is good, our X1 is 1. Our weight is 6, we'll multiply it with 6. Then, if my wife decides that she is going to stay at home and she will probably be busy with cooking and she doesn't want to drink beer with me, so she's not coming. So that input becomes 0. 0 into 2 will actually make no difference because it will be 0 only. Then again, there is no public transport available also. Then also this will be 0 into 2. So what output I get here? I get here as 6. And notice the threshold value, it is 5. So definitely 6 is greater than 5. That means my output will be 1, or you can say my neuron will fire, or I'll actually go to the beer festival. So even if these two inputs are 0 for me, that means my wife is not willing to go with me and there is no public transport available, but weather is good, which has very high weight value and it actually matters a lot to me. So if that is high, it doesn't really matter whether the two inputs are high or not. I will definitely go to the beer festival. All right. Now I'll explain you a different scenario. So over here our threshold was 5. But what if I change this threshold to 3? So in that scenario, even if my weather is not good, I'll give it a 0. So 0 into 6. But my wife and public transport both are available. All right. So 1 into 2 plus 1 into 2, which is equal to 4. And it is definitely greater than 3. Then also my output will be 1. That means I will definitely go to the beer festival even if weather is bad. And my neuron will fire. So these are the two scenarios that I have discussed with you. Alright. So there can be many other ways in which you can actually assign weight to your problem or to your learning algorithm. So these are the two ways in which you can assign weights and prioritize your inputs or factors on which your output will depend. So obviously in real life, all the inputs or all the factors are not as important for you. So you actually prioritize them. And how you do that in perceptron, you provide high weight to it. This is just an analogy so that you can relate to a perceptron to a real life. We'll actually discuss the math behind it later in the session as to how a network or a neuron learns. All right. So how the weights are actually updated and how the output is changing, that all those things we'll be discussing later in the session. But my aim is to make you understand that you can actually relate to a real life problem with that of a perceptron. All right. And in real life, problems are not that easy. They are very, very complex problems that we actually face. So in order to solve those problems, a single neuron is definitely not enough. So we need networks of neurons. And that's where artificial neural network, or you can say multi-layer perceptron, comes into the picture. Now let us discuss that. Multi-layer perceptron or artificial neural network. So this is how an artificial neural network actually looks like. So over here we have multiple neurons present in different layers. The first layer is always your input layer. This is where you actually feed in all of your inputs. Then we have the first hidden layer. Then we have second hidden layer, and then we have the output layer. Although the number of hidden layers depend on your application, on what are you working, what is your problem. So that actually determines how many hidden layers you'll have. So let me explain you what is actually happening here. So you provide in some input to the first layer, which is nothing but your input layer. You provide inputs to these neurons. All right. And after some function, the output of these neurons will become the input to the next layer, which is nothing but your hidden layer 1. Then these hidden layers also have various neurons. These neurons will have different activation functions. So they'll perform their own function on the inputs that it receives from the previous layer. And then the output of this layer will be the input to the next hidden layer, which is hidden layer 2. Similarly, the output of this hidden layer will be the input to the output layer. And finally, we get the output. So this is how basically an artificial neural network looks like. Now let me explain you this with an example. So over here, I'll take an example of image recognition using neural networks. So over here, what happens, we feed in a lot of images to our input layer. Now this input layer will actually detect the patterns of local contrast and then will feed that to the next layer, which is hidden layer 1. So in this hidden layer 1, the face features will be recognized. We'll recognize eyes, nose, ears, things like that. And then that will be again fed as input to the next hidden layer. And in this hidden layer, we'll assemble those features and we'll try to make a face. And then we'll get the output, that is the face will be recognized properly. So if you notice here, with every layer, we are trying to get a more abstract version or the generalized version of the input. So this is how basically an artificial neural network, how it works. All right. And there's a lot of training and learning which is involved that I'll show you now. Training a neural network. So how we actually train a neural network? So basically the most common algorithm for training a network is called backpropagation. So what happens in backpropagation, after the weighted sum of inputs and passing through an activation function and getting the output, we compare that output to the actual output that we already know. We figure out how much is the difference. We calculate the error. And based on that error, what we do, we propagate backwards. And we'll see what happens when we change the weight. Will the error decrease or will it increase? And if it increases, when it increases, by increasing the value of the variables or by decreasing the value of variables. So we kind of calculate all those things and we update our variables in such a way that our error becomes minimum. And it takes a lot of iterations. Trust me guys, it takes a lot of iterations. We get output a lot of times and then we compare it with the model, with the actual output. Then again we propagate backwards, we change the variables, then again we calculate the output, we compare it again with the desired output of the actual output. Then again we propagate backwards. So this process keeps on repeating until we get the minimum value. All right. So there's an example that is there in front of your screen. Don't be scared of the terms that I used. I'll actually explain you with an example. So this is the example over here. We have 0, 1 and 2 as inputs, and our desired output, or the output that we already know, is 0, 1 and 4. All right. So over here we can actually figure out that desired output is nothing but twice of your input. But I'm training a computer to do that, right? The computer is not a human. So what happens? I actually initialize my weight. I keep the value as 3. So the model output will be 3 into 0 is 0, 3 into 1 is 3, 3 into 2 is 6. Now obviously it is not equal to your desired output. So we check the error. Now the error that we have got here is 0, 1 and 2, which is nothing but your difference. So 0 minus 0 is 0, 3 minus 2 is 1, 6 minus 4 is 2. Now this is called an absolute error. After squaring this error, we get square error, which is nothing but 0, 1 and 4. All right. So now what we need to do, we need to update the variables. We have seen that the output that we got is actually different from the desired output. So we need to update the value of the weight. So instead of 3, our computer makes it as 4. After making the value as 4, we get the model output as 0, 4 and 8. And then we saw that the error has actually increased. Instead of decreasing, the error has increased. So after updating the variable, the error has increased. So you can see that square error is now 0, 4 and 16, and earlier it was 0, 1 and 4. That means we cannot increase the weight value right now. But if we decrease that, make it as 2, we get the output which is actually equal to desired output. But is it always the case that we need to only decrease the weight? Definitely not. So in this particular scenario, whenever I'm increasing the weight, error is increasing, and when I'm decreasing the weight, error is decreasing. But as I've told you earlier as well, this is not the case every time. Sometimes you need to increase the weight as well. So how we determine that? Alright, fine guys, this is how basically a computer decides whether it has to increase the weight or decrease the weight. So what happens here, this is a graph of square error versus weight. So over here what happens, suppose your square error is somewhere here, and your computer, it starts increasing the weight in order to reduce the square error. And it notices that whenever it increases the weight, square error is actually decreasing. So it'll keep on increasing until the square error reaches a minimum value. And after that, when it tries to still increase the weight, the square error will increase. So at that time, our network will recognize that whenever it is increasing the weight after this point, error is increasing. So therefore, it will stop right there, and that will be our weight value. Similarly, there can be one more scenario. Suppose if we increase the weight, but then also the square error is increasing. So at that time, we cannot increase the weight. At that time, computer will realize, okay, fine, whenever I'm increasing the weight, the square error is increasing. So it'll go in the opposite direction. So it'll start decreasing the weight, and it'll keep on doing that until the square error becomes minimum. And the moment it decreases more, the square error again increases. So our network will know that whenever it decreases the weight value, the square error is increasing. So that point will be our final weight value. So guys, this is what basically backpropagation in a nutshell is. Fine, so we'll move forward, and now is the correct time to understand how to implement the use case that I was talking about at the beginning. That is how to determine whether a node is fake or real. So for that, I'll open my PyCharm. This is my PyCharm again, guys. Let me just close this. All right. So this is the code that I've written in order to implement the use case. So over here, what we do, we import the first important libraries which are required. Matplotlib is used for visualization. TensorFlow we know in order to implement the neural networks. NumPy for arrays, pandas for reading the data set. Similarly, sklearn for label encoding as well as for shuffling, and also to split the data set into training and testing parts. All right, fine guys. So we'll begin by first reading the data set, as I've told you earlier as well when I was explaining the steps. So what I'll do, I'll use pandas in order to read the CSV file which has the data set. After that, I'll define features and labels. So X will be my feature and Y will contain my label. So basically X includes all the columns apart from the last column, which is the fifth one. And because the indexing starts from 0, that's why we have written 0 till 4th. So it won't include the 4th column. All right. And so our last column will actually be our label. Then what we need to do, we need to encode the dependent variable. So the dependent variable, as I've told you earlier as well, is nothing but your label. So I've discussed encoding in TensorFlow tutorial. You can go through it and you can actually get to know why and how we do that. Then what we have done, we have read the data set. Then what we need to do is to split our data set into training and testing. And these are all optional steps. You can print the shape of your training and test data. If you don't want to do it, it's still fine. Then we have defined learning rate. So learning rate is actually the steps in which the weights will be updated. All right. So that is what basically learning rate is. Then when we talk about epochs, means iterations. Then we have defined course history. That will be an empty NumPy array, and its shape will be 1, and it will include the float type objects. Then we have defined ndim, which is nothing but your x shape of axis 1, which means your column. Then we'll print that. After that, we have defined the number of classes. So there can be only 2 classes, whether the node can be fake or it can be real. And this model path I've given in order to save my model. So I've just given a path where I need to save it. So I'll just save it here only in the current working directory. Now is the time to actually define our neural network. So we'll first make sure that we have defined the important parameters like hidden layers, number of neurons in hidden layers. So I'll take 10 neurons in every hidden layer and I'm taking 4 layers like that. Then x will be my placeholder and the shape of this particular placeholder is none, comma n underscore dim. N underscore dim value I'll get it from here and none can be any value. I'll define one variable w and I'll initialize it with zeros and this will be the shape of my weight. Similarly for bias as well, this will be the particular shape. And there will be one more placeholder y dash, which will actually be used in order to provide us with the actual output of the model. There'll be one model output and there'll be one actual output, which we use in order to calculate the difference, right? So we'll feed in the actual values of the labels in this particular placeholder y dash. And now we'll define the model. So over here we have named the function as multi-layer perceptron, and in it we'll first define the first layer. So the first hidden layer, and we are going to name it as layer underscore 1, which will be nothing but the matrix multiplication of x and weights of h1, that is the hidden layer 1, and that will be added to your biases b1. After that, we'll pass it through a sigmoid activation function. Similarly, in layer 2 as well, matrix multiplication of layer 1 and weights of h2. So if you can notice, layer 1 was the network layer just before the layer 2, right? So the output of this layer 1 will become input to the layer 2. And that's why we have written layer underscore 1. It'll be multiplied by weights h2 and then we'll add it with the bias. Similarly for this particular hidden layer as well and this particular layer as well. But over here we are going to use the ReLU activation function instead of sigmoid. Then we are going to define the weights and biases. So this is how we basically define weights. So weights h1 will be a variable which will be a truncated normal with the shape of n underscore dim and n underscore hidden underscore 1. So these are nothing but your shapes. Alright, and after that what we have done, we have defined biases as well. Then we need to initialize all the variables. So all these things actually I've discussed in brief when I was talking about TensorFlow. So you can go through TensorFlow tutorial at any point of time if you have any question. We have discussed everything there. Since in TensorFlow we need to initialize the variables before we use it. So that's how we do it. We first initialize it and then we need to run it. That's when your variables will be initialized. After that we are going to create a saver object. And then finally I'm going to call my model. And then comes the part where the training happens. Cost function. Cost function is nothing but you can say an error that will be calculated between the actual output and the model output. Alright, so y is nothing but our model output and y dash is nothing but the actual output or the output that we already know. Alright, and then we are going to use the gradient descent optimizer to reduce the error. Then we are going to create a session object as well. And finally what we are going to do, we are going to run the session. So this is how we basically do that. For every epoch we will be calculating the change in the error as well as the accuracy that comes after every epoch on the training data. After we have calculated the accuracy on the training data, we are going to plot it for every epoch how the accuracy is. And after plotting that, we are going to print the final accuracy which will be on our test data. So using the same model, we'll make prediction on the test data. And after that, we are going to print the final accuracy and the mean squared error. So let's go ahead and execute this, guys. Alright, so training is done. And this is the graph we have got for accuracy versus epoch. This is accuracy, y-axis represents accuracy, whereas this is epochs. We have taken 100 epochs and our accuracy has reached somewhere around 99%. So with every epoch, it is actually increasing. Apart from a couple of instances, it is actually keep on increasing. So the more data you train your model on, it will be more accurate. Let me just close it. So now the model has also been saved where I wanted it to be. This is my final test accuracy and this is the mean squared error. Alright, so these are the files that will appear once you save your model. These are the 4 files that I've highlighted. Now what we need to do is restore this particular model. And I've explained this in detail how to restore a model that you have already saved. So over here what I'll do, I'll take some random range. I've taken it actually from 754 to 768. So all the values in the row of 754 and 768 will be fed to our model and our model will make prediction on that. So let us go ahead and run this. So when I'm restoring my model, it seems that my model is 100% accurate for the values that I've fed in. So whatever values that I have actually given as input to my model, it has correctly identified its class, whether it's a fake node or a real node. Because 0 stands for fake node and 1 stands for real node, okay? So original class is nothing but which is there in my data set, so it is 0 already. And what prediction my model has made is 0. That means it is fake. So accuracy becomes 100%. Similarly for other values as well. Fine guys, so this is how we basically implement the use case that we saw in the beginning. So in the slide you can notice that I've listed down only 2 applications, although there are many more. So neural networks in medicine. Artificial neural networks are currently a very hot research area in medicine, and it is believed that they will receive extensive application to biomedical systems in the next few years. And currently the research is mostly on modeling parts of human body and recognizing diseases from various scans. For example, it can be cardiograms, CAT scans, ultrasonic scans, etc. And currently the research is going mostly on 2 major areas. First is modeling and diagnosing the cardiovascular system. So neural networks are used experimentally to model the human cardiovascular system. Diagnosis can be achieved by building a model of the cardiovascular system of an individual and comparing it with the real-time physiological measurements taken from the patient. And trust me guys, if this routine is carried out regularly, potential harmful medical conditions can be detected at an early stage and thus make the process of combating disease much easier. Apart from that, it is currently being used in electronic noses as well. Electronic noses have several potential applications in telemedicine. Now let me just give you an introduction to telemedicine. Telemedicine is the practice of medicine over long distance via a communication link. So what the electronic noses will do, they would identify odors in the remote surgical environment. These identified odors would then be electronically transmitted to another site where an door generation system would recreate them. Because the sense of the smell can be an important sense to the surgeon, telesmell would enhance telepresent surgery. So these are the 2 ways in which you can use it in medicine. You can use it in business as well, guys. So business is basically a diverted field with several general areas of specialization such as accounting or financial analysis. Almost any neural network application would fit into one business area or financial analysis. Now there is some potential for using neural networks for business purposes, including resource allocation and scheduling. I've listed down 2 major areas where it can be used. One is marketing. So there is a marketing application which has been integrated with a neural network system. The airline marketing tactician is a computer system made of various intelligent technologies, including expert systems. A feed-forward neural network is integrated with the AMT, which is nothing but airline marketing tactician, and was trained using backpropagation to assist the marketing control of airline seat allocation. So it has wide applications in marketing as well. Now the second area is credit evaluation. Now I'll give you an example here. The HNC company has developed several neural network applications, and one of them is the credit scoring system, which increases the profitability of existing model up to 27%. So these are few applications that I'm telling you guys. Neural network is actually the future. People are talking about neural networks everywhere, and especially after the introduction of GPUs and the amount of data that we have now, neural network is actually spreading like plague right now.
Now that we have covered artificial neural networks, let's move on to convolutional neural networks, where learners will discover how these networks excel in image processing.
So let's understand how exactly a computer reads an image. So this is an image of New York skyline. I personally love this picture. So when a human will see this image, he'll first notice there are a lot of buildings in different colors and stuff like that. But how a computer will read this image? So basically there will be 3 channels. One will be red, another will be green, and finally we have blue channel, which is popularly known as RGB. So each of these channels will have their own respective pixel values, as you can see it over here. So when I say that image size is B cross A cross 3, it means that there are B rows, A columns, and 3 channels. Alright, so if somebody tells you that the size of an image is 28 cross 28 cross 3 pixels, it means that it has 28 rows, 28 columns, and 3 channels. So this is how a computer sees an image. And this is for colored images. For black and white images, we have only 2 channels. So let's move forward and we'll see why can't we use fully connected networks for image classification. So consider an image which has 28 cross 28 cross 3 pixels. So when I feed in this image to a fully connected network like this, then the total number of weights required in the first hidden layer will be 2352. You can just go ahead and multiply it yourself. Alright. But in real life, the images are not that small, all right? So whatever images that we have, they are definitely above 200 cross 200 cross 3 pixels. So if I take an image which has 200 cross 200 cross 3 pixels and I feed it to a fully connected network, so at that time, the number of weights required at the first hidden layer itself will be 120,000 guys. So we need to deal with such huge amount of parameters, and obviously we require more number of neurons. So that can eventually lead to overfitting. So that's why we cannot use fully connected network for image classification. Now let's see why we need convolutional neural networks. So basically, in convolutional neural network, a neuron in the layer will only be connected to a small region of the layer before it. So if you consider this particular neuron which I'm highlighting right now is only connected to 3 other neurons. Unlike the fully connected network where this particular neuron will be connected to all these 5 neurons. Because of this, we need to handle less amount of weights, and in turn, we need less number of neurons as well. So let us understand what exactly is convolutional neural network. So convolutional neural networks are special type of feed-forward artificial neural networks, which is inspired from visual cortex. So visual cortex is nothing but a small region in our brain which is present somewhere here where you can see the bulb. And basically what happened, there was an experiment conducted and people got to know that visual cortex is small regions of cells that are sensitive to specific regions of visual field. So what I mean by that is, for example, some neurons in the visual cortex fires when exposed to vertical edges. Some will fire when exposed to horizontal edges. Some will fire when exposed to diagonal edges. And that is nothing but the motivation behind convolutional neural network. So now let us understand how exactly a convolutional neural network works. So generally a convolutional neural network has 3 layers: convolution layer, ReLU layer, pooling layer, and fully connected layer. We'll understand each of these layers one by one. We'll take an example of a classifier that can classify an image of an X as well as an O. So with this example, we'll be understanding all these 4 layers. So let's begin, guys. Now there are certain trickier cases. So what I mean by that is X can be represented in these 4 forms as well, right? So these are nothing but the deformed images of X. Similarly for O as well. So these are deformed images. So even I want to classify these images either X or O. All right, because even this is X, this is X, this is X, this is X. But all these are deformed images, but they are in turn X, right? So I want my classifier to classify them as X. So basically that's what I want. So if you can notice here, this is a proper image of an X, and which is actually equal to this particular X, which is a deformed image. Same goes for this O as well. So now what we are going to do is, we know that a computer understands an image using numbers at each pixels. So what we'll do, whatever the white pixels that we have, we are going to assign a value -1 to it, and whatever black pixels we have, we are going to assign a value 1 to it. When we use normal techniques to compare these 2 images, one is a proper image of X and another is a deformed image of X, we got to know that a computer is not able to classify the deformed image of X correctly. Why? Because it is comparing it with the proper image of X, right? So when you go ahead and add the pixel values of both of these images, you get something like this. So basically our computer is not able to recognize whether it is an X or not. Now what we do with the help of CNN, we take small patches of our image. So these patches or these pieces are known as nothing but features or filters. So what we do, by finding rough feature matches in roughly the same positions in 2 images, CNN gets a lot better at seeing the similarity between the whole image matching schemes. What I mean by that is, we have these filters, right? We have these filters that you can see. So consider this first filter. This is exactly equal to the feature or the part of the image in the deformed image as well. So this is our proper image and this is our deformed image, all right? So this particular feature or this particular part of the image is actually equal to this particular part of the image. Same goes for this particular feature or filter as well. And similarly, we have this filter as well, which is actually equal to this particular part of the deformed image, all right? So let's move forward and we'll see what all features that we'll be taking in our example. So we'll be considering these 3 features or filters. This is a diagonal filter, this is again a diagonal filter, and this is nothing but a small X. So we'll take these 3 filters and we'll move forward. So what we are going to do is, we are going to compare these features, the small pieces of the bigger image. We are going to put it on the input image, and if it matches, then the image will be classified correctly. Now we'll begin, guys. The first layer is convolution layer. So these are the beginning 2 steps of this particular layer. First, we need to line up the feature in the image and then multiply image by the corresponding feature pixel. Now let me explain you with an example. So this is our first diagonal feature that we'll take. We are going to put this particular feature on our image of X, all right? And we are going to multiply the corresponding pixel value. So 1 will be multiplied with 1, we'll get 1, and we'll put it in another matrix. Similarly, we are going to move forward and we're going to multiply -1 with -1. We're going to multiply -1 with -1, as you can see. Similarly, we multiply this as well, -1 into -1, then again -1 into -1. So we are going to complete this whole process when we are going to finish up this matrix. All right. And once we are done finishing up the multiplication of all the corresponding pixels in the feature as well as in the image, we need to follow 2 more steps. We need to add them up and divide by the total number of the pixels in the feature. So what I mean by that is, after the multiplication of the corresponding pixel values, what we do, we add all these values, we divide it by the total number of pixels, and we get some value, right? And then now our next step is to create a map and put the value of the filter at that particular place. We saw that after multiplying the pixel value of a feature with the corresponding pixel value with that of our image, we get the output, which is 1. So we place 1 here. Similarly, we are going to move this filter throughout the image. Next up, we are going to move this filter here. After that, we are going to move it here, 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 everywhere on the image. We are going to move it, and we are going to follow the same process. All right, so yeah, this is one more example where I've moved my filter in between, and after doing that, I've got the output something like this, 1, 1, -1 and all. So over here, if you notice, I've got a couple of times -1 as well, due to which my output that comes is 0.55, right? So I'm going to place 0.55 here. Similarly, after moving the pixel, after moving the filter throughout the image, I got this particular matrix. All right, and this is for one particular feature. After performing the same process for the other two filters as well, I've got these two values. So we have these three values after passing through the convolution layer. Let me give you a quick recap of what happens in convolution layer. So basically we have taken three features, all right, and one by one we'll take one feature, move it through the entire image, and when we are moving it, at that time we are multiplying the pixel value of the image with that of the corresponding pixel value of the filter, adding them up, dividing by the total number of pixels to get the output. So when we do that for all the filters, we got these three outputs, all right? So let's move forward and we'll see what happens in ReLU layer. So this is ReLU layer, guys, and people who have gone through the previous tutorial actually know what it is. So let me just give you a quick introduction of ReLU layer. So ReLU is nothing but an activation function. All right, so what I mean by that is it will only activate a node if the input is above a certain quantity. While the input is below 0, the output is also 0. All right, and when the input rises above the certain threshold, it has a linear relationship with the dependent variable. Now I'll explain you with an example. We have a graph of ReLU function here. So my function says that when f of x is equal to 0 if x is less than 0, and it is equal to x when x is greater than 0. All right. So whatever values that I have which are below 0 will actually in turn become 0, and whatever values that are above 0, our function value will also be equal to that particular value. So f of x will be equal to x if it is greater than or equal to 0, and it will be 0 if it is less than 0. So if I have x value as -3, so definitely it is less than 0, so f of x becomes 0. Similarly, if I have -5x value, then again it is less than 0, so my f of x value becomes 0. But when I consider 3 as my x value, then my f of x becomes equal to x, which is nothing but 3. So over here I'll have 3. Again, if I take my x value as 5, then obviously it is greater than or equal to 0. Then my f of x becomes equal to x, so my f of x value becomes 5. So this is how a ReLU function works. So why are we using ReLU function here is we want to remove all the negative values from our output that we got through the convolution layer. So we'll only take the first output that we got by moving one feature throughout the image. So this is the output that we have got for only one filter. All right. So over here, I'm going to remove all negative values. So over here, you can see that it was -0.11 before, and I've converted that to 0. Similarly, I'm going to repeat the whole process for the entire matrix, and once I'm done with that, I get this particular value. Now remember, this is only for the output that we got through one feature. All right, so when we were doing convolution at that time, we were using three features, right? So this is the output only for one filter. After doing it for the output of the other two filters as well, we have got these two values more. So totally we have these three values after passing through ReLU activation function. Next up, we'll see what exactly is pooling layer. So in pooling layer, what we do, we take a window size of 2 and we move it across the entire matrix that we have got after passing through ReLU layer. And we take only the maximum value from there so that we can shrink the image. So what we are actually doing is we are reducing the size of our image. So let me explain you with an example. So this is basically one output that we have got after passing through ReLU layer. And over here we have taken a window size of 2 cross 2. So when we keep this window at this particular position, we see that 1 is the highest value. So we are going to keep 1 here. And we are going to repeat the same process for this particular window as well. So over here the maximum value is 0.33, so 0.33 will come. So if you notice here, earlier we had 7 cross 7 matrix, and now we have reduced that to 4 cross 4 matrix. So after doing that for the entire image, we have got this as our output. This output we have got after moving our window throughout the image that we have got after passing through ReLU layer, right? And when we repeat this process for all the three outputs that we have got after the ReLU layer, then we get this particular output after pooling layer, right? So basically we have shrinked our image to a 4 cross 4 matrix. Now comes the tricky part. So what we are going to do now is stack up all these layers. So we have discussed convolution layer, ReLU layer and pooling layer. So I'll just give you a brief recap of what all things we have discussed. In convolution layer, what we did, we took 3 features and then after that one by one we moved each filter throughout the image, and when we were moving it, we were continuously multiplying the image pixel value with that of the corresponding filter pixel value, and then we were dividing it by the total number of pixels. Alright. With that, we got 3 output after passing through the convolution layer. Then those 3 output we passed through a ReLU layer where we have removed the negative value. Alright, and after removing negative value, again we have got the 3 outputs. Then those 3 outputs we passed through pooling layer. So basically we're trying to shrink our image, and what we did, we took a window size of 2 cross 2, moved it through all the 3 outputs that we have got through ReLU layer. And after doing that, we were only taking the maximum value, pixel value in that particular window, and then we were putting it in a different matrix so that we get a shrinked image. And after passing it through pooling layer, we have got a 4 cross 4 matrix. And since we took 3 features in the beginning, so therefore we have got 3 outputs after passing through pooling layer. All right. Next up, we are going to stack up all the layers. All right. So let's do that. So after passing through convolution, ReLU and pooling, we have got this 4 cross 4 matrix. This was our input image. Now when we add one more layer of convolution, ReLU and pooling, we have shrinked our image from 4 cross 4 to 2 cross 2, as you can notice here. Now we are going to use fully connected layer. Now what happens in fully connected layer? The actual classification happens here, guys. Okay. So what we are doing here is we are going to take the shrinked images and put it into a single list. So basically this is what we have got after passing through 2 layers of convolution, ReLU and pooling. And this is what we have got. So basically we are converting into a single list or a vector. How we do that? We take the first value 1, then we take 0.55, then we take 0.55, then we take 1 again. Then we take 1, then we take 0.55, 0.55, 0.55. Then we again take 0.55, 1, 1 and 0.55. So this is nothing but a vector, or you can say a list. If you notice here that there are certain values in my list which is high for X, and similarly if I repeat the entire process that we have discussed for O, there will be certain different values which will be high. So for X we have first, fourth, 5th, 10th and 11th element vector values are high. For O we have 2nd, 3rd, 9th and 12th element vector which are high. So basically we know now if we have an input image which has 1st, 4th, 5th, 10th and 11th element vector values high, we know that we can classify it as X. Similarly, if our input image has a list which has the 2nd, 3rd, 9th and 12th element vector values high, then we can classify it as 0. Now let me explain you with an example. So after the training is done, after doing the entire process for both X and O, you know that our model is trained now. Okay, so we have given a new input image, and that input image passes through all the layers, and once it has passed through all the layers, we have got this 12 element vector. Now it has 0.9, 0.65, all these values, right? Now how do we classify it, whether it is an X or O? So what we do, we'll compare this with a list of X and O. Right, so we have got the list in the previous slide. If you notice, we have got 2 different lists for X and O. We are going to compare this new input image list that we have got with that of X and O. Right, so first let us compare that with X. Now, as I've told you earlier as well, for X there are certain values which will be high, which is nothing but 1st, 4th, 5th, 10th and 11th value. Right, so I'm going to sum 1st, 4th, 5th, 10th and 11th value, and I've got 5. 1 plus 1 plus 1 plus 1 and plus 1. So 5 times 1, I've got 5. And now I'm going to sum the corresponding values of my input image vector as well. So the first value is 0.9, then the 4th value is 0.87, 5th value is 0.96, 10th value is 0.89 and the 11th value is 0.94. So after doing the sum of these values, I've got 4.56. When I divide this by 5, I got 0.91, right? Now this is for X. Now when I do the same process for O, so in O if you notice, I have 2nd, 3rd, 9th and 12th element vector values as high. So when I sum these values, I get 4. And when I do the sum of the corresponding values in my input image, I've got 2.07. When I divide that by 4, I got 0.51. And so now we notice that 0.91 is a higher value compared to 0.51. So when we have compared our input image with the values of X, we got a higher value than the value that we have got after comparing the input image with the values of O. So the input image is classified as X. Alright, so now let us move towards our use case. So this is our use case, guys. So over here what we are going to do is we are going to train our model on different types of dogs and cat images, and once the training is done, we are going to provide it an input and it will classify whether the input is of a dog or a cat. Now let me tell you the steps involved in it. So what we are going to do in the beginning is obviously first we need to download the data set. After that, we are going to write a function to encode the labels. Labels are nothing but the dependent variable that we are trying to predict. So in our training data and testing data, obviously we know the labels, right? So on that basis only we can train our model. So we are going to encode those labels. After that, we'll resize the image to 50 cross 50 pixel and we are going to read it as a grayscale image. Then we are going to split the data, 24,000 images for training and 50 for testing. Once this is done, we are going to reshape the data appropriately for TensorFlow. Now TensorFlow, I think everyone knows about TensorFlow. TensorFlow is nothing but a Python library for implementing deep learning models. Then we are going to build the model, calculate the loss. It is nothing but categorical cross entropy. Then we are going to reduce the loss by using Adam optimizer with a learning rate set to 0.001. Then we are going to train the deep neural network for 10 epochs. And finally, we are going to make predictions. All right, so I'll just quickly open my PyCharm and I'll show you the code, how it looks like. So this is the code that I've written in order to implement the use case. In the beginning, I need to import the libraries that I require. And once it is done, what I'm doing, I'm defining my training data and the testing data. So train and test one contains both my training data as well as testing data respectively. Then I've taken my image size as 50 and learning rate I've defined here. And I've given a name to my model. You can give whatever name you want. All right, so first thing that we saw, we need to encode the dependent variable. That's what we are doing here. We are encoding our dependent variable. So whenever the label is cat, then it will be converted to an array of 1, 0, and when it is dog, it will be converted to an array of 0, 1. So why we are actually encoding the label? Because our code cannot understand the categorical variable. So we need to encode it, right? Next, what I'm doing is I'm resizing my image to 50 cross 50. And I am converting it to a grayscale image, right? And once this is done, I'm going to split my data set into training and testing parts. So yeah, we are basically splitting the data set into two parts for training and testing. And here we are defining a model. So you can I can just go ahead and throw in a comment here. Building the model. Yeah. So this is where we are building the model. So basically what we have done here is we have resized our image to 50 cross 50 cross 1 matrix, and that is the size of the input that we are using, right? This input that I'm talking about. Then what we have done, a convolution layer we have defined with 32 filters and a stride of 5 with an activation function, a ReLU. And after that, we have added a pooling layer, max pool layer. Okay. Again, what we have done, we have repeated the same process, but over here we are taking 64 filters and 5 stride, passing it through a ReLU activation function, and after that we have a pooling layer, max pool layer. Then we have repeated the same process for 128 filters. After that we have repeated for 64 filters, then for 32 filters, and after that we are using a fully connected layer with 1024 neurons. And finally we are using the dropout layer with key probability of 0.8 to finish our model. So this is where our model is actually finished. And then what we are doing is we are using the Adam optimizer to optimize our model. So basically whatever the loss that we have, we are trying to reduce it. And this is basically for your TensorBoard. So we are creating some log files, and then with that log file, TensorBoard will create a pretty fancy graphs for us that helps us to visualize the entire model. And then what we are doing is we are trying to fit the model. And we have defined epochs as 10. That is the number of iterations that will happen will be 10. And yeah, so this is pretty much it. Model name we have given. Then input is x_test to check the accuracy. Similarly, the target will be y_test. The labels associated with that test data will be a y_test, and which we have encoded basically. So this is how we are going to actually calculate the accuracy, and we'll try to reduce the loss as much as possible in 10 epochs. So till now our model is complete. We are done with it. Next, what I'm doing is I'm feeding in some random input from the test data, and I'm validating whether my model is predicting it correct or not. All right. So I've already trained the model because it takes a lot of time, and yeah, I cannot do it here. So I've already trained the model, and you can see that the loss that came after the 10th epoch is 0.2973, and the accuracy is somewhere around 88%, which is pretty good, guys. And yeah, and I've done the prediction on the test data as well. So let me just show it to you that. So this is the prediction that it has done on few of the images in the test data. So yeah, it is a cat predicted as cat, cat predicted as cat, cat, and dogs as well. There are certain dogs as well.
Here's a simple question. What is the main purpose of convolutional neural networks? And the options are A. Text classification, B. Image processing, C. Time series forecasting, and D. Reinforcement learning. If you know the correct answer, please leave it in the comment section below. Following our exploration of CNN, we'll learn about recurrent neural networks, which are essential for handling sequential data like text and time series.
Why can't we use feed-forward networks? Now let us take an example of a feed-forward network that is used for image classification. So we have trained this particular network for classifying various images of animals. Now if you feed in an image of a dog, it will identify that image and will provide a relevant label to that particular image. Similarly, if we feed in an image of an elephant, it will provide a relevant label to that particular image as well. Now if you notice, the new output that we have got, that is classifying an elephant, has no relation with the previous output, that is of a dog. Or you can say that the output at time t is independent of output at time t minus 1. As we can see that there is no relation between the new output and the previous output. So we can say that in feed-forward networks, outputs are independent to each other. Now there are a few scenarios where we actually need the previous output to get the new output. Let us discuss one such scenario. Now what happens when you read a book? You'll understand that book only on the understanding of your previous words. Alright, so if I use a feed-forward network and try to predict the next word in a sentence, I can't do that. Why can't I do that? Because my output will actually depend on the previous outputs. But in the feed-forward network, my new output is independent of the previous outputs. That is, output at t plus 1 has no relation with output at t minus 2, t minus 1 and at t. So basically, we cannot use feed-forward networks for predicting the next word in a sentence. Similarly, you can think of many other examples where we need the previous output, some information from the previous output, so as to infer the new output. This is just one small example. There are many other examples that you can think of. So we'll move forward and understand how we can solve this particular problem. So over here, what we have done, we have input at t minus 1. We'll feed it to our network. Then we'll get the output at t minus 1. Then at the next timestamp, that is at time t, we have input at time t that will be given to our network along with the information from the previous timestamp, that is t minus 1, and that will help us to get the output at t. Similarly, at output for t plus 1, we have two inputs. One is a new input that we give. Another is the information coming from the previous timestamp, that is t, in order to get the output at time t plus 1. Similarly, it can go on. So over here, I have just written a generalized way to represent it. There's a loop where the information from the previous timestamp is flowing. And this is how we can solve this particular challenge. Now let us understand what exactly are recurrent neural networks. So for understanding recurrent neural network, I'll take an analogy. Suppose your gym trainer has made a schedule for you. The exercises are repeated after every third day. Now this is the order of your exercises. First day you'll be doing shoulder, second day you'll be doing biceps, third day you'll be doing cardio. And all these exercises are repeated in a proper order. Now what happens when we use a feed-forward network for predicting the exercise today? So we'll provide in the inputs such as day of the week, month of the year, and health status. All right, and we need to train our model or our network on the exercises that we have done in the past. After that, there'll be a complex voting procedure involved that will predict the exercise for us. And that procedure won't be that accurate. So whatever output we'll get won't be as accurate as we want it to be. Now what if I change my inputs and I make my inputs as what exercise I've done yesterday? So if I've done shoulder, then definitely today I'll be doing biceps. Similarly, if I've done biceps yesterday, today I'll be doing cardio. Similarly, if I've done cardio yesterday, today I'll be doing shoulder. Now there can be one scenario where you are unable to go to gym for one day. Due to some personal reasons, you could not go to the gym. Now what will happen at that time? We'll go one timestamp back and we'll feed in what exercise that happened day before yesterday. So if the exercise that happened day before yesterday was shoulder, then yesterday there were biceps exercises. Alright, similarly biceps happened day before yesterday, then yesterday would have been cardio exercises. Similarly, if cardio would have happened day before yesterday, yesterday would have been shoulder exercises. Alright, and this prediction, the prediction for the exercise that happened yesterday will be fed back to our network, and these predictions will be used as inputs in order to predict what exercise will happen today. Similarly, if you have missed your gym say for 2 days, 3 days or 1 week, so you need to roll back. You need to go to the last day when you went to the gym. You need to figure out what exercise you did on that day, feed that as an input, and then only you'll be getting the relevant output as to what exercise will happen today. Now what I'll do, I'll convert these things into a vector. Now what is a vector? Vector is nothing but a list of numbers. Alright, so this is the new information guys along with the information from the prediction at the previous timestamp. So we need both of these in order to get the prediction at time t. Imagine if I have done shoulder exercises yesterday. So this will be 1, this will be 0, and this will be 0. Now the prediction that will happen will be biceps exercise because if I have done shoulder yesterday, today it will be biceps. So my output will be 0, 1 and 0. And this is how vectors work, guys. So I hope you have understood this, guys. Now, this is how a neural network looks like, guys. We have new information along with the information from the previous timestamp. The output that we have got in the previous timestamp will use certain information from that, will feed into our network as inputs, and then that will help us to get the new output. Similarly, this new output that we have got will take some information from that, feed in as an input to our network along with the new information to get the new prediction, and this process keeps on repeating. Now, let me show you the math behind the recurrent neural networks. So this is the structure of a recurrent neural network, guys. Let me explain you what happens here. Now consider at time t equals to 0, we have input x naught, and we need to figure out what is h naught. So according to this equation, h of 0 is equal to wi weight matrix multiplied by our input x of 0 plus wr into h of 0 minus 1, which is h of minus 1, and time can never be negative, so this particular equation cannot be applied here, plus a bias. So wi into x of 0 plus bh passes through a function g of h to get h of 0 over here. After that, I want to calculate y naught. So for y naught, I'll multiply h of 0 with the weight matrix wi, and I'll add a bias to it and pass it through a function g of y to get y naught. Now in the next timestamp, that is at time t equals to 1, things become a bit tricky. Now let me explain you what happens here. So at time t equals to 1, I have input x1. I need to figure out what is h1. So for that, I'll use this equation. So I'll multiply wi, that is a weight matrix, by the input x1 plus wr into h of 1 minus 1, which is 0. H of 0, we know what we got from here. So wr into h of 0 plus the bias, pass it through a function g of h to get the output as h1. Now this h1 we'll use to get y1. We'll multiply h1 with wi plus a bias and we'll pass it through a function g of y to get y1. Similarly, the next timestamp, that is at time t equals to 2, we have input x2. We need to figure out what will be h2. So we'll multiply the weight matrix wi with x of 2 plus wr into h of 1 that we have got here plus b of h and pass it through a function g of h to get h of 2. From h of 2, we'll calculate y of 2, wi into h of 2 plus by, that is the bias, pass it through a function g of y to get y2. And this is how recurrent neural network works, guys. Now you must be thinking how to train a recurrent neural network. So a recurrent neural network uses backpropagation algorithm for training. But backpropagation happens for every timestamp. That is why it is commonly called as backpropagation through time. And I've discussed backpropagation in detail in artificial neural network tutorial, so you can go through that. Over here, I won't be discussing backpropagation in detail. I'll just give you a brief introduction of what it is. Now with backpropagation, there are certain issues, namely vanishing and exploding gradients. Let us see those one by one. So in vanishing gradient, what happens? When you use backpropagation, you tend to calculate the error, which is nothing but the actual output that you already know minus the model output, the output that you got through your model, and the square of that. So you figure out the error. With that error, what do? You tend to find out the change in error with respect to change in weight or any variable. So we'll call it weight here. So change of error with respect to weight multiplied by learning rate will give you the change in weight. Then you need to add that change in weight to the old weight to get the new weight. All right. So obviously what we are trying to do, we are trying to reduce the error. So for that, we need to figure out what will be the change in error if my variables are changed, right? So that way we can get the change in the variable and add it to our old variable to get the new variable. Now over here, what can happen if the value dE by dW, that is a gradient, or you can say the rate of change of error with respect to our variable weight, becomes very small than 1, like it is 0.00 something. So if you multiply that with the learning rate, which is definitely smaller than 1, then you get the change of weight, which is negligible. All right. So there might be certain examples where you are trying to predict, say, a next word in a sentence, and that sentence is pretty long. For example, if I say I went to France dash dash dash, I went to France, then there are certain words, then I say few of them speak dash. Now I need to predict speak, what will come after speak. So for that, I need to go back in time and check what was the context, which will be very complex. And due to that, there will be a lot of iterations. And because of that, this error, this change in weight will become very small, very small. So the new weight that we'll get will be actually almost equal to your old weight. So there won't be any updation of weight that will be happening. And that is nothing but your vanishing gradient. All right, I'll repeat it once more. So what happens in backpropagation, you first calculate the error. This error is nothing but the difference between the actual output and the model output and the square of that. With that error, we figure out what will be the change in error when we change a particular variable, say weight. So dE by dW, multiply it with learning rate to get the change in the variable or change in the weight. Now we'll add that change in the weight to our old weight to get the new weight. This is what backpropagation is, guys. Alright, I'm just giving you a small introduction to backpropagation. Now consider a scenario where you need to predict the next word in a sentence. And your sentence is something like this. I have been to France. Then there are a lot of words. After that, few people speak, and then you need to predict what comes after speak. Now if I need to do that, I need to go back and understand the context. What is it talking about? And that is nothing but your long-term dependencies. So what happens during long-term dependencies, if this dE by dW becomes very small, then when you multiply it with n, which is again smaller than 1, you get delta W, which will be very, very small. That will be negligible. So the new weight that you'll get here will be almost equal to your old weight. So I hope you're getting my point. So this new weight, so there will be no updation of weights, guys. This new weight will always be almost equal to our old weight. So there won't be any learning here. So that is nothing but your vanishing gradient problem. Similarly, when I talk about exploding gradient, it is just the opposite of vanishing gradient. So what happens when your gradient or dE by dW becomes very large, becomes greater than 1, all right? And you have some long-term dependencies. So at that time, your dE by dW will keep on increasing, delta W will become large, and because of that, your weights, the new weight that will come, will be very different from your old weight. So these two are the problems with backpropagation. Now let us see how to solve these problems. Now exploding gradients can be solved with the help of truncated BTD, backpropagation through time. So instead of starting backpropagation at the last timestamp, we can choose a smaller timestamp like 10. Or we can clip the gradients at a threshold. So there can be a threshold value where we can, clip the gradients. And we can adjust the learning rate as well. Now for vanishing gradient, we can use a ReLU activation function. Similarly, we can also use LSTM and GRUs. Now let us understand what exactly are LSTMs. So guys, we saw what are the two limitations with the recurrent neural networks. Now we'll understand how we can solve that with the help of LSTMs. Now what are LSTMs? Long short-term memory networks, usually called as LSTMs, are nothing but a special kind of recurrent neural network. And these recurrent neural networks are capable of learning long-term dependencies. Now what are long-term dependencies? I've discussed that in the previous slide, but I'll just explain it to you here as well. Now what happens, sometimes we only need to look at the recent information to perform the present task. Now let me give you an example. Consider a language model trying to predict the next word based on the previous ones. If we are trying to predict the last word in the sentence, say the clouds are in the sky. So we don't need any further context. It's pretty obvious that the next word is going to be sky. Now in such cases where the gap between the relevant information and the place that it's needed is small, RNNs can learn to use the past information. And at that time, there won't be such problems like vanishing and exploding gradient. But there are few cases where we need more context. Consider trying to predict the last word in the text, I grew up in France. Then there are some words. After that comes, I speak fluent French. Now recent information suggests that the next word is probably the name of a language. But if we want to narrow down which language, we need the context of France from further back. And it's entirely possible for the gap between the relevant information and the point where it is needed to become very large. And this is nothing but long-term dependencies. And the LSTMs are capable of handling such long-term dependencies. Now LSTMs also have a chain-like structure like recurrent neural networks. Now all the recurrent neural networks have the form of a chain of repeating modules of neural networks. Now in standard RNNs, the repeating module will have a very simple structure such as a single TANH layer that you can see. Now this TANH layer is nothing but a squashing function. Now what I mean by squashing function is to convert my values between -1 and 1. Alright, that's why we use TANH. And this is an example of an RNN. Now we'll understand what exactly are LSTMs. Now this is a structure of an LSTM. Or if you notice, LSTM also have a chain-like structure, but the repeating module has different structures. Instead of having a single neural network layer, there are 4 interacting in a very special way. Now the key to LSTM is the cell state. Now this particular line that I'm highlighting, this is what is called the cell state. The horizontal line running through the top of the diagram. So this is nothing but your cell state. Now you can consider the cell state as a kind of a conveyor belt. It runs straight down the entire chain with only some minor linear interactions. Now what I'll do, I'll give you a walkthrough of LSTM step by step, alright? So we'll start with the first step. Alright guys, so the first step in our LSTM is to decide what information we are going to throw away from the cell state. And you know what is the cell state, right? I've discussed in the previous slide. Now this decision is made by the sigmoid layer. So the layer that I'm highlighting with my cursor, it is the sigmoid layer called the forget gate layer. It looks at ht-1, that is the information from the previous timestamp, and xt, which is the new input, and outputs a number between 0 and 1 for each number in the cell state ct-1, which is coming from the previous timestamp. A 1 represents completely keep this, while a 0 represents completely get rid of this. Now if we go back to our example of a language model trying to predict the next word based on all the previous ones, in such a problem, the cell state might include the gender of the present subject so that the correct pronouns can be used. When we see a new subject, we want to forget the gender of the old subject, right? We want to use the gender of the new subject. So we'll forget the gender of the previous subject here. This is just an example to explain you what is happening here. Now let me explain you the equations which I've written here. So ft will be combining with the cell state later on, that I'll tell you. So currently ft will be nothing but the weight matrix multiplied by ht-1 and xt and plus the bias, and this equation is passed through a sigmoid layer. All right, and we get an output that is 0 and 1. 0 means completely get rid of this, and 1 means completely keep this. All right, so this is what basically is happening in the first step. Now let us see what happens in the next step. So the next step is to decide what information we are going to store. In the previous step, we decided what information we are going to keep, but here we are going to decide what information we are going to store here. All right, what new information we are going to store in the cell state. Now this has two parts. First, a sigmoid layer, this is called a sigmoid layer, and which is also known as an input gate layer, decide which values we'll update. All right, so what values we need to update. Then there's also a tan-hash layer that creates a vector of the candidate values c bar of t-1 that will be added to the state later on. All right, so let me explain it to you in a simpler terms. So whatever input that we are getting from the previous timestamp and the new input, it will be passed through a sigmoid function which will give us I of t. All right, and this I of t will be multiplied by ct, which is nothing but the input coming from the previous timestamp and the new input with that is passed through a tan-h that will result in ct. And this will be later added on to our cell state. And the next step will combine these two to update the states. Now let me explain the equations. So I of t will be what? Weight matrix, and then we have ht-1 comma xt multiplied by the weight matrix plus the bias, pass it through a sigmoid function, we get I of t. C bar of t will get by passing a weight matrix ht-1 xt plus bias through a tan-h squashing function, and we'll get C bar of t. All right, so as I've told you earlier as well, in the next step we'll combine these two to update the state. Let us see how we do that. So now is the time to update the old cell state ct-1 with the new cell state ct. All right, and the previous steps we have already decided what to do. We just need to actually do it. So what we'll do, we'll multiply the old cell state ct-1 with ft that we got in the first step, forgetting the things that we decided to forget earlier in the first step, if you can recall. Then what we do, we add it to it and ct, then we add it by the term that will come after multiplication of it and c bar t, and this new candidate value scaled by how much we decided to update each state value. All right, so in the case of the language model that we were discussing, this is where we would actually drop the information about the old subject gender and add the new information as we decided in the previous steps. So I hope you are able to follow me, guys. All right, so let us move forward and we'll see what is the next step. Now our last step is to decide what we are going to output, and this output will depend on a cell state, but it will be a filtered version. Now finally what we need to do is we need to decide what we are going to output, and this output will be based on our cell state. First we need to pass ht-1 and xt through a sigmoid activation function so that we get an output that is OT. All right, and this OT will be in turn multiplied by the cell state after passing it through a tan-h squashing function or an activation function. And why we do that? Just to push the values between -1 and 1. So after multiplying OT, that is this value, and a tan-h CT, we'll get the output H2, which will be our new output, and that will only output the part that we decided to. Whatever we have decided in the previous steps, it will only output that value. All right. Now I'll take the example of that language model again. Since it just saw a subject, it might want to output information relevant to a verb, and in case that's what is coming next. For example, it might output whether the subject is singular or plural, so that we know what form of a verb should be conjugated into. All right, and you can see from the the equations as well. Again, we have a sigmoid function Then that whatever output we get from there, we multiply it with tan-H-CT to get the new output. All right, guys. So this is basically LSTMs in a nutshell. So in the first step, we decided what we need to forget. In the next step, we decided what are we going to add to our cell state, what new information we are going to add to our cell state, and we were taking an example of the gender throughout this whole process. All right. And in the third step, what we do, we actually combined it to get the new cell state. Now in the fourth step, what we did, we finally got the output that we want. And how we did that? Just by passing ht minus 1 and xt through a sigmoid function, multiplying it with the tan-H-CT, the tan-H new cell state, and we get the new output. Fine, guys. So this is what basically LSTM is, guys. Now we'll look at a use case where we'll be using LSTM to predict the next word in a sentence. All right, let me show you how we are going to do that. So this is what we are trying to do in our use case, guys. We'll feed our LSTM with correct sequences from the text of 3 symbols. For example, had a general and a label that is council in this particular example. Eventually, our network will learn to predict the next symbol correctly. So obviously, we need to train it on something. Let us see what we are going to train it on. So we'll be training our LSTM to predict the next word using a sample short story that you can see over here. All right, so it has basically 112 unique symbols. So even comma and full stop are considered as symbols. All right, so this is what we are going to train it on. So technically, we know that LSTMs can only understand real numbers. All right, so what we need to do is we need to convert these unique symbols into a unique integer value based on the frequency of occurrence. And like that, we'll create a dictionary. For example, we have had here that will have value 20. A will have value 6. General will have value 33. All right, and then what happens, our LSTM will create a 112 element vector that will contain the probability of each of these words or each of these unique integer values. All right, so since 0.6 has the highest probability in this particular vector, it will pick the index value of 0.6, then it will see what symbol is attached to that particular integer value. So 37 is attached to council. So this will be our prediction, which is absolutely correct, as a label is also council according to our training data. All right, so this is what we are going to do in our use case. So guys, this is what we'll be doing in our today's use case. Now I'll quickly open my PyCharm and I'll show you how you can implement it using Python. We'll be using TensorFlow, which is a popular Python library for implementing deep neural networks or neural networks in general. All right, so I'll quickly open my PyCharm now. So guys, this is my PyCharm, and over here I've already written the code in order to execute the use case that we have. So first we need to do is import the libraries. NumPy for arrays, TensorFlow, we know TensorFlow.contrib. From that we need to import RNN, then random collections and time. All right, so this particular block of code is used to evaluate the time taken for the training. After that we have log_path, and this log_path is basically telling us the path where the graph will be stored. All right, so there will be a graph that will be created, and then that graph will be launched. Then only our RNN model will be executed. Then that's how TensorFlow works, guys. So that graph will be created in this particular path. All right, and we are using summary writer, so that will actually create the log file that will be used in order to display the graph using TensorBoard. All right, so then we have defined a training_file, which will have our story on which we'll train our model on. Then what we need to do is read this file. So how are we going to do that? First is read line by line whatever content that we have in our file. Then we are going to strip it. That means we are going to remove the first and the last white space. Then again we are splitting it just to remove all the white spaces that are there. After that we're creating an array, and then we are reshaping it. Now during the reshape, if you notice, this -1 value tells us the compatibility. All right, so when you're reshaping it, you need to make sure that we are providing in the correct parameters to reshape it. So you can convert a 3x2 matrix to a 2x3 matrix, right? So just to make sure that it is compatible enough, we add this -1 and it will be done automatically. All right, then return content. After that, what we are doing, we are feeding in the training data that we have, training_file. We are feeding in our story and calling the function read_data. Then what we are doing, we are creating a dictionary. What is a dictionary? We all know key value pairs based on the frequency of occurrences of each symbol. All right, so from here, collections.counter words.most common. So most common words with their frequency of occurrence, there will be a dictionary created. And after that, we'll call this dict function, and this dict function will feed in word, and which is equal to length of dictionary. That means whatever the length of that particular dictionary is, how many times it is repeated. So we'll have the frequency as well as a symbol. That will be our key value pair, and we are reversing it as well. Then what we are doing, we are calling it build_data set, and we're feeding in our training data there. This is our vocabulary size, which is nothing but the length of your dictionary. And then we have defined various parameters such as learning rate, iterations or epochs. Then we have display step and underscore input. Now learning rate, we all know what it is. The steps in which our variables are updated. Training underscore iterations is nothing but your epochs, the total number of iterations. So we have given 50,000 iterations here. Then we have display underscore step, that is 1000, which is basically your batch size. So batch size is what? After every 1000 epochs, you'll see the output. All right. So it'll be processing it in batches of 1000 iterations. Then we have n underscore input as 3. Now the number of units in the RNN cell will keep it as 512. Then we need to define X and Y. So X will be our placeholder that will have the input values, and Y will have all the labels. All right. Vocab size. So X is a placeholder where we'll be feeding in our input dictionary. Similarly, Y is also one more placeholder, and it'll have a shape of none, comma, vocab size. Vocab size we have defined earlier, as you can see, which is nothing but the length of your dictionary. Then we are defining weights as well as biases. After that, we have defined our model. All right. So this is how we are going to define it. We'll create a function RNN when we'll have X weights and biases. And after that, we are calling in RNN.multi-RNN cell function. And this is basically to create a 2-layer LSTM, and each layer has n underscore hidden units. After that, what we are doing, we are generating the predictions. But once we have generated the prediction, there are n underscore input outputs, but we only want the last output. All right. So for that, we have written this particular line. And then finally, we are making a prediction. We are calling this RNN function, feeding in X weights and biases. After that, we are calculating the loss and then we are optimizing it. For calculating the loss, we are using reduce underscore mean, softmax cross entropy, and this will give us basically the probability of each symbol, and then we are optimizing it using RMS prop optimizer. All right, and this gives actually a better accuracy than Adam optimizer, and that's the reason why we are using it. Then we are going to calculate the accuracy, and after that we are going to initialize the variables that we have used. As we have seen in TensorFlow that we need to initialize all the variables, unlike constants and placeholders in TensorFlow. All right, and once we are done with that, we are feeding in our values, then calculating the accuracy, how accurate it is, and then when optimization is done, we are calculating the elapsed time as well. So that will give us how much time it took in order to train our model. Then this is just to run the tensor board on local host 6006, and this particular block of code is used in order to handle the exceptions. So exceptions can be like whatever word that we are putting in might not be there in our dictionary or might not be there in our training data. So those exceptions will be handled here, and if it is not there in our dictionary, then it will print word not in a dictionary. All right, so fine guys, let's input some values and we'll have some fun with this model. All right, so the first thing that I'm gonna feed in is had a general. So whenever I feed in these three values, had a general, there will be a story that will be generated by feeding back the predicted output as the next symbol in the inputs. All right. So when I feed in had a general, so it will predict the correct output as council, and this council will be fed back as a part of the new input, and our new input will be a general council. So it will be a general council. All right. So these three words will become our new input to predict the new output, which is 2. All right, and so on. So surprisingly, LSTM actually creates a story that somehow makes sense. So let's just read it. Had a general council to consider what measures they could take to outwit their common enemy, the cat. By this means, we should always know when she was about and could easily. All right, so somehow it actually makes sense when you feed in that. So what will happen when you feed in these three inputs? It will predict the next word, that is council. After that, it will take council and it will feed back as an input along with a general. So a general council will be your next input to predict 2. Similarly, in the next iteration, it will take general council 2 and predict consider for us. And this will keep on repeating.
With a solid understanding of neural networks, let's introduce Keras, where learners will learn how to simplify the process of building deep learning models.
Keras is a Python-based deep learning framework which is actually the high-level API of TensorFlow. And now I have 4 major highlights for you guys, so let's check it out from the start. Well, Keras basically runs on top of Theano, TensorFlow or CNTK. Since it runs on top of any of these frameworks, Keras is amazingly simple to work with. You might be wondering why. Well, building models are as simple as stacking layers and later connecting these graphs. Guys, Keras attracts a lot of attention, but why? Since it is open source, it is actively developed by all the contributors across the world and the documentation is nearly endless. Well, we're good with the documentation, but how does Keras perform? Guys, since it is an API which is actually used to specify and train differentiable programs, high performance naturally follows through here. So now that we know what Keras actually is, who makes Keras what it is? Well, we need to check out some of the contributors and the backers to the deep learning framework. Well guys, Keras had over 4,800 contributors during its launch and the initial stages. And now that number has gone up to 250,000 active developers. Well, what amuses me is that there is a 2x growth every year since its launch. Also, it holds a really good amount of traction among multiple startups. Big players like Microsoft, Google, Nvidia, and Amazon actively contribute to the development of Keras. Good enough? So at this point, I'm sure all of you are curious about who uses Keras. Well, Keras has an amazing industry traction and it is used in the development of popular firms like Netflix, Uber, Expedia, Yelp, and more. Well, now that you know, the next time you watch a movie on Netflix or book an Uber, you know Keras is being used. So guys, if Keras is getting all this attention, what makes it so special? What makes Keras stand out among all the top framework? Here I have for you top 10 snippets that makes Keras so special. Well guys, the focus on user experience has always been the major part of Keras. And next, large adoption in the industry, definitely. We just checked out all of the industry traction it gets and this holds well. And next, it is multi-backend and supports multi-platform as well. This helps all the coders come together and code easily. Next up, the research community present for Keras is amazing along with the production community. So this is a win-win for me guys. So what do you think? And moving on, all the concepts are really easy to grasp with Keras guys. And next up, it supports fast processing, which is really good. And guys, it runs seamlessly on both the CPU and the GPU, and it has support for both Nvidia and AMD as well. And the best part for me is the freedom to design on any architecture and then later implement it as an API for your projects, guys. This definitely is a major advantage for me. So next up, for all the beginners, Keras is really simple to get started with, and I'm here to help you guys with this tutorial for that. So stay tuned. And lastly, the easy production of models makes Keras that much special, guys. Now that we know Keras is special, guys, let's dig in a little bit about one of the major concepts which make Keras what it is, the user experience. Well, in my opinion, this is very important for anyone who wants to know more about Keras, or better, they want to start creating their own neural nets using Keras. So clearly, Keras is an API designed for humans. Well, why so? Because it follows the best practices for reducing cognitive load, which ensures that the models are consistent and the corresponding APIs are simple. And moving on, Keras provides clear feedback upon occurrence of any error, and this minimizes the number of user actions required for the majority of the common use cases, guys. And lastly, Keras provides high flexibility to all of its developers. Well, we all love high flexibility, right? So how is Keras doing this? Guys, it's very simple. It integrates with lower level deep learning framework languages like TensorFlow or Theano. So guys, this ensures that you can implement anything in Keras which you actually built in your base language, which is amazing. So next up, we need to talk about how Keras supports the claim of being able to support multi-platform and lets us work with multiple backends. You can develop Keras in Python as well as R. The code can be run with TensorFlow, CNTK, Theano, or MXNet, totally based on your requirement. This almost feels like a tailor-made API for the framework, guys. The code can be run on the CPU or the GPU as well. Support for both the big players being Nvidia and AMD here. So this ensures that producing models with Keras is really simple. Total support to run with TensorFlow serving, GPU acceleration such as CUDA when using modules such as WebKeras and Keras.js, native support to develop Android and iOS apps using TensorFlow and Core ML, and yes, full-blown support to work with Raspberry Pi as well. So guys, moving on, we need to check one quick concept which forms the backbone as a working principle of Keras. So let's check out a computation graph. Here is an example for you guys. Just before decoding and working our way through the graph, let's look at the features. So guys, do note that computational graphs are used for expressing complex expression as a combination of simple operations for Keras to work with. It is mainly useful for calculating the derivatives during the phase of backpropagation, and hence it makes it easier to implement distributed computing on the whole. So all it takes is to specify the inputs, outputs, and to make sure that the graph is connected throughout. I hope you guys know what a connected graph is. So let's check out our graph. We'll be working away from the leaf nodes to the top. So guys, here as you can see, E equal to C multiplied with D, where C is equal to A plus B and D is equal to B plus 1. So all we're doing is we're making sure we land at E equal to C cross T, which is the head of our tree, And we get to this by performing two operations on the leaf nodes. So as you can see, working down further, E equal to A plus B into B plus 1 actually makes sense now. And in our case, A and B are inputs. So guys, it is as simple as that. So next, let's dive a little bit deeper and check out the two major models, guys. So the first model is a sequential model. The working is basically like a linear stack of layers. So the first thing that comes into my mind when I think about the layered approach is the sequential model. It is majorly useful for building simple classification network and encoder-decoder model, guys. And definitely yes, this is the model which we all know and love. So here we basically treat every layer as an object that feeds into the next layer and so on. And now in the simple code, we'll import Keras into Python. We define the model as sequential, and with the hidden layers, we have 20 neurons and we'll be using ReLU here. ReLU is rectified linear unit, guys. It is one of the activation functions we'll be using. Well, model.fit is used to train the network. Here, by epoch, I'm sure all of you guys are familiar with it already. So it is basically the forward and the backward pass of all of our training examples. And batch size is really straightforward as well. It is the number of training examples in one forward and backward pass, guys. So higher the batch size, the more the memory you'll need. So next, we need to check out the functional model. It is widely used and it holds good for about 95% of the use cases. Well, imagine the concept of playing with Legos, guys. I'm pretty sure most of us have played with Legos in our childhood. It's pretty much the same here as well. Well, the highlights of the functional model is that it supports multi-input, multi-output, and an arbitrary static graph topology. We have branches, so whenever we have a complex model, the model is forked into two or more branches based on the requirement, guys. The code which we have here is pretty much similar to the previous one, but with subtle changes. We first import the models, we work on its architecture, and lastly, we train the network. Well, with functional models, we have this concept called as domain adaptation. So guys, what we did until this stage is that we train a model on one domain but test it on the other. This definitely results in poor performance on the overall test dataset because the data is different for each of the domains, right? So what's the solution for this? Well, we adapt the model to work on both the domains at the same time. And guys, we'll be looking at a very interesting use case using the functional models in the upcoming slides. So stay tuned for that. So moving on, we need to understand about the two basic types of execution in Keras, deferred and eager execution. It is also called as symbolic and imperative execution as well. Well, with deferred, we use Python to build a computation graph first like we previously discussed, and then this compiled graph gets executed. Well, with eager execution, there is a slight change, guys. It is here that the Python runtime itself becomes the execution runtime for all of the models. It is very similar to execution with NumPy. So if you're familiar with NumPy, then it's a cakewalk, guys. So on the whole, here is a quick note. Symbolic tensors don't have a value in the Python code as of yet, but eager tensors will have a value in the Python code. And with eager execution, we make use of a type of recurring neural networks called as trees. So guys, it is basically a value dependent dynamic topology structure. So what are you guys thinking about Keras at this point? Well, it is actually really easy to grasp, guys. Well, next, let's look at the steps needed to implement our own neural network using Keras. There are 5 major steps here, guys. So starting out, we need to prepare the inputs for the model. We do this by analyzing our requirements and specifying the input dimensions. Well, as you know it, the common inputs are images, videos, text, or audio based on your model requirement. The next step is to actually define the artificial neural network model. Here, we do everything from defining the model architecture to building the computation graph and also defining the style we'll be using for the model. It is as straightforward as that. Well, step 3 is to specify the optimizer. Think of it this way, a neural network is just a complex function. We need to simplify the process of making the machine learn. Well, the optimizer is just for that. There are many types of optimizers such as SGD, which is stochastic gradient descent. We have RMSProp, which is based on root mean square, and ADAM, and so on. And the next step is to define the loss function. So for every step in our training, we'll be checking the accuracy of prediction by comparing the obtained value with the actual one. We check for the difference between them and we print out the loss, guys. Well, the goal is to actually define a function which we will use to reduce the losses in each pass of the training phase. There are many types of loss functions such as MSE, which is mean squared error, and we have cross entropy loss, which is also called as the log loss in most cases, and so on. And the last step is to actually train the network based on the input data, which is also called as a training data. And after training, we will need to test the model based on the trained data to check if the model actually learned anything. So it is as simple as this, guys. What do you think? I would love to know your views on this, so head to the comment section. Let's have an interaction there. And now, guys, let's spice things up a bit. I'm sure you guys were curious about the use case, so let me walk you through the entire thing. Well, we'll be checking out a wine classifier in this use case, so let's begin by checking out our problem statement. So we're trying to predict the price of a bottle of wine just by knowing the description and the variety of wine. Well, we can work this out with the Keras functional API and TensorFlow. We'll be building a wide and a deep network using Keras to make predictions for us. Well, can we achieve this goal? Yes, we can. This is a problem statement suited for wide and deep learning networks, as I mentioned. Well, it involves textual input and there isn't any correlation between the wine's description and its price. Well, this is what makes it fun in my opinion, guys. So next we need to check out the model. A lot of Keras models are built using the sequential model API as I told you earlier. But let's make use of the functional API for our use case. Well, true, the sequential API is still the best way to get started with Keras. Why? Because it lets you define models easily as a stack of layers like I explained earlier. However, the functional model allows for more flexibility and is best suited for models with multiple inputs. So we need to know a little bit about wide and deep model, guys. Well, wide models are models with sparse feature vectors. Well, what I mean by sparse feature vectors is that it consists of mostly zeros and a little bit of ones. And deep networks are networks which do really well on tasks like speech and image recognition. So now that that's sorted, we need to take a look at the dataset. Well, for this case, we'll be using a wine dataset from Kaggle. So what's the data? Well, it's basically 12 columns of data and it's as follows. Here we'll be talking about the country that the wine is from. Next up is description, a few sentences from the sommelier describing the wine's taste, smell, look and feel. A sommelier is a person who is a professional wine taster, guys. Next up is designation, the vineyard within the winery where the grapes that the wine has been made from. Next up is points, the number of points that the wine enthusiasts rated the wine on a scale of 1 to 10. However, they only say that they post reviews for the wines which scores greater than equal to 80. Next up is price, the cost of the bottle of the wine obviously, followed by province, the province or the state where the wine is from. Next up I have something called as region 1. Well, with region 1, it's the wine growing area in a province or a state. Let's say for example India. Next I have region 2. Well, sometimes there are more specific regions within a specified wine growing area. For example, we can say Bangalore, India, but this value can sometimes be blank as well. Next up is taster's name. Well, as it suggests, it's the name of the person who tasted and reviewed the wine. Taster Twitter handle for the person who tasted and reviewed the wine. Well, the title of the wine review, which often contains the vintage if you're interested in extracting that feature. Variety, the type of the grapes that is used to make the wine. Let's say for example Pinot Noir, that's a type of the grape. And finally, the winery that made the wine. Guys, the overall goal here is to actually create a model that can identify the variety, winery and the location of a wine based on the description alone. And this dataset offers some really great opportunities for sentiment analysis and other text-related predictive models as well. So now that that's clear, we need to take a look at the sample data case. So here we have a description for the wine such as scent, if it's tart, firm or needs more decanting, etc. So this forms our input for the model, guys. And the output our model provides just from all of this textual information is the pricing that it predicts. How cool is that, guys? So basically we need to check out some of the prerequisites before jumping into the code. Since you're working with Python, we'll require pandas, we'll require NumPy, scikit-learn and Jupyter Notebook. So yes, Keras works on top of TensorFlow, so we'll require both Keras and TensorFlow to be installed on the machine. So now that that's done, moving on, let's look at a small piece of code. Here are all the inputs that we'll require to build the model. And lastly, we test the presence of TensorFlow by printing the installed version. Well, without TensorFlow, it wouldn't make any sense. So we go to Kaggle and download the data and end up converting the data to a pandas data frame, guys. Well, that's good enough to start. Let's look at the code for this model. I'll quickly open up Google Colaboratory, which is basically a Jupyter Notebook hosted on their Google Cloud. You can actually do this on your local machine as well by installing all of the frameworks that I've previously mentioned. So let me go ahead and open Colaboratory and let's begin, guys. So guys, we'll be executing each of these blocks and we'll be going on from there. So let us check out the first block. So here we import all of the modules that we require. So guys, let me run it. And that's done. So next we need to install the latest version of TensorFlow. Well, with Google Colab, it doesn't require any extra setup, so it's pretty much straightforward. So guys, that took about 2 minutes and TensorFlow is installed. And as I explained before, we need to import the models that we'll use to build the model. And after that, we'll actually run the code to check the version output of the TensorFlow that we just installed. And the output we're supposed to be expecting is version 1.7 because 1.7 is the TensorFlow version that we installed. As you can check out the output, you have TensorFlow version 1.7. So beautiful. So moving on, we need to download the data, which is from a CSV file hosted on the cloud. So let's go ahead and do that. Now that it is downloaded and ready, let us convert all the data from the CSV file into a pandas data frame as I mentioned. So now that that is done, let's go ahead and mix up the data by shuffling it. And yes, so let's start printing samples from our data set. So we'll be printing the first 5 rows, and as you can see, all the columns that we discussed earlier from country, price, province, all the way till a detailed description of the wine is present here. So now that that's done, next we need to do some pre-processing to limit the number of varieties of wine in the dataset. So let us go ahead and set a threshold of 500 in our case. So anything less than 500 will be removed from analysis in our model. We'll be replacing it with NaN, which is not a number, instead of letting it to be blank. So let me go ahead and run this. So now that that's done, the next step we need to do is actually split the data into a training dataset and a testing dataset. So let's go ahead and do that and print the size of both the training dataset and the testing dataset. So let me go ahead and run this code for you guys, and there it is. We have the training dataset size and the testing dataset size. Now that we have the size, we need to actually extract the testing and the training features and all of the labels. So let me go ahead and run this code and we can actually get the labels. And so that does it. The training and the testing features and the labels are known to our machine by now. So now it's very obvious that we're using a test description. Well, instead of looking at every word that we have found in our description in our dataset, let us limit our bag of words to, let's say, top 12,000 words in our dataset. So guys, don't worry, there is actually a built-in Keras utility for creating just this vocabulary. This is considered as wide because the input to our model for each description will be a 12k element wide vector with zeros and ones, indicating the presence of word from our vocabulary in a particular description. Well, Keras has some handy utilities for text pre-processing that we'll use to convert the text descriptions into a bag of words. With the bag of words model, we'll typically want to use only a subset of all the total words that we found in our dataset. And in this example, I used 12,000 words, but this is a hyperparameter that you can tune. Well, you can try out a few values to see what works best on your dataset. Well, we can use the Keras tokenizer class to create our bag of words vocabulary for us. So let me go ahead and run this to create the tokenizer. Guys, so now that that's done, we'll be actually using text to matrix function to convert each description to a bag of words vector. So let me go ahead and run it. Well, now that that's done, guys, in the original Kaggle dataset, there are about 632 total varieties of wine. To make it easier for our model to extract the patterns, we did a bit of pre-processing to keep only the top 40 varieties. Well, around 65% of the original dataset or 96k total examples. Well, we use a Keras utility to convert each of these varieties to integer representation. And then we'll create 40 element wide one-hot vectors for each input to indicate the variety. So let me go ahead and run it, guys. So now that that's run, guys, at this stage, we are ready to build our wide model. Well, guys, Keras has two APIs for building the models, the sequential API and the functional API. The functional API gives us a bit more flexibility in how we define our layers and lets us combine multiple feature inputs into one layer. It also makes it easy for our wide and deep models into one when we are ready. Guys, with the functional API, we can define our wide model in just a few lines of code as you see. Well, first we need to define our input layer as a 12k element vector, well, for each word in our vocabulary, and then we'll connect this to our dense output layer to generate the price prediction. So let me go ahead and run this. Well, now that that's done, we'll compile the model so that it is ready to use. If we were using the wide model all on its own, this is when we'd actually start training it with the fit function and evaluate later with the evaluate function. Since we're going to combine it with our deep model later on, we can hold off on training until the two models are combined, which is done later, guys. So let me go ahead and execute this so we define our wide model. And yep, our wide model is done. Let's go ahead and print out a summary from the wide model. Well, now that we have a summary, we can realize the total number of trainable parameters and non-trainable parameters. Well, in our case, the non-trainable parameters are 0, guys. So guys, that's the end to the construction of the wide model, and it's time to build our deep model. So let's go ahead and check that. Well, to create a deep representation of the wine's description, we'll represent it as an embedding. Well, there are a lot of resources on word embeddings, but the short version is that they can provide a map word to vectors so that the similar words are closer together in the vector space. Well, to convert our text descriptions to an embedding layer, we'll need to first convert each description to a vector of integers corresponding to each word in our vocabulary. We can do that with the handy Keras text to sequence method. And now we've got the integerized description vectors. We need to make sure that they're all the same to feed into our models. Well, Keras is fancy and it has a handy method for that too. We'll use pad_sequences to add zeros to each description vector so that they're all the same length. Well, in this case, I used 170 as the max length, so no descriptions were cut short. So let me go ahead and run this. Well, with our descriptions converted to vectors that are all the same length, we're ready to create our embedding layer and then feed it into our deep model, guys. So let's start building our deep model. Well, there are two ways to create an embedding layer. We can use weights from the pre-trained embeddings as I previously explained, or we can actually learn the embeddings from our vocabulary. Well, it's best to experiment with both and to see which performs better on your particular dataset. Here, we'll consider using learned embeddings. Well, firstly, we'll define the shape of our input to the deep model. Then, we'll feed it into the embedding layer, and here I'm using an embedding layer with 8 dimensions. Well, you can experiment this with tweaking the dimensionality of your embedding layer as per your choice. And the output of the embedding layer will be a 3-dimensional vectors with the following shape. Well, it'll have a batch size, a sequence length. Well, in our case, the sequence length is 170. It'll have an embedding dimension. It is 8 in our example. And in order to connect our embedding layer to the dense, fully connected output layer, we actually need to flatten it first. So let's go ahead and define our model and then we can flatten our layer. Well, once the embedding layer is flattened, it's ready to be fed into the model and to compile it. So let's go ahead and compile it. And now that the compilation is done, as you can see, the loss function we've used in this case is MSE, which is mean squared error. The optimizer we'll be using is Adams and the metrics is accuracy. And at this point of time, we have established the wide model and the deep model. So once we have defined both our models, combining them is really easy, guys. We simply need to create a layer that concatenates the output from each of the model and then merge them into a fully connected dense layer, and finally define a combined model that combines the input and the output from each one. Well, obviously, since each model is predicting the same thing, which is the price, the outputs or the labels from each one will be the same. Also, guys, do note that since the output of our model is a numeric value, we will not need to do any pre-processing and it's already in the right format as well. How cool is that? Well, that's done, guys. It's time for the training and the evaluation. Well, you can experiment with the number of training epochs and the batch size that works best for your data set. Well, this is going to take some time, so I'll save you the pain by fast forwarding this a bit. So guys, as you can see, the training is actually done. So each of the epoch took about 100 seconds and we had 10 epochs for the same. So guys, here's the important thing that you have to notice. With every epoch, we were actually reducing the loss all the way from 1100 to 130, guys. And the accuracy of prediction went from 0.02 all the way till 0.0994, which is almost 0.1. Well, wow, that's definitely a breakthrough for just 10 passes, guys. And now that the training is done, it's time to evaluate it. So let me go ahead and run this piece of code for you guys. So that was quick. That took only about 5 seconds and we have evaluated the model. And now it's time for the most important part, guys, seeing how our model actually performs on the data that it has never seen before. To do this, we'll actually call the predict function on our trained model and we'll be passing it our data set. So let's go ahead and do just that. Well, now that that's done, we'll have to compare the predictions to the actual values for the first 15 wines from our test data set. So guys, as you can see, we have a set of predictions from the description and the predicted value is about $24 while the actual value is $22. Next up, we have $34 as a predicted one while the average is 70. Well, this is not a really good case, but okay, that's tolerable. And next up, we predicted 11.9 when the actual value is 12. Wow, that is actually really close. So next up, we have 15.7 versus 9. Well, this goes on and on for the first 15 and it's actually really good. Well guys, pretty well it turns out that there is some relationship between a wine's description and its price. Well, we might not be able to see it instinctively, but our machine learning models certainly can. So lastly, let's compare the average difference between the actual price and the model's predicted price. Well, the average prediction difference is about $10 for every wine bottle. Wow, that is really nice, guys.
It's time for a simple question. Keras is primarily used as and the options are A. Database management system, B. Front-end framework, C. High-level neural network API, and D. Data visualization tool. If you know the correct answer, please leave it in the comment section below. After discussing Keras, We'll apply our knowledge by exploring text classification, a crucial application for analyzing and organizing text data.
Since the beginning of time, written texts have been a means to communicate, express, and document something of significance. Even in the modern age, it has been proven a lot of times that an individual's writing style can be a defining aspect of one's psyche. Ever since social media emerged, microblogging became the new form of writing, expressing, or documenting an event. This also gave rise to a lot of unstructured data, and with it, a need to understand that data. Now, this is where text classification can be put to our advantage. Text classification is nothing but classifying unstructured text data into various categories. To further simplify how we use text classification, let's consider an example. You have a product that was launched a while ago, and you have also kept track of all the reviews that the product got on all the platforms across the internet. Now, what you have is unstructured text data. And to do text classification on this unstructured data, you can follow two approaches. One, you can either make a few rules where a collection of words will decide the sentiment of the input text. This approach can be useful for a handful of data, but analyzing large sets of data is neither efficient nor cost-effective. But a better approach is making use of natural language processing and classification using machine learning. For this, we should train a classifier with a separate class labeled data, and using this model, we can do classification on the input data. When we give input to the classifier, we will get an output with the class category based on our trained model, telling us if the review is bad, average, or good. This way, text classification on user reviews can help us improve user experience. Data is the new fuel. Thus, even bad reviews can help us identify the attributes which can help us improve our upcoming campaigns. Businesses and organizations are following this trend to understand user sentiment and user behavior. Text classification can also be used for applications like spam detection in emails, targeting customer needs, etc. In this day and age, where data is generated every second of the day, text classification becomes an asset for any organization. Edureka's postgraduate program in machine learning and artificial intelligence, in collaboration with NIT Warangal, can help you learn text classification and natural language processing, among other advanced concepts such as deep learning and predictive analytics. Enroll today to master artificial intelligence and machine learning with the help of our expert faculty.
Having covered text classification, we'll now move on to GANs, which have revolutionized content generation.
Let us understand what are GANs. So we are going to start with generative models. So generative models are nothing but those models that use an unsupervised learning approach. In a generative model, there are samples in the data, that is input variables x, but it lacks the output variable y. And we use the only input variables to train the generative model, and it recognizes patterns from the input variables to generate an output that is unknown and based on the training data only. In supervised learning, we are more aligned towards creating predictive models from the input variables. And this type of modeling is also known as discriminative modeling. And in a classification problem, the model has to discriminate as to which class the example belongs to. And on the other hand, unsupervised models are used to create or generate new examples in the input distribution. To define a generative model in layman terms, we can say generative models are able to generate new examples from the sample that are not only similar to the examples but are indistinguishable as well. And the most common example of a generative model is a naive Bayes classifier, which is more often used as a discriminative model. Other examples of generative models include Gaussian mixture model and a rather modern example, that is generative adversarial networks. So let us try to understand what exactly are GANs, or generative adversarial networks. Generative adversarial networks, or GANs, are a deep learning based generative model that is used for unsupervised learning. It is basically a system where two competing neural networks compete with each other
to create or generate variations in the data. It was first described in a paper in 2014 by Ian Goodfellow, and a standardized and much stable model theory was proposed by Alec Radford in 2016, which is also known as DGCAN, also known as DCGAN, or we can call it as Deep Convolutional General Adversarial Networks. And most of the GANs today use Deep Convolutional General Adversarial Networks. The GANs architecture consists of two submodels known as the generator model and the discriminator model. So a generator network takes a sample and generates a sample of data. A discriminator network decides whether the data is generated or taken from the real sample using a binary classification problem with the help of a sigmoid function that gives the output in the form or the range 0 and 1. So let us go ahead and take a look at how GANs actually work. To understand how GANs work, let's break it down. So generative means that the model follows the unsupervised learning approach and is a generative model. When we talk about adversarial, the model is trained in an adversarial setting. And network simply means for the training of the model, we use the neural networks as artificial intelligence algorithms. In GANs, there is a generator network that takes a sample and generates a sample of data. And after this, the discriminator network decides whether the data is generated or taken from the real sample using a binary classification problem with the help of a sigmoid function that gives the output in the range 0 to 1. The generative model analyzes the distribution of the data in such a way that after the training phase, the probability of the discriminator making a mistake maximizes. And the discriminator, on the other hand, is based on a model that will estimate the probability that the sample is coming from the real data or not the generator. The whole process can be formalized in a mathematical formula. So G over here is generator, D is equal to discriminator, P data X is the distribution of real data, P data Z is the distributor of generator, X is the sample from the real data, and Z is the sample from generator, where DX is the discriminator network and GZ is a generator network. So let's take a look at the flowchart once again, guys. So we have the training data, which is going to give the real sample, and the generator network is going to generate the sample from the random noise or the examples. And then it will go to the discriminator network, where it's going to check if the sample that is coming is real or fake. So that is how a GAN actually works. Now let's take a look at the training phase, like how a generative adversarial network is actually trained. So it happens in two phases, guys. So the first phase is where we train the discriminator and we actually freeze the generator, which means that the training set for the generator is turned false and the network will only do the forward pass and there will not be any back propagation. Basically, the discriminator is trained with real data and checks if it can predict them correctly. And the same with the fake data to identify them as fake. After this, there's the second part where we train the generator and freeze the discriminator. So we get the result from the first phase and we use them to make better from the previous state to try and fool the discriminator better. So to understand this in the layman's term, I'm gonna tell you a few steps for training, like how you should start. So the first step is you have to define the problem. You have got to define the problem and collect the data. After this, the second step is you have to choose the architecture of GAN. So in this step, depending on your problem, you have to choose how your GAN should look like. The third step is training the discriminator on real data. So we train the discriminator with real data to predict them as real for n number of times, or we call it epochs as well. And then we generate the fake inputs from the generator. So in this step, we are going to generate the fake samples from the generator. And the next step is we train the discriminator on fake data. So whatever samples are generated from the generator network, you're going to train the discriminator to predict the generated data as fake. So that's how we know that discriminator is actually predicting the values as correctly. And the last step is we train the generated with the output of discriminator. So after getting the discriminator predictions, we train the generator to fool the discriminator. So that's how we train the GAN to actually get our solution from the problem, which is like defining the problem. So you'll understand this when I'm talking about the applications, guys. So no worry. Now let's go ahead and take a look at a few challenges of generative adversarial networks. So the concept of GANs is rather fascinating, but there are a lot of setbacks that can cause a lot of hindrance in its path. Some of the major challenges faced by GANs are, the first one is the stability. So there has to be a stability that is required between discriminator and the generator network. Otherwise, the whole network would just fall. For example, in case, let's say, if the discriminator is too powerful, the generator will fail to train altogether. Won't be able to push fake samples to the discriminator, and it will always identify them as fake. And let's say if the network is too lenient, the discriminator network is too lenient, so any image that would be generated by the generator network would make the network useless. The next challenge that is faced by GANs is GANs fail miserably in determining the positioning of the objects in terms of how many times the object should occur at that location. Suppose we have a image in which we have, let's say, 3 dogs with 2 eyes, and sometimes a GAN will fail to determine the positioning of the objects in terms of it will generate an image with like 1 dog and 6 eyes. So that's kind of a problem that we face while working on GANs. And the next challenge is 3D perspective troubles GANs, as it is not able to understand the perspective also. So it will often give a flat image for a 3D object. So that's one challenge that we face with GANs as well. And GANs have a problem of understanding the global objects, and it cannot differentiate or understand a holistic structure. Like if you're talking about trees or if you're talking about flowers, that's a problem that GANs will follow. And last but not least, newer types of GANs are more advanced that I've talked about, that is deep convolutional generative adversarial networks, and are expected to overcome these shortcomings altogether. So we don't have to worry about these. These are the shortcomings that we face with normal GANs, the initial generative adversarial networks. Now that they have become more advanced, they actually overcome these shortcomings, so you don't have to worry, guys. So last but not the least, I want to talk about a few applications of generative adversarial networks. So the first one is prediction of next frame in a video. So let's say the prediction of future events in a video frame is made possible with the help of GANs, and DVD GAN, or we can call it as dual video discriminator GAN, can generate a 256 by 256 videos of notable fidelity up to 48 frames in length. And this can be used for various purposes, including surveillance, in which we can determine the activities in a frame that gets distorted due to other factors like rain, dust, smoke, etc. So the possibilities are immense with this. If you are able to predict the next frame in a video, that actually helps in a lot of things like surveillance, security, and we can predict outcomes based on these frames that we generate from a video. After this comes the text to image generation. So basically, object-driven attentive GAN, which is also known as object GAN, performs the text-to-image synthesis in 2 steps. So the first step is generating the semantic layout, and then generating the image by synthesizing the image by using a deconvolutional image generator is the final step. So this could be used intensively to generate images by understanding the captions, the layouts, and refine details by synthesizing the words. And there is another study about the story GANs that can synthesize the whole storyboards from mere paragraphs. So that's actually a very good idea if you're talking about GANs. So you can just give a few layouts and captions. Based on that, it will generate an image for us. Talking about the next application, we have image to image translation. So Pix2Pix is a model which is designed for general purpose image to image translation. So let's say we have 3 images. We have a real image, then we'll be having a generated image which is basically a fake, and then it will be reconstructed to the previous image which was real. So this is how image to image translation work, guys. And after this, we have enhancing the resolution of an image. So super resolution generative adversarial network, or also known as SR-GAN, is a GAN which can generate the super resolution images from low resolution images with finer details and better quality. So this is actually a very good application of GANs, guys. The applications can be immense. So you imagine a higher quality image with finer details generated from a low resolution image. The amount of help it would produce to identify details in low resolution images can be used for wider purposes, including surveillance. We can use it for documentation, security. We can use it for detecting patterns, etc. And last but not least, we have interactive image generation. So GANs can be used to generate interactive images as well. And Computer Science and Artificial Intelligence Library, also known as CSAIL, has developed a GAN that can generate 3D models with realistic lighting and reflections enabled by the shape and texture editing. And more recently, researchers have come up with a model that can synthesize a reenacted face animated by a person's movement while preserving the appearance of the face at the same time. There are a lot more applications we can work on.
Here's another question. GAN stands for option A, General Adversarial Network, B, Generative Adversarial Networks, C, Graphical Adversarial Network, D, Generative Automated Networks. If you know the correct answer, please leave it in the comment section below. Now that we understand GANs, let's see them in action by learning how to generate images using the DCGAN and demonstrating their practical exploration.
So over here, what we're going to do is we are going to download the MNIST dataset from keras.datasets, and we'll just take the X dataset. That is the features that are present only in the X train part. And what we are going to do is we are going to create a generator and a discriminator model, and then we are finally going to combine them in order that they can work together. And as GANs are being a pretty intense topic, I would really recommend you people to check out or have a good understanding of the real basics of what deep learning is and how machine learning works. Although you won't be using any concepts from the machine learning. So if you want the playlist for our deep learning or the full course link, the description for that will also be provided in the description box below. So talking about the problem statement, as I mentioned earlier, first off, we are going to load our dataset, and the source that I'm going to use over here will be keras.dataset. Apart from that, we are supposed to create two types of model here. One would be the generator model, another one is going to be the discriminator model. Generator model, it is there for performing sampling, and the discriminator model is basically there for downsampling, and then we are going to combine this up. It's very important for you to know how GANs work, and the reason for this is because we have to write our own loss function over here. So moving ahead, let me quickly just show you what are the different tools and frameworks that we are going to use. As GANs are really intense when it comes to training them, we're going to need a good performing GPUs. So what I'm going to do is, we all know Google Colab gives me a good performing GPU for free. So let me quickly use that up, and we're going to use Google Colab. Apart from that, talking about the different frameworks and libraries that we're going to have, the generic ones would remain the same. We are going to use NumPy, Matplotlib, and Pandas. Apart from that, a deep learning framework that is TensorFlow and Keras, that's a framework that we are going to use here to train a model and also to develop our model. Alright guys, so now that we know brief of what we are going to do now, let me quickly jump to my code editor, that is Google Colab, and show you how we can get started with this project. So this is the interface of a Google Colab. First thing that I'm going to do over here is come down to the runtime and change the runtime type to GPU. Because training GANs requires a huge amount of compute power. So once we're done with that, let's connect this to the server. So it will take some time. So once this is connected, let me zoom in for you guys. First off, what we'll do is we'll load our libraries. So load libraries. So let's do one thing. Let's import from keras.datasets, import MNIST, and let me execute this. It's okay, we are getting this error. Let me quickly, I think I might have done some typo here. So first off, keras.datasets, import MNIST. So this is where I'll be having my datasets. Then we also need some layers. So it will be keras.layers, import. We know we have different types of layers. So for our simplicity's sake, I'll import all our layers over here. And then we have from keras.layers.activation or advanced activation. We'll import this later. So let me just have something like models, import sequential model, and then also import functional API, that is model. Now we also need some optimizers, that is from keras.optimizer, import Adam. And as you can see, I've done a small typo here. Let me fix this as well. And let's also add this advanced model again from keras.layers.advanced model. It's going to be advanced activation, import leaky ReLU. Usually the activation function that we would use in normal CNN is going to be like ReLU or TANH, but here we're going to use leaky ReLU. ReLU is just that, in the lower level. So let me show you what this means. So if I take this thing, ReLU goes something like this. Oh yeah. So this goes here and it ends at 0, and then there's exponential growth. So either it is at this point or at this point. But when it comes to leaky ReLU, the graph over here is going to be same over here, but on this coordinate it will be a small dip. So we have a small space here. So this is called as leaky ReLU. And apart from this, let's also get some generic ones. So import NumPy as NP and also import matplotlib as PLT. So let's execute this. That's great. What we'll do is, sometimes we do get the warnings. So let me ignore the warnings. So import warnings. So now warnings, let me execute this. Then we have warnings dot filter warning and just pass here ignore. This looks great. So now we are supposed to get our data set. So for getting a data set, I just have MNIST, which we have loaded, and then we just have to do load data. We all know that this gives us tuple, two values. So that's xtrain, ytrain, and again xtest, ytest. So what we're going to do is we're going to have something in this format, and now we'll just have xtrain here. So now let me quickly execute this up. And now if I show you xtrain dot shape, it's going to be 60,000, and 28,28 is the picture size. And now what I'm going to do here, in order to normalize my image, what we'll do is xtrain is equal to xtrain minus 127.5. Divide this by the same 127.5. So print, we want the maximum value and the minimum value, that is xtrain dot minimum, and similarly print xtrain dot max. And now you can see it would be ranging from -1 to 1. If I divide this by like 255, then everything over here would be from 0 to 1. So this is what we have done. And now we're supposed to create the batches. What we're going to do here, we're just going to use the train images or the images present in this train to learn. And then we are going to generate our own very own MNIST data. So it will be total epochs. Let's keep it as 50. Then we have the batch size. Batch size basically means in one go how many images can be there. So it will be 256. Then we have half batch. That's going to be half of this. That's 128. And then number of batches. This would be int xtrain.shape, which is present in index 0. Divide this by batch size. And then let's also add some noise here. So noise dimension. So it's going to be 100. And finally, for our optimizer, what we're going to do here is Adam. We just change the learning rate here. So LR, this would be equal to -4, and then beta 1 would be 0.5. So this basically means 0.0002. And now let's execute this. We are done. So what we're going to do now, we are going to create a generator model. So generator model. And here we are basically trying to do upsampling. So first off, as this is the model, right? So we'll give the name here as generator. We'll keep this as a lowercase generator. And this is going to be the sequential model. This is pretty similar to what we are going to have. So we'll have now generate. Let me just execute this. And now we'll have generator dot add. Now we'll add dense layer here. And now we'll call units. Number of units that I need over here, it'll be 7 times 7 times 128. And then we have input shape. And this would be noise dimension, comma. So basically this thing, noise dimension is 100, right? So this is going to give me the batch size, and then comma is basically telling me the values. And then again we have generator dot add. Now we'll do the reshape here. So it'll be 7, 7, 128. Then again generator dot add. We're going to add a leaky ReLU, and the value that I'm going to give here is going to be 0.3. That's the alpha value, or 0.2. It's totally up to you. And then we'll do some batch normalization just to prevent overfitting. So this would give me like the size over here is going to be 7 cross 7 cross 128. Now we'll try to decrease this and increase these values. So let me write that down. 7, 7, 128. We will try to do 14, 14, 64. So this is going to be generator.add. So we'll have convolution 2D transpose. Number of layers that we are going to add is going to be 64. Then we have kernel size, that will be 3 cross 3. Stride will take 2. And even after that, padding would remain the same. So now we'll do generator.add leaky ReLU, and we'll give the beta value here would be 0.2. And again, we'll try to add batch normalization. Now again, we'll try to do the upsampling. What we'll do is we'll change this. We'll change this to 28, 28, 1. This is the actual image that we need. So this is the size of the image that we have over here. So for this, we'll do generator.add. It's going to be the same thing that's over here. It's just that we'll change the dimensions. So instead of 64, it's going to be 1. And rest everything remains the same. And just a small change that I'm going to do here, add an activation function, tanh. This looks great. And finally, we are going to compile a model. So generator.compile. So we'll have loss. This will be Keras. So what we'll do here, we'll also import Keras. So import just Keras. So now we'll come here, Keras dot losses dot binary cross entropy, and then we have optimizer. We'll use our custom optimizer, that is Adam. We have used this Adam over here somewhere in the top. And finally, we'll try to do general.summary. That's our model.summary. And let's execute this now. So as you can see here, first off, we have the batch size. We have 7 cross 7. And finally, we'll do the upsampling and we get this image 28, 28, 1. Now we're going to do discriminator model, or you can say downsampling. The input size over here is going to be 28, 28, 1. If you're unable to understand what's happening here, I would highly recommend you to check out any of the Edureka's GAN tutorial projects. The reason for this is because GANs are pretty high level models that requires you to have some fundamental knowledge over here. So finally, what we're going to do, now we are going to do downsampling. So the input shape here is going to be 28. Let me just copy this from here. And we are going to downsample this to 14, 14, 64. So this basically we are trying to do the reverse of this model, generator model. So here we'll have discriminator, and this would also be a sequential model. And let me execute this so that I start getting the recommendations here. So now that we have done with this, so we'll have discriminator dot add, let's say conv2d, and now the number of layers I need here is going to be 64. Then I have kernel size 3, 3. Then I have strides. This will also remain the same, 2, 2. We have padding. We want the padding to be same. And as this is the first layer, we are going to add our input shape as well. And this is going to be 28, 28, 1. So now that you're done with this, let's also try to add some other layers. So we have discriminator is equal to dot add. And now we are just going to add leaky ReLU and give an alpha value here to be 0.2. Try this with a different alpha values like 0.3 and whichever suits you. And now what we'll do, we will again do the downsampling. So we give this as a comment, and we're going to downsample this thing to 128, and this should be 7, 7. We're going to perform the same step. I'll just copy this for now. And as we all know, there's slight changes that we need to do. First off, instead of 54, this is going to be 64, right? Not 54. And instead of here of 54, we are going to have 128. And we don't have to provide the input shape over here as well. The rest everything remains the same. And finally, we will downsample this again from this vector to a scalar value. That is, scalar here is going to be 6272. And now we'll do discriminator dot add. So this is going to be flatten here. We'll do some discriminator dot add dense, and we'll pass here 100. And we'll also give some leaky ReLU here. Let me just copy this. And finally, we'll do discriminator.add dense layer. And we just want the output for this to be 1. And the activation, as this is just 1, it's going to be sigmoid. So this is it about the model. And now we are going to compile this. So it's going to be discriminator.compile. So the loss function that I'm going to use here is binary cross entropy again. So it's going to be keras.losses.binary cross entropy. Optimizer that I'm going to use will be Adam, the one which you have defined, Adam. And finally, let's compile this. This is not going to be compiled. This is going to be summary. And let's execute this now. So as you can see here, we are doing the reverse process of what we did in our generator. It's usually 28, 28. And then every time I pass this through a convolution layer, obviously there's a change in size. And as I move down, the size decreases and we are presented with 1. So this is about like building our generator model and even our discriminator model. So fine, in the next stage or the final stage of model creation, we are going to combine it. Combined model. So over here we have describer.trainable. We'll give this as false. Then we have GAN input. So this is the name of a model. That's a GAN input. And I have input, and this will be shape, and this is going to be noise dimension. And then finally we have generated image. This will be generator of GAN input. And finally, we have GAN output. This should again be discriminator, and we're going to pass here generated input or image. And now we'll use a functional API. We are using this to create a final model. So it'll be model. This will be model. We are supposed to part the inputs, right? So it'll be GAN input, and the output will be GAN output. And finally, just like others, we are supposed to compile a model. That will be model.compile. So here loss we are going to use is binary cross entropy. So Keras dot losses dot binary cross entropy. And optimizer will be Adam. Looks great. Let me execute this. The reason why we're getting this error is because of this, and let's try to execute this. And now as you can see, we don't have any errors. Let's quickly see how this model would look like. So model.summary, and let's run this. So as you can see, we have input shape, and this is the output, and then finally this is the input over here. So now we are going to come back to our data set, that's train. We'll reshape this. So it will be train.reshape. We're going to have -1, then 28. That is on the x-axis, 28 on the y-axis, and 1 is a channel. And if I run this and add here xtrain.shape, you will see it looks like 60,000, 28, 28, and 1. This is the batch size, and then we have 28, 28 is the size of the image, and 1 is the number of channels. So this is all there is about building a model. Now finally, we are supposed to create a training loop. Let me give a comment again, training loop. So we'll have discriminator loss. At the same time, we'll also have generator loss. We'll have a for loop here for epoch in range, total epochs. Here we'll have one value, that is epoch discriminator losses. There will be 0.0. Similarly, epoch generative loss, and even this will be 0.0. So now we are going to have mini batch gradient descent for step in range, number of batch. Let me give some comments over here just so that it's easier for you guys to understand. So in the step 1, we're going to train discriminator. So for this, what we are going to do is we're going to have discriminator.trainable will be equal to true. That is, how do I do this is by this part. Okay, discriminator. So first off, we need to get the real data. So this will be index. This will be equal to np.random.randint. So we'll have 0, 60,000, half batch. And then we'll have real images. This will be xtrain present in that index, idx. And now get the fake image, or you can say data. So we'll have noise. This will be equal to np.random.normal. So we'll have 0, 1, noise should range. Size, this will be half batch, noise dimension. So now it will be fake image. This will be generator.predict noise. And now we'll do labels. So now we need the label. So it will be real y is equal to np.ones. So this would be half batch, 1 times 0.9. So times 0.9, and then fake y. This would be np.zeros. Then we have half batch, 1. So now it's time to train d underscore loss underscore real. This would be equal to discriminator.train on batch. So here we are going to pass real image and then real y. And then for the fake, d underscore loss underscore fake. This would also be the same. It's just that instead of real, it's going to be a y. So let me do this. Fake images, and then this is going to be fake y. And finally, d loss. This would be 0.5 times d loss underscore real plus 0.5 times d loss underscore fake. And then finally, we have to do epochs d loss, that is epochs per loss, plus equal to d loss. So this is the stage 1. In the stage 1, we are gonna just train this part over here. And now coming down to the stage 2, that is, let me give a comment here, train generator. And when I'm training generator, obviously my discriminator has to be false or disabled. So here we have noise. There will be np.random.normal. So here we are going to pass 0, 1, size. This would be batch size, noise dimension. And now we have ground truth. So this will be np.ones. And let's provide a batch size, the size for this, 1. And then we have epochs G loss plus equal to G loss. So finally we have to print this out. So what we're going to do, we're going to write a function to display the images that we have created. But before that, let me quickly write here print. So it will be epoch and we'll pass this data here. Then we have disc loss, that is discriminator loss. We'll provide this over here, and generator loss. We'll provide this over here. So here we'll have epoch plus 1. And then over here we are going to have epochs underscore d underscore loss. Divide this by number of batches. And finally for our loss over here, that is generator loss, I'm going to add something similar. Let me give this on the next line just so that it's easier to read. So here it's going to be the similar thing, but instead of D it's going to be G. So let me copy this and paste this over here. And finally we'll have D underscore losses dot append. We're going to append the same values. So we are going to append this for the discriminator loss. We copy and paste here. And then this would be D underscore losses dot append. It's going to be G, not D. And we're going to add this value here. And finally, if generator, it's going to be like this. If the number of epochs plus 1 percentage 10 is equal to 0, then save it. Give a extension as generator.h5. And now we also want to display the images. So what we'll do, display image, we'll write a function display image, and we'll just have to display this image here. So what's going to happen is for every 10 images, so for every 10 image, it will display the epochs, losses, and then the images. For us to display the image, we have to write another function here. We'll do that as well. This will have a small function def display image images, and we'll give samples is equal to 25. Now we have noise. This would be np.random.normal. Here we'll have 0, 1, size. The size would be number of samples. That's 25, noise dimension. So generator image, this would be equal to generator.predict noise. And finally, we'll just plot the figure here. So plt.figure, we'll give you a figure size. Let's say 10, 10. And I want the images to be plotted next to each other. So for I in range samples, as it's 25, no, it's going to be 5 in row and 5 in columns. So plt.subplot 5, 5, that's 5 rows, 5 columns, and then we just have to provide the index, that's I plus 1. Then we have plt.imshow generated image, which is present in index I dot reshape 28, 28, and I want the C map to be gray. You can either keep it gray or binary, totally up to you. I'll give it as binary. Then plt.axis, we'll keep this as off. And plt.show, and yeah, this is it. So let me quickly give you a walkthrough of what we are doing here. Let me zoom out. First off, we try to get our data. First off, we are trying to ignore the warnings. Then we import the libraries. Then we get our data, try to reshape it. Over here, I want my data to range from -1 to 1. I hope now you understand why you're using leaky ReLU. And now we are trying to create the batch size, noise dimension, and customize our function. Over here, there are two models that are involved. The generator model, where we are basically trying to do the upsampling. And then we have also done downsampling using discriminator model. Both of these models are combined over here. As you can see, we are combining them to create a GAN model. That's our final model. And the way we train our model is quite different. Like usually we use fit and provide all the values, but here we are trying to write a customized training loop. For every 10 epochs, this function would be called, and this would actually generate the images. So let me do one thing. Let me quickly run this up now. Before you start, make sure you remove this comment from here. And first off, we are going to train our discriminator, as I mentioned earlier, and then we are going to give this a false, right? Discriminator.trainable would be false. And let me quickly run this and see what happens here. This would take quite some time, as training generators, adversarial neural networks are pretty intense. This would take quite some time over here. And let's see what happens. Alright guys, so as you can see here, we have successfully created our images. And now if I tell you this, right, this is not the image which is present in our data set here. This is the beautiful concept of GANs, where this image over here, we have generated this by ourselves. And this is what GANs does. So let's wait for another batch over here. Let's wait for another 10 batches and let's see what happens and how that thing would look like. Alright guys, so as you can see here now, this is the second batch of the image that we have received. Let me zoom out a bit. Let me zoom out over here. So as you can see, the images over here are better. So we can see this 5, 6, 3, 6, 7, and all of these are the images that was generated by our model. And as you can see, all this is pretty simple and short, but there's a huge amount of complications that go in for developing this particular model. So if you have this kind of project in your arsenal, you can crack out any interview or question that is been posed to you.
Shifting our focus, we'll explore LLMs, that is the large language models, which play a vital role in modern AI language for understanding and generation.
Imagine you have a brilliant friend named Max who has read every book, article and social media post on the internet. Max can recall entire conversation, understand details of language and generate responses that are both informative and engaging. So, one day you request Max to help you write an email to a colleague. Max suggests different words, fixes any mistake in spelling or grammar and even make the email more engaging to read. Next, you get help to summarize a lengthy report on a technical topic. Max simplifies the main points into a clear and concise summary, saving you hours of reading time. And later, you engage in a conversation with Max about a complex topic like artificial intelligence. Max responds thoughtfully using its vast knowledge and understanding of language to provide insightful answers and ask follow-up questions that stimulate further discussion. So this is what large language model like Max can do. Process and generate human-like language, understand context and meaning, and assist with various tasks. So on that note, hello everyone and welcome to this video on what is large language model by Edureka. And in this video, we will discuss some of the examples of large language models and their applications, followed by the working of large language model, and moving on to some of the examples of large language model, such as Google's BERT, Meta's Llama, OpenAI's GPT-3 and Microsoft Turning NLG. And these models have many applications such as language translations for accurately translating text between different languages, and then text summarization for understanding the meaning and context of text for tasks like sentiment analysis, question answering and summarization. And then we have chatbots and virtual assistants, followed by content generation for creating human-like text for content creation, chatbots and storytelling. And then we have conversational AI, and along with this, it is also used for content recommendations, search engine, sentiment analysis and data analysis. Large language models work by using a combination of natural language processing, that is NLP, and machine learning algorithms to process and generate human-like language. So now, moving ahead, let's have a look at how large language models work. So first, the model is trained on a massive dataset of text, such as books, articles, and websites. So this dataset is used to learn patterns and relationships in language. The text is then broken down into individuals' words or tokens, which are used as an input for the model. And then each token is converted into a numerical representation called an embedding, which captures its meaning and context. The embeddings are fed into an encoder, which uses a series of transformer layers to analyze the input text and generate a contextualized representation. And then the decoder generates output text one token at a time. So based on the contextualized representation and the model's understanding of language patterns, the model can generate text in various forms, such as continuation of prompt, text completion, or even entirely new text. And the model can be fine-tuned for specific tasks such as language translation or text summarization by adjusting the weight and biases of the neural network. I hope the working of a large language models are clear to you. But to help you understand better, let me explain with a simple example. So, think of a large language model like a smart parrot named Polly. And Polly lives in a busy town where she learns to talk by listening to people chatting. She picks up words and phrases from their conversation, just like we learn from hearing others speak. So, Polly's training begins when she listens to the people around her chatting, telling stories, and sharing news. She pays close attention to the words they use and how they are put together. So, just like Polly listens for individual words and phrases, the text is broken down into small chunks called tokens. Each token represents a word or part of a word, making it easier for Polly to understand. Polly not only learns words but also understands their meaning and how they are used in different contexts. She associates words with their meanings just like we do with pictures. When Polly hears a conversation, she processes the words she hears and makes sense of them using her knowledge of the language. She can understand the flow of conversation and respond appropriately. And then, Polly's responses are like pieces of a puzzle that fit together to form a meaningful conversation. She uses her understanding of language patterns to generate responses that make sense in the context of the conversation. Polly can generate responses based on what she's learned from listening to conversation. Whether it's answering questions, sharing information, or telling stories, Polly can speak fluently like a human. And just as a Polly learns to mimic different voices and accents by listening to other people, the language model can be fine-tuned for specific tasks like translating between languages or summarizing text.
With LLM introduced, our next step is to dive deeper into large language models to understand how they work.
Large language models consist of three main components. First one is data, and then architecture, and the third one is training. These models are trained on enormous amount of text data, enabling them to understand language patterns and nuisance. Large language models utilizes a neural network architectures, particularly transforms, which handled a sequence of data such as sentences or lines of code. The transformer architecture allows a model to understand the context of each word in the sentence by considering its relationship with every other word. During training, the model learns to predict the next word in the sentence and adjust its parameters to reduce the difference between its predictions and actual outcomes. Through iterations, the model gradually improves its word predictions until it can reliably generate coherent sentences. After pre-training, the model can be fine-tuned on smaller, more specific datasets to refine its understanding and improve task performance. And finally, fine-tuning enables the model to become a proficient in specific tasks, transforming a general language model to an expert in a particular domain. Now, let me give you a few examples of large language models. First one is GPT-3 from OpenAI. GPT-3 is versatile for various applications, which means it has impressive capabilities, make it suitable for a wide range of applications. And then, it excels its text generation tasks, such as generating articles, stories, and poetry. And then, GPT-3 is also utilized for language translation tasks, enabling accurate and contextually relevant translations across multiple languages. And also, in addition to this, it is employed for question answering systems, where it can provide a detailed and informative responses to user queries. And the next application is BERT from Google. BERT is a bidirectional training approach, allows it to capture the context from both directions, making it highly effective for various NLP tasks. And it is widely used in a sentimental analysis application, helping business analyze customer feedback and engage public opinion. BERT is also employed for named entity recognition tasks, where it accurately identifies and classifies entities such as name of people, organizations, and locations in text data. Furthermore, BERT is utilized in machine translation systems, facilitating accurate and fluent translations between different languages. Moving forward, the next application we have is T5 from Google. T5's unique text-to-text approach makes it versatile for handling a wide range of NLP tasks. It is commonly used for summarization tasks, where it can generate a concise and informative summarizes of longer text. T5 is also applied in text classification tasks, helping classify documents, emails, or social media posts into relevant categories. Additionally, it is utilized for language generation tasks, enabling the creation of conversational agents and chatbots capable of engaging in natural and coherent dialogue with users. And the last example of large language models is Robert from Facebook AI Research. Robert does robust optimization and fine-tuning on large datasets make it highly effective for various NLP applications. It is commonly used in sentimental analysis tasks, providing accurate assessments of sentimental from text data. Robota is also applied in text classification tasks, helping categorize text data into predefined classes or labels. Furthermore, It is utilized in natural language understanding tasks, enabling systems to comprehend and interpret human language input accurately. Now, let us understand the benefits of using large language models. First one is reduce manual labor and cost. By automatically a number of tasks like sentimental analysis, customer support, content production, fraud detection, prediction, and classification, LLMS cuts down the manual labor and associate expenses. And the second benefit is enhance availability, personalization, and customer satisfaction. Large language models give companies the ability to use chatbots and virtual assistants to offer 24/7 availability. By processing enormous volumes of data to comprehend customer behavior and preferences, automated content creation powered by LLMs enabling personalized services, boosting customer satisfaction, and developing strong brand relationships. And the third benefit is save time. Large language model systems automate data entry, customer support, and other marketing stuffs like sales and customer service processes. Because of this, employees can concentrate on duties requiring human expertise. Moving forward, we have improved task accuracy. Because of large language models are adept at handling a large volume of data, they produce a better result when it comes to a task like classifications and predictions. Learning patterns and correlations from data helps large language models to create more accurate classifications and forecast. For example, in sentimental analysis, large language models can examine a large number of customer reviews to ascertain the sentimental underlying each one precisely. This is important for companies that place a high value on accuracy. Moving forward, we have facilitate innovations and creativity. These models are effective instruments for encouraging innovations and creativity by encouraging the investigations of novel ideas, concepts, and solutions. Through their text generations capabilities, these models can help with the creativity, creative writing, and brainstorming sessions. They can also help writers, artists, and researchers to create original content and investigate non-traditional methods of problem solving. And the last benefit of these models is improved decision making and risk management. By offering insightful analysis and predictions based on sizable datasets, these models contributes to the enhancement of decision-making procedures and risk management. This can help with the business identity opportunities, reduce risk, and make a well-informed decisions by examining past data and finding trends. This skill is especially helpful in industries like supply chain management, healthcare, and finance. Now, let us discuss the differences between large language models development versus traditional development. Large language models development requires a vast amount of text data for pre-training, whereas traditional development may require smaller datasets. Large language models are complex neural networks with millions to billions of parameters, while traditional models are simpler with fewer parameters. Next, these models are pre-trained on large text corpora followed by fine-tuning, whereas traditional models are trained directly on task-specific data. Moving forward, we have a difference as large language models are less interpretable due to their complex architecture, whereas traditional models are generally more interpretable. And the next difference is large language model development demands significant computational resources and large-scale text datasets, while traditional development may require a less computational power and data. And the last difference, large language models are mainly used for natural language processing tasks, whereas traditional models have broader applications across various domains.
Here's another question. What is a common application of large language models? And the options are A. Image classification, B. Speech recognition, C. Natural language processing, and D. Data encryption. If you know the correct answer, please leave it in the comment section below. After exploring LLMs, we'll focus on ChatGPT, a leading example of these models and its capabilities in natural language processing.
ChatGPT, ChatGPT, ChatGPT. This has been the buzzword since the day of its release, and people are going crazy about everything it can do. Microsoft will be integrating ChatGPT into Teams, to automatically take notes and recommend tasks. ChatGPT has also passed the US medical and law exams, and it has got a lot of doctors, lawyers, and engineers concerned about whether it could replace them. People want to know if ChatGPT is the next step towards our evolution by replacing Google and voice assistants like Siri and Alexa. But what exactly is ChatGPT? Why is it changing everything? Now, I want you to think of ChatGPT like Siri or Alexa minus the voice capabilities. ChatGPT can give you detailed and contextual answers in a very human-like manner. It can remember conversations, do math, write essays, and much more. And it does it so well that people are genuinely scared of losing their jobs. Now, ChatGPT is not really a new concept. Microsoft and other companies have also tried this before, but were nowhere near successful. OpenAI developed a model called GPT-3 using huge data sets that had a variety of information. They released it to the public, calling it Playground, where a lot of developers used it for their daily tasks. ChatGPT has been another implementation of this. OpenAI took a year to make this model faster and more accessible to the general public, and when they released it in November 2022, the crowd went nuts. The site gained more than 1 million users in just 5 days. And to give you some perspective, this number is bigger than Netflix, Twitter, Facebook, and even Instagram. All that said, I want to let you know how everyone is using ChatGPT to simplify business operations. For developers, ChatGPT has been a blessing. Since ChatGPT can write code, provide code templates, and fix errors, most of the problems that developers usually run into has been fixed. As a result of this, productivity has greatly increased and companies are getting more results. It's the same thing with content development. Videos like this one traditionally take a lot of time and effort to be made. We have to think about how best to explain things so that you, the viewer, can easily understand it while making sure that the content is SEO friendly and extremely engaging. ChatGPT has also helped us give you better, more optimized content while reducing our workload. By the way, did you know that ChatGPT can explain stuff better than most university professors? I guess it's time we contemplated our learning methods. Marketing and sales has also been much easier than before. Think about it like this. If you want to make a customized sales pitch, all you need to do is enter the details. ChatGPT can provide a customized sales pitch for each individual lead. How convenient is that? And it doesn't just end there. ChatGPT can also be integrated with accounting and data analytics platforms, so you don't need to know the formulas directly. All you need to have is data, and you just need to type what you want to do. If all this doesn't blow your mind just yet, then know that psychologists and psychiatrists are using ChatGPT to help and counsel their patients. Now, if you are questioning whether it would really be helpful, then let me tell you, it can. I just had a 30-minute conversation with ChatGPT about my dog, and it seemed way more interested in him than most of the people I usually talk to about this. All that said, if you want to start using ChatGPT, then all you need to do is open chat.openai.com. This is the URL of ChatGPT, and the moment you open this, it will ask you to create an account. Once you do that, you will land in a web page similar to this. Let's start with a simple question about programming. This is just a random question on Stack Overflow, which I will be using for this demonstration. How to check if an array includes a value in JavaScript. The user has also provided some code, and he has said that he only knows how to do it like this. Is there a better way? And once we ask ChatGPT the same thing, boom, ChatGPT is on it. It finds a solution and provides the best answer it could think of. If you look at the question, while the solution might be simple, the complexity of conditions and following my instructions properly is quite hard. ChatGPT eased through it and also provided a sample snippet which I can directly copy and paste into my editor. But this is not the only thing. It can also give you complete guides on how to do something. Like for example, let me type, using Python, help me fetch data for Nifty Bank for the past 3 years. ChatGPT is already providing explanation and code of how this can be done and is pretty damn cool. Now, remember that ChatGPT remembers conversations and can have future answers based on it. So now, if I type, great, how can I create an AI model that can predict values using this data? It immediately understands what I want and provides an accurate answer. The answer might not be everything that you hope for, but at least now you know where to start from. Another use case for ChatGPT that we talked about was content creation. To do this, let's create a new chat thread. This makes sure that the previous conversations don't affect the current conversation. If we start without a new chat thread, ChatGPT might think that we are trying to write content about stocks and machine learning. We don't want to do that now, do we? So let me ask ChatGPT to give me blog ideas for ChatGPT itself. And we already have multiple blog ideas for ChatGPT. We can then ask it to write a story based on some option. We can then say, I like the third option. Could you create a storyline for it? And we can see that ChatGPT immediately starts generating a storyline based on my option. It includes an introduction and sections of what my blog will contain. Similarly, we can also create a sales pitch. Let's just say, create a motorbike sales pitch for a person with the following details. And then I have listed down a few details like name, product, age, country, and source. And once we submit this prompt, we can see that ChatGPT immediately starts writing a beautiful sales pitch. You can even use the sales pitch directly if you want. Now, if we dive too deep into the subject, then this video will take forever to finish. So if you are interested in knowing more about how to use ChatGPT, then check our course on ChatGPT, which will not only cover the basics of ChatGPT, but also the advanced and complex usage for different scenarios. But before we end this video, I definitely need to make you aware of a few limitations. The first thing is that it may occasionally provide incorrect information. You should know that ChatGPT is a relatively new application and it needs some time to improve. The current version of this is a free research preview, meaning that they have released it to test the application. This statement could also mean that we might see an improved paid version of this in the future. There's a lot of rumor going about that already. The second limitation is that it may occasionally produce harmful or biased content. This is something that we have seen in all chatbots in the past, and ChatGPT has reduced the occurrence, but it's still not perfect. But the biggest drawback is that the model was trained on data collected before 2021. This means that it has very limited knowledge about the current affairs. So make sure to check the facts before drawing conclusions. And with all this, I want to know what you think of ChatGPT. How do you think it will look in the future? And what do you think about the future of automation and AI? I personally think that we can expect radical changes in all segments. Imagine voice assistants being as intelligent as ChatGPT. And if it is updated with real-time information, things would be much more convenient than now. You could shop online with ChatGPT's recommendations, find good restaurants, meet new people, plan trips, and much more.
Here is a quiz question for you guys. And the question is, ChatGPT is an example of which type of model? And the options are option A, convolutional neural network, option B, large language model, option C, decision tree, and option D, support vector machine. If you know the correct answer, please leave it in the comment section below. Now that we have discussed ChatGPT, it's important to compare it with Google Bard, analyzing their strengths and unique features.
You all have heard about war? Let me tell you about the AI war happening right now in the video. The progress in AI has stunned everyone as the possibilities are endless and the sky is the limit. we are already starting to see plenty of progress in areas mainly language processing models like ChatGPT and Google Bard. You must be thinking, what are language processing models? These models allow you to speak and get text-based answers for your questions. Hello everyone, this is Arya from Edureka and I welcome you to the today's session to see who wins the battle between ChatGPT versus Google Bard. With all the chaos in the tech field right now, this has ignited the spark between the tech developers to be the best among the competitors of AI. All I can say is the biggest AI rivalry has now started. And what if I will tell you that it is between Microsoft and Google? You will be amazed to know that Microsoft CEO Satya Nadella confirms $10 billion investment into ChatGPT as it got huge success. On the other hand, Google CEO Sundar Pichai was quite frustrated as he has asked his employees to focus on the AI tool, which showed inaccurate data at the launching event of Google Bard. Now let me tell you something about these two chatbots. First, let's start with ChatGPT. It is an AI language model that is taking the world by storm. Do you know what is the full form of ChatGPT? It is Chat Generative Pre-trained Transformer. I know, it seems a bit difficult to say, right? And what about Google Bard? It is an experimental conversational AI service powered by Lambda, which stands for Language Model for Dialogue Applications. Google Bard and ChatGPT are two of the most prominent chatbots available in 2023. But which is better? As both offer natural language responses to natural language inputs, using machine learning and millions of data to craft useful and informative responses for the users. As the hype got real, soon after the launch of ChatGPT, many tech personalities like Narayan Murthy, Bill Gates, as well as the Gmail founder appreciated the chatbot, ChatGPT, due to its extraordinary features. To know more details about ChatGPT, let's dig into the topic first. To start with it, we will try to know what is ChatGPT. ChatGPT was launched on November 30, 2022 and its valuation was estimated at $29 billion in 2023. ChatGPT is a large language model chatbot developed by OpenAI based on GPT 3.5. Due to high demand of the users, we often get to see this that ChatGPT is at max capacity. You don't need to worry about it, as it happens when a lot of engagement is going on the server. And if you are a GPT Plus subscriber, then maybe you can get the access more easily. Now the question is how it really works. Basically, it generates text-based answers and help us to code. From finding the error to actually improving it. Within few seconds, ChatGPT has been doing wonders. After seeing this, the growth of ChatGPT among the users, Google had started panicking, as they wanted a more advanced rival chatbot from their side to compete with ChatGPT. They recently launched their own chatbot, Google Bard, in a press conference which came out as a huge failure, resulting in shares of Google's parent company to lose more than $100 billion in market value. As we are already discussing about Google's Bard, now let's move on to the next topic of our video. What is Google Bard? I am going to answer this question as we move ahead in this video. Google Bard is similar to OpenAI's ChatGPT, as it is latest experimental AI service that can respond to various queries and requests in a conversational manner. At the heart of Google Bard, it is an experimental technology Lambda, which is a transformer, a neural network architecture. Soon after the two tech giants launched their products, everybody started thinking which one is better. To get the answer without any delay, let's talk about the elephant in the room, which is ChatGPT versus Google Bard. Let's start with the ChatGPT. It is an artificial intelligence chatbot developed by OpenAI, built on OpenAI's GPT-3 family of large language models. Google Bard developed by Google, and it is a convolutional neural language model. Secondly, you need to know that ChatGPT is based on GPT 3.5 and has a remarkable ability to interact in conversational dialogue form, and it can provide responses that can appear surprisingly human. On the other hand, Google Bard is an experimental conversational AI service powered by Google Lambda. You will be surprised to know that Google Bard will inform users by finding the latest, high-quality answers, and it means that Google's latest AI tool can give users information about the current scenario. While on the other hand, ChatGPT is not connected to the internet, and it can occasionally produce incorrect answers, as it has limited knowledge of world till 2021, and may also occasionally produce harmful instructions or biased contents. As we come to the new levels of AI chatbots, given the many ways AI is tested, people want to test how sophisticated such chatbots are. Whether ChatGPT or Google Bard are plagiarism-free is a question on lot of lips. ChatGPT supports plagiarism checker, but OpenAI has also clearly stated that tool isn't fully reliable yet and should not be used as a primary way to identify copy text. On the other hand, Google Bard is not that developed to have an AI text classifier. After all the factors, the most important point of the discussion is whether ChatGPT or Google Bard free for the users. Till date, ChatGPT has allowed research content previews for free, but also has a subscription model to get more enhanced results. As I have told previously that Bard is still under beta phase, so it's completely free for now. Both the AI chatbots have their own capabilities and limitations, but what exactly matters is how beneficial they are going to be for us in future. Take it as education sector or research sector or advanced language models. But for me now, ChatGPT is in lead. But soon after Google Bard comes with personalized search option, it's gonna be a hell of a ride for the tech users.
After comparing these models, we learn how to use the OpenAI API with Python, enabling practical application of our knowledge.
How to use OpenAI API using Python. Now most of y'all must have heard of ChatGPT, the super trending AI text generator that generates responses based on user prompts. This technology was developed by a company called as OpenAI, and along with ChatGPT, they released a few APIs that are super convenient to use in your code. You can find these models if you search for openai.com/API/pricing. Once you're in this page, if you scroll down a bit, you will be able to see a section called as language models. Now this section has a collection of base models that you can directly use in your code. There are currently 4 options available, which is Ada, Babbage, Curie, and DaVinci. Now each of these models has slightly better capabilities than the previous one, and depending on these capabilities, prices can also differ. Now the Ada model, which is the least capable out of these 4, has the fastest response time, and DaVinci is the most capable while being the slowest out of all these options. Now coming to the pricing, you can see that the prices are mentioned per 1000 tokens. So what is tokens? You can think of tokens as words, and like it is mentioned over here, 1000 tokens is approximately 750 words. You will be charged based on how many tokens you use in your program. If you want to look at the differences, then there is a separate page for that too. Over here, you can see the details, capabilities, and restrictions of each of these models. All these models are developed on the GPT-3 models, and the DaVinci model, which is the most capable, has a max request limit of 4000 tokens, and the training data was taken up to June of 2021. The Curie model is slightly less capable than the DaVinci model, but it is faster and costs way less than DaVinci. It has a max limit of 2048 tokens, and you can also see that it was trained only until October of 2019. The Babbage model is another option which is capable of straightforward tasks and is very fast while giving your answers at a fraction of the cost. And the Ada model is super fast while being restricted to very simple tasks. Now, just because the capabilities differ doesn't really mean that the Ada is worse than DaVinci. It all depends on your use case. If your use case is very simple and straightforward, you would be better off using Ada or Babbage. And if you have some complex mathematical tasks, then you can use a text generator like DaVinci. While using these models in code, you will also have to insert some parameters. Based on this parameter, the prices can also heavily differ. To use the OpenAI APIs, you will first need to head over to openai.com. Once you are in here, you will find an option called as API on the top. Click on that and then log into your account. If you don't have an account yet, then I highly recommend that you make one. Now once you log into OpenAI, you will find yourself in a web page similar to this. What you need to do right now is head over to your account and then click on View API Keys. Once you're here, click on this button that says Create New Secret Key. Once this key has been generated, make sure that you copy this key. Let's just name this key as OpenAI.API key. Now before we execute this code, we will need to install a library called as OpenAI. So let's just do that by using the pip command. As you can see, I have already installed OpenAI in my system, but if you haven't already, then this command will install OpenAI library in your system. Once that is done, you can get rid of that cell and import the OpenAI library into your code. Now let's run this. Yes, your key needs to be passed as a string. Now let's run it again, and you can see that it has executed successfully. Now let's define a simple prompt. We'll say variable prompt is equal to, and then a message. Let me just type, "Hi, how are you today?" Now this will be our prompt. Now that we have access to OpenAI and we have defined a prompt, the only thing left is to generate a response. Now to generate the response, let's start by typing variable response equal to OpenAI.completion.create. Now this is the function that you use to generate responses. Inside the create method, we will start defining our parameters. The first parameter that we are going to define is the type of engine that we will use. So you can just type engine equal to, and then you can specify the model that you will use. If you want the details of the models, you will find it over here. These are the models that you can use in your code. Let's first start with the Ada model. The next parameter that you will need to specify is your prompt. This parameter will be passed to your model to generate a response. Since tokens are expensive, it's best practice to set a max limit to your tokens. You can do this by typing the max tokens parameter and setting a value for it. Let me just set it to 50. And one more interesting parameter is the number of responses that you want to generate. So we can set it as n equal to 1. This will tell the model to generate only one response. Another interesting parameter is the temperature parameter. This parameter will tell the model how flexible it can be with the response. This value can be anywhere between 0 and 1. A temperature of 1 will make the generated response quite formal, while a value of 0.1 will keep the response extremely creative. Keep in mind that lesser temperatures can also make your responses factually incorrect. And when I say 1, it will show 1. When I say 0, it will show 0. And then 0.1. For now, let's keep the temperature value at 0.5. With this, we have generated the response. To view this response, you will just need to write one more line of code. This can be done by using the print function and then typing response.choices. Now, choices is a list of generated response. Since we have set n as 1, we'll be getting only one output. So our response's choice index is 0. We also need to see the text format of the response. So we type .text at the end. Once we execute this code, you can see that our model has generated a response. You can also change the model or the number of responses if you don't find the answer satisfactory. And now you can see that our response is more friendly. So guys, this is how we use OpenAI API in Python.
With the API skills in hand, let's explore GPT 4.0, where learners will discover its new features and enhancement compared with previous versions.
A few days back, on May 13, 2024, OpenAI came out with an announcement unveiling their latest AI model, GPT-4o, also known as GPT-4 Omni. This announcement just sent shockwaves to the tech world and captured the imagination of AI enthusiasts everywhere. Compared to the other models of OpenAI like GPT 3.5 or GPT-4, this model stands as a pioneering AI model that can seamlessly understand and generate content across different modalities including text, audio, and visuals. GPT-4 Omni accepts user inputs in the form of text, audio, or image and can generate a combination of text, audio, or visual as an output. But the special part is its speed in generating these responses. GPT-4o can generate responses in as little as 232 milliseconds with an average of 320 milliseconds, which is much similar to the average human response during a conversation. The quality of GPT-4o makes it a jaw-dropping innovation in this field of human-computer interaction. Like literally you're speaking to a human who is smart, intelligent, and your artificial best friend. But it's not the only capability of GPT-4o with respect to human-computer interaction. It matches GPT-4 Turbo's performance on English text and coding, but it really outshines GPT-4 Turbo when it comes to handling text in languages other than English. If we check GPT-4o model evaluation, we can see how it becomes better compared to GPT-4 Turbo in terms of multilingual audio and vision capabilities. We can see that in terms of text evaluation, it reaches a score of 88.7% on O-shot COT-MMLU, which basically means addressing the general knowledge questions. If we check the audio ASR performance, GPT-4o significantly boosts speech recognition accuracy over Whisper v3, performing much better with lower resource languages. For speech translation, GPT-4o sets a new benchmarks, outperforming Whisper v3 and also Google and Meta models, especially on the MLS benchmark. If we check M3 exam results, which is a standardized test for multilingual and vision evaluation, then we can see that it outperforms GPT-4 across all languages. It also outperforms other AI models including GPT-4 Turbo, Gemini, and CloudOps in terms of vision understanding. Now after checking all these stats, we can see that GPT-4o is especially better at vision and audio understanding compared to existing models. Now let's check what exactly makes it better compared to other AI models. Previously, you wanted to use voice mode to talk to ChatGPT. There was a noticeable delay of around 2.8 seconds for GPT 3.5 and 5.4 seconds for GPT-4. This was because voice mode used three separate models. One model to transcribe your spoken words into text, GPT 3.5 or GPT-4 to understand and respond that particular text, and another model to convert the text response back into the audio. This process meant that GPT-4, the main intelligent model, couldn't directly perceive things like tone, multiple speakers, or background noise, or laughter, singing, or emotional expressions. It only saw the plain text. With GPT-4o, they have trained a single new model that can handle text, visuals, and audio all at once. This means the spoken words got straight into GPT-4o, and its responses can come out as audio incorporating all those subtle expressions. Now, this GPT-4 Omni will definitely bring a new revolution to this world of AI when it becomes accessible to the general public. It will have a feature of vision where you can upload and chat about images. You have the browsing feature where you can get the real-time and up-to-date responses from the model and the web. Then it has a feature of memory where it remembers facts about you and uses it in the future chats. And lastly, it has a feature of advanced data analysis where it can analyze data and create charts. Now, all of these features will be coming to you in maybe a couple of weeks, but till then, let's check what it has in store for us right now. Okay, So here you can see the user interface of GPT-4 Omni. If you go over here, you can check the models that we have, GPT 3.5, GPT 4 and GPT-4 Omni. So let's start by giving it prompts and okay, let's start by being simple. So over here, I'm gonna tell. So, how you doing?
I'm sorry to hear you're feeling that way. What's going on?
I'm good. Can you tell something about you?
Sure. I'm here to help answer questions, chat, and assist with various topics. What's something you're interested in?
Can you start by introducing yourself?
Of course. I'm ChatGPT, an artificial intelligence developed by OpenAI. My job is to assist with answering questions, engaging in conversations, and providing information on a wide range of topics. How about you? What's something you'd like to share about yourself?
You're ChatGPT-4 Omni, right? So can you tell me how you're better than ChatGPT-4?
Yes, I'm based on the GPT-4 architecture, often referred to as ChatGPT-4. The key improvements in models like mine generally include better understanding of context, more accurate and relevant responses, and enhanced ability to handle complex queries. These improvements make interactions smoother and more helpful. What kind of topics do you enjoy discussing?
Okay, I wanted to check your linguistic options. So can you tell me a joke in Hindi?
बिल्कुल. Here's a joke in Hindi for you. बच्चों, कोई मुझे बताएगा कि वकील और डॉक्टर में क्या अंतर होता है? हाँ मास्टर जी, वकील एक जुर्म करता है और डॉक्टर उसे अच्छा कर देता है.
That's funny. Tell me another joke.
Glad you liked it. Here's another one. डॉक्टर साहब, मेरी पत्नी को नींद में बातें करने की आदत है. इसे कोई बीमारी नहीं मानते. लेकिन डॉक्टर साहब उसकी सारी बातें फोन पर होती हैं.
Okay, great. So now let me give it an image and check. So I'm gonna give this image. Add. Okay, I'll just say, can you tell me which fish is this? Which fish is this? Okay, yeah. Question mark. Come on. This is basically a glowfish. Might be correct, might be wrong. You just tell me in the comment section that is it right or wrong. I'm bad in the terms of identifying a fish, but still. So over here, you can see that GPT-4 Omni responses are very similar to GPT-4. And maybe in a couple of weeks, we might see a new variant of Omni, which will be very fast and efficient than GPT-4. So you can see that the response time are much more similar to the ChatGPT-4. And that's why maybe they have kept the name as GPT-4 Omni rather than GPT-5. But the difference which we might come across might lie in its response time once it's released. So for now, what you can do is you can just visit their website. This particular link I will be putting in the description. You can check it from there. And also you can check out these videos which they have posted on the site to know more about the features of GPT-4o. Now, it's basically very sad for me that I can't use these particular features, of course, because they haven't released it yet. But at the same time, it's really giving me an excitement to check these new features of GPT-4 Omni. Also, one thing which you can all do is to put your particular opinions about this innovation in the comment section, and we would love to hear your opinions on that.
Transitioning from text-based models, we'll delve into Midjourney AI, which opens up new possibilities for creative visual generation.
In today's modern digital era, we can witness the impact that AI has created on our world. Starting from healthcare to finance to transport, AI has played a huge role in developing these sectors. But do you know what is more interesting? It's when AI contributes to the field of art and can generate some really interesting art pieces just like this. And you know what is more even cooler? The part is, if I tell you that you can generate these kind of images with just a single prompt. And the thing which makes it all possible is called Midjourney. Midjourney is the latest AI model that combines art with technology blended with human creativity to produce stunning and unique art pieces. This tool became a game changer for a lot of content creators, and many of them are using it to either grow their Instagram pages or to generate YouTube thumbnails, and many of the top companies are getting in on the action using it for all sort of design work. On July 12, 2022, the Midjourney image generation platform entered the beta. Midjourney Inc. is the company that owns this AI platform and was founded by David Holtz, who was previously the co-founder of Leapmotion. This company has been working on improving its algorithm, releasing new model versions every few months. On December 21, 2023, the alpha iteration of version 6 was released, which can be considered to generate the most advanced and detailed images out of all its previous versions. But now, the question comes that how does it work to generate such realistic and detailed images? This AI model uses machine learning algorithms to analyze and interpret the data. Now, this data can be in the form of text, image, audio, or video. And then using this data, the algorithm generates new images by analyzing the patterns of the input data. And one of the most common deep learning algorithm it uses is generative adversarial networks, also known as GAN. This algorithm contains two main entities, the generator and the discriminator. From random noise, the generator generates an image which is evaluated by the discriminator that whether it's a real or a fake image. After evaluating, the discriminator will send a feedback to the generator, and using this feedback, the generator will increase its efficiency to generate more real images. The cycle will go on, and unless the generator generates an image which the discriminator will fail to evaluate as a fake image, and the generator will end up generating a completely new image. Another deep learning algorithm that it uses is Recurrent Neural Network, or RNN. It is a class of artificial intelligence model designed to process sequential data by leveraging its inherent memory function. It uses a feedback loop using which it remembers the previous inputs and then uses that information to generate new pieces of data. These algorithms work more efficiently when combined with human creativity. Now, after knowing how it works, let's put our knowledge into practice. So, turn on your computer screens and let's start with Midjourney. So, let us start with the tutorial part for the Midjourney. So, first of all, open your browser and type Midjourney. So, over here, the first link is the official link for Midjourney. And once you click on that link, this kind of interface is going to appear in front of you. Then, click on Join the Beta. Now, in order to access the Midjourney, you should have a Discord account. And once you verify the Discord account, you'll be getting access to Midjourney. So, I accept the invite. Now, if I go down and click any of the newbies, so over here, you can check out the community that is using the Midjourney right now. So if we go down, and there is a separate way of providing a prompt to the Midjourney. So in order to provide a prompt, we should use /imagine, and over here, you can see the prompt. And now I can write any prompt into it. So let's give a simple prompt, and let's give lion with a crown in a sunset. So over here you can see that it's waiting to start, and by the time you can see the other images that was generated by other people in this community. So ours 15% is done. We'll still wait. And our image is in the progress. It's 45% done. We'll still wait. And you can see the other images that are being generated continuously. And that's our image, the lion with the crown in a sunset. Now, to be honest, I like the third image. So I'm going to click on U3. And over here, you can check your image. Click on the image, open in browser, and from here, I can download my image. Yeah, that's downloaded. Now, the Midjourney comes up with a subscription. So in order to check that, put /subscribe, enter, go to manage accounts, and over here, you can see the subscription plans. So we are currently using the standard plan that is active, whereas others you can subscribe to any of the plans and use the Midjourney. So this was a tutorial part for the Midjourney. Now let's move forward. Now, after all this, a question comes that will Midjourney eventually replace human artists? Let's understand. In the year 2022, a Midjourney image called Theatre de Opera Spatial won the first prize in the digital art competition at the 2022 Colorado State Fair. Jason Allen, who wrote the prompt, led Midjourney to generate the image, and then he printed the image onto a canvas and entered it into the competition using the name Jason M. Allen via Midjourney. The two categorical judges were unaware that Midjourney used AI to generate images, although they later said that even if they had known this, they would have awarded Allen the top prize anyways. Another incident took place in Italy. The leading newspaper, Corriere della Sera, published a comic created with Midjourney, which was written by Vanni Sanatoni in August 2022. In December 2022, the creator, Amar Rishi, used Midjourney to generate a large number of images, from which he chose 13 for the book titled Alice and Sparkle. This book features a young girl who built a robot that becomes conscious. Now, all these incidents tell us that humans and AIs are not enemies or competitors. They work together to bring a new revolution. Yeah, in some sectors we have to agree that AI can work more efficiently as compared to humans. But we also have to see that there is always a human brain behind the AI. These AI tools, when blended with human creativity, amplify the quality of the output. And for that, all we need to do is to learn these AI tools and then put our creativity into it. And then very soon, we will be witnessing the progress we make together.
Now that we understand Midjourney, we'll discuss how to use Midjourney effectively, empowering you to create stunning visuals.
Have you ever dreamt of creating stunning visuals without being a professional artist? This video will help you with everything that you need to master Midjourney, from generating basic photos to utilizing its advanced features. Midjourney is a generative AI tool that turns your text description into stunning images. Now, let's see how IT industry can use Midjourney. Users can generate mockups with simple text prompts and visualize idea before the development. Marketers can create eye-catching visuals for their campaign, test multiple concepts, and quickly personalize content for their targeted audience. Midjourney even help create illustrations, build fictional worlds, visualize data for content creator, and help them go beyond. Midjourney is a game changer, streamlining design, marketing, and content creation within the IT industry. A realistic portrait of a woman holding a white cat, an anime-like character with powerful effect, drawing of an ideal scenery, and cinematic view of soldier in middle of war. Let's see why use Midjourney. I would just say 3 points. It's easy to use, boost creativity, explore different style, and find the one you like.
So, to get started, let's see how to sign up for Midjourney. Go into your favorite search browser, then go to search bar and type Midjourney. Let's go ahead and click enter. So we'll see the Midjourney's official website. Go ahead and click on that. There you'll see a landing page that will look something like this. To join Midjourney, we'll go ahead and click on join the beta. After clicking this will take us to their Discord invite. For this, you have to have one Discord account. Since we have already created one, we'll go ahead and just sign into it. As soon as you join, you will see something like this. Midjourney's icon you will find on the left hand side of your screen that will look something like a sailing boat. Now to go ahead, we'll just scroll down and join any of the newbie channels. There, you can see so many creation of so many people. This is an open channel. Anyone can come and write a prompt. They'll get their image generated right over here. But in this, you'll lose your image as soon as you create it because there's so much content over here. So to go ahead and add Midjourney bot to your server or directly message it, we have to go on left hand side and click on symbol that will look something like this. Here you can see Midjourney bot. Right click on it. There you can see the profile. Click on profile. It will open a menu like this. If you click on send message, it will directly take you to the Midjourney bot. There you can message directly and get your results. So let's go ahead and see our information. To do that, we have to type /info, then just hit enter. Here we can see user ID, our subscription, and even the fast time remaining. Here we can see how many images we have created and fast images that has been generated by Midjourney. To go ahead and join Midjourney bot to a personal server, we have to create a server first. Let's go ahead and create a server. On the left hand side of your screen, you can see something like this. Click on it. Then you can select create my own.
you can choose for me and my friends and go ahead and name it. For now, we'll name it Edureka Server 3. We'll go ahead and create. Here, we have landed on our page. Now, to add bot to a server, we would just go ahead and click over here. We can see Midjourney bot. When you click on it, you can see an option of add app. Click on it and then you can choose a server you want to add it to. We'll go ahead and choose Edureka Server 3. Then click continue. After that, you would have to select the permission you want to give Midjourney bot. Then go ahead and authorize it. Here, we got success. After adding Midjourney bot to your server, you can see a message like this. Let's go ahead and click on Edureka Server 3. So we'll go to Edureka Server. We can see the Midjourney bot has landed. Let's go ahead and create a first image. To do that, we would have to type in /imagine. Then hit enter. Here you can see a prompt-like option. Now, following prompt, you have to give the description of the image you want. For now, we'll go ahead and type this. A bustling city street in modern era. Let's go and see what does Midjourney generates. So the image has been generated. Let's go ahead and click on it to get a better view. The images will be generated in the grid of 4 in order 1, 2, 3 and 4. Below the generated image, you can see multiple options like this with U and V, where the number would correspond to the image. Here we can see a reroll button that will look something like this. The U stands for upscaling and the V stands for vary. If you like an image, for instance, I like the image 2. We'll go ahead and click U2. As we can see, the image has been generated. This is the exact image that I have selected, the second number. If you like it, you can just go ahead and download it. To do that, click on Open Browser. You can zoom in, zoom out to get a better view and right click on it to save it. We'll go ahead and save it as image. Just click on save and it will be downloaded to your disk. Let's go back to our Discord. Here, below the image, we can see multiple options again. But this time, the options are different. Here, we can see Upscale Subtle and Upscale Creative. Both are used to upscale the current image, but in a different manner. It will slightly upscale your image, whereas Creative will change something in the image. Vary. Vary has multiple options. Subtle and Strong. Strong will generate a totally different image, but with similar reference. Whereas Vary region, if in the image you want to change something, you can select it by the region and then change it. We will dive into that later. So, let's go ahead and see zoom out. There's an option of zoom out 2, zoom out 1.5 and custom zoom out. If you want to zoom out, you can click on any of these, and if you want to customize your zoom, you can click on this. We'll dive into that later. Moving ahead, we can see multiple arrows pointing in different directions. What does this mean? Let me tell you. If you click on the arrow, it will pan out the image in the direction which the arrow is pointing. If the arrow is pointing left, the image will pan out on the left side. If the arrow is pointing at right, the image will pan out on the right side. Similarly, on the top and the bottom. Now, let's go ahead and test out our zoom. We'll click on Zoom Out 2.0 and see what it generates. The image has been generated. We'll go ahead and click into it. To get a better view, we'll upscale all of these. This is our original image. Let's go ahead and see our zoomed out images. In our fourth image, these parts have been added, which were originally not here. In a third image, we can see a different scenario over here. There's a zebra crossing, whereas in fourth image, it is not. In every scenario, we can see a different vehicle or a different building. Nothing has changed from the original image, but to zoom out, it had to create new objects that we can see. Now, let's go ahead and see pan out. To go to our original image, we can click on this and it will take us to our original image. Now, let's go ahead and see pan out. Now, I want to see what's up there in that image. To do that, we'd have to click on pan out with top arrow. We'll go ahead and do that. It will give us a prompt window. Now, you can choose what you want. As we are talking about sky, we can have moon or sun over there or a plane flying. Let's go ahead and do a sun in cloudy weather. and click on submit. As we can see in our newly generated images, there is sun, there are clouds, and even both of them. Now, to create perfect prompt, you need to use proper keywords and even give description as much as you can. For that, we'll go ahead and generate this image in painting format. To do that, we'll type /imagine and then prompt. Our prompt will be same as previous one, and we have just added oil painting. Now let's go ahead and hit enter. Here, the Midjourney has used vibrant color in oil painting. All the images look stunning. Now we'll see some of its advanced feature. One of those was released recently by Midjourney, that was Describe. Describe feature of Midjourney allows you to use an image to get its prompt. You can use the prompt to generate new images similar to that one. For that, we'll go ahead and type /describe. Now there are two options, image and link. You can go ahead and click on image to upload image from your system. If you go ahead and click on link, you can provide link from anywhere that can be used by Midjourney to generate description for that image. For now, we'll go ahead and click on image. You can either drag or drop your picture, or you can go ahead and select it. Now, I have selected the image. Just go ahead and hit enter. As a reply to your image, Midjourney bot will generate several of its prompts that can be used to generate images similar to that one. Scrolling down, you can generate any of the images based on the prompt number given. Or you can imagine them all. Let's go ahead and imagine all. Here we can see all the images generated by all 4 prompts. Those are similar to the one we had given. Now let's go ahead and talk about settings in the Midjourney. To check those, type setting. Here we can select the model that we want for our Midjourney and so many other, like style is. Style is low, medium or high. Controls the amount of Midjourney's creative influence on our pictures. Next is public mode. Public mode allows your picture to be seen in Midjourney's public collection. Then comes the remix mode. Remix mode allows you to give extra prompt during variation in image. If you have turned it off, it won't ask you for prompt again, just vary your current image based on its prompt. Then there is variation mode. When we choose variation, it will go ahead and check our preferences, either it is low or high. Based on that, it will give us a varied image. Then we have different modes: relax mode, fast mode and turbo mode. All these 3 modes define the speed at which Midjourney will generate your images. For relax mode, it will generate very slow. But for fast mode, it will use your fast hours but will generate faster. And for turbo mode, your results would be instant but consume more fast hours. You can click on reset setting and set your setting to default. At last, raw mode. Raw mode access a more literal interpretation of your prompt. Now, let's go ahead and design some logos. I have chosen logo for a bakery. Here, the Midjourney has given us some amazing logos. We can select any one of those and use it our own. Now, let's go ahead and explore different parameters that Midjourney allows. For starters, we'd use a new prompt. To add a parameter, we just need to add // followed by the parameter. For the first parameter, we would select aspect ratio. Now, aspect ratio is the ratio between height and width of an image. Let's go ahead and type in 16:9 and hit enter. Now, as we can see, the aspect ratio of the image has changed from the previous ones. Those images were in square and this is a widescreen image. Now, let's go ahead and discuss a different prompt, that is negative prompt. For that, we'll go ahead and type the same prompt. You can add multiple parameters in a single prompt. For negative prompting, you use no and followed by the object you want to remove. We want to remove clouds. We'll type in clouds and hit enter. the clouds have been removed from our original image. Here, cloud, cloud and cloud. Even here. But in our newly generated images, there are no clouds because it has taken a unique approach of making our dolphin underwater. So let's go ahead and check out the parameter that controls imagination of a Midjourney. That is stylus. Now we'll go ahead and type in same prompt. For stylus, the range is from 1 to 1000, and to use stylus, we would type single S followed by the value we want to, 0 being the lowest and 1000 being the highest. We would go and type in 1000 and see the result. This is a fine result and it is stunning. I am amazed. Moving to another parameter, chaos. Higher value of this parameter lead to unexpected and unique outcomes. So let's go ahead and try it. With the chaos value 1, we get results something like this. Now let's move to using reference images to create our own images. For that, we need to go ahead and upload one of our photos. So let's go upload a file. I'm going to use this picture. We'll go ahead and open in browser. Copy its link. For the next one, we would go ahead and type imagine, paste the copied link, then type the prompt we want to. Near a lake with rocky mountain and cloudy sky. Here are our generated images. Now let's go ahead and see another parameter, image weight. It controls the weight of referenced image on our newly generated image. Values ranging from 0 to 2, 0 being the lowest and 2 being the highest. Image weight parameter is given by IW and value I have given as 0. Let's hit enter. With the image weight being 0, the reference has not been taken into consideration. Now let's try it with value 2. Our reference image is the first priority and the prompt is second. With that, let's see how to create stock images. To create stock images, we need to use words like realistic and describe as much as we can in that image. Photography of adult Caucasian female wearing a white shirt and black tie, smiling cross-handed. Studio shot, cinematic look, clean background and white background. Adding all these, now we'll just hit enter. You can see there are multiple keywords that represent stock image. So here are generated images. Let's go ahead and upscale first one. It's a stock image. It's a real looking. Let's create a second stock image in a group. Photo of a diverse team. Remember the keyword photo. Photo of a diverse team celebrating a successful project in a co-working space. Let's hit enter. We'll go ahead and upscale the fourth image. It's a stock image, definitely one. With that, we'll conclude our video, and now I'll show you in Midjourney how you can use. When you enter Midjourney website, you can see collection of photos like this that has been generated by multiple Midjourney users. So you can find all your generated images in archive. You can see all of these images right over here. You can join the rooms, those are based on themes, or read the images as you like. Midjourney has recently introduced Midjourney's web creation alpha that allows you to create images on the web. This is currently available only for the users those have created more than 100 images already. You can type your prompt directly here without giving any command like /imagine or anything. Let's just go ahead and type shark in mechanical suit. Now our image is being generated in Create. We'll go ahead and check it out. These are the images of shark in mechanical suit. You can even vary both of these, subtle or strong, or you can use rerun button to re-roll the images. You can even see the prompt that you have given for previously generated images by you.
Having explored creative tools, it's crucial to consider AI ethics, where learners will learn about the responsibilities involved in AI development.
In today's ever-evolving digital era, we have to agree that AI has become an integral part of our daily lives. For example, you wake up and ask your virtual assistant to schedule your day. You get in your car and a navigation app suggests the best route based on the real-time traffic. At work, you use AI tools like ChatGPT, Cloud AI, or Google Gemini to help you with research, writing, and analysis. AI is truly embedded in so many aspects of our modern existence. But have you ever stopped to think about the impact that AI is having? And by impact, I mean directly or indirectly, AI is taking decisions that will shape your day-to-day life. Imagine going for a job interview and an AI system scores your resume, determining whether you will get shortlisted or not. In healthcare, AI is increasingly being used for diagnosis and treatment planning. In finance, AI algorithms analyze data and make trading decisions. In criminal justice, AI tools are used for predictive policing and risk assessment. But do you really think that while making all these decisions, AI will remain accurate and unbiased? This question is what AI ethics is all about, and in this video, we will be discussing the answer to this question and understand what exactly is AI ethics. So let's start by understanding what exactly is AI ethics. AI ethics refers to the principles and practices that ensure artificial intelligence systems are developed and used in a way that is ethical, unbiased, transparent, and accountable. Now, AI ethics is a subset of responsible AI that refers to the principles and practices around developing and deploying artificial intelligence in a way that is ethical, trustworthy, and benefits humanity as a whole. Today, AI systems might seem to be unbiased, but if not designed carefully, they can actually continue and amplify societal biases. The best example for this is Google Gemini. Gemini made some really bad mistakes in the past. It showed pictures of German soldiers from World War II as the people of different races, which is not accurate at all. It also made up stories about historical figures like founding fathers of America and the Pope, showing them as different ethnicities than they really were. Even worse, Gemini said something crazy. It said that Elon Musk posting memes online was more harmful than Adolf Hitler. In India, it falsely claimed that PM Modi enforced fascist policies, which is not true at all. However, when asked about other world leaders like the presidents of Ukraine, its responses were not as controversial. These big mess-ups by an esteemed platform like Google Gemini shows why AI ethics is so important. Now, the question comes then, how can we build trustworthy AIs? So let's understand that. In order to build trustworthy AIs, there are 5 pillars to keep in mind: fairness, explainability, robustness, transparency, and privacy protection. Now let's understand them one by one. Very firstly, we have fairness. Coming to fairness, it is basically ensuring that AI systems treat everyone fairly and do not discriminate against underrepresented or disadvantaged groups. For example, you can take an AI-powered recruitment system that ranks job candidates without discrimination based on race, gender, age, or other protected characteristics by using carefully curated training data and bias testing. Then comes explainability. It means being able to understand and explain how the AI arrived at its decisions or outputs based on the training data and machine learning methods used. For example, a loan application AI not only outputs a decision but can show the key factors like income, credit score, debt, etc. that drove its approval or denial recommendation. Then we have robustness. AI systems need to be secure, reliable, and safe, preventing them from being hacked, manipulated, or behaving in unintended ways that could harm individuals. For example, a self-driving car AI built with safety constants and backups to prevent dangerous behavior if the system malfunctions or is hacked. Then comes transparency. The use of AI to drive decisions that impact people should be proactively disclosed, and the details provided about the AI's purpose, training, and functionality should always be disclosed and always be transparent. For example, a healthcare provider disclosing upfront that an AI system helps analyze medical scans and provides information about its capabilities and limitations. Then lastly, we have privacy protection. Any personal data used to train AI models must have robust data governance, de-identification, and protection of individuals' privacy. An example to this is an AI virtual assistant that does not store or use personal conversation data for training unless users explicitly opt in to share their data. If AI systems do not follow these rules, they might keep unfairness going, make decisions without anyone checking if they are right, accidentally hurt people, invade privacy, and make people lose faith in them. The example shows why it is important to use AI in a fair and responsible way that helps everyone out there. Now, after checking the pillars, how do enterprises determine if their solution is at risk of crossing some sort of ethical boundaries? Let's check that out. Imagine you work for a large e-commerce company that uses AI to recommend products to customers based on their browsing and purchase history. While this AI system is designed to enhance the customer experience and increase sales, there are potential ethical concerns that needs to be addressed. As the ethical lead at your company, you realize that it's crucial to establish clear guidelines and principles to ensure your AI solution operates within ethical boundaries. You propose the three following core principles for that. Firstly, AI should augment human intelligence, not replace it. The AI recommendations should assist customers in making informed decisions and manipulate or deceive them. Then we have data and insights belong to their creators. Customer data should be used transparently and with consent, respecting privacy and ownership. Lastly, we have solutions must be transparent and explainable. There should be visibility into how the AI systems is trained, what data is used, and how it generates recommendations. To ensure these principles are followed, you suggest implementing a mapping exercise. This involves listing all the features and intended benefits of the AI's recommendation system and then identifying potential negative consequences or ethical risk associated with each feature. For example, while the AI system's ability to personalize recommendations based on browsing history can enhance customer experience, it could also lead to privacy concerns or promote biases if the training data is not diverse enough. After mapping out benefits and risks, your work with your team is to implement specific rules the AI system must follow. This might include rules such as customer data will not be sold to third-party advertisers. The AI system will be trained on a diverse and inclusive dataset to avoid biases. Customers will have the option to opt out of personalized recommendations or access explanations for why certain products are recommended. To further mitigate ethical risk, you leverage open source tools like Interpret ML or AI Fairness 360, which helps detect and mitigate bias in machine learning models. You also explore tools to ensure compliance and privacy regulations and to measure the uncertainty or confidence levels of AI systems recommendations. Through this proactive approach involving clear principles, risk assessment, rules, and monitoring tools, your e-commerce company can build trust with customers and stakeholders, ensuring that the AI solution enhances the customer experience while operating within the ethical boundaries. According to Exploring Topics, around 77% of companies are either using or exploring the use of AI, which very evidently shows that ethics in AI is not only impacting the individuals, but even the organizations that are massively dependent on AI tools. And now, imagine what could be the consequences if the AI models that the companies are using lacks its ethical configurations. The whole industry will be hugely impacted, and this creates the importance of learning AI ethics.
It's time for another question. AI ethics primarily deals with, and the options are A, the technical aspects of AI, B, the moral implication of AI use, C, the marketing of AI products, D, the coding of AI algorithms. If you know the correct answer, please leave it in the comment section below. With ethics in mind, we'll now focus on prompt engineering, an essential skill for interacting with AI system effectively.
Have you heard about the buzz yet? You will be surprised to know that prompt engineers can earn up to $375,000 per year. That's right, you can make a six-figure salary by helping to train AI chatbots. And you don't even need a technical degree to do it. Before diving into the details, first we need to know what prompt engineering is and what do prompt engineers do. In easy words, prompt engineering is a technology where you assist AI to do work for you, basically with the help of LLMs, large language models like ChatGPT or Google Bard. I always find reading books a tiring task, but models like ChatGPT will help you summarize in matter of seconds with the right use of prompts. That's how prompt engineering works. The more precise you are with your prompts, the better answer you will get. You must be thinking about the thing I mentioned at the start of the video. What do prompt engineers do and why do they get paid so well? It is clearly because they know how to find the right words. Basically, they help coders and developers automate repetitive coding tasks, eventually which helps in efficiency and companies by saving $1 billion. Now that you know, if they are capable of getting the best out of AI, they can make the best use of it by saving a lot of time and capital. As far as I know, there are few mandatory things that one should focus on while trying on the best prompts. Be clear and specific. The more clear and specific you are in your prompt, the better the AI will be able to understand and what you want. Provide context. The AI needs to understand the context of your prompt in order to give a good response. This means providing information about the topic, the audience, and the desired outcome. Use examples. Examples can be very helpful in guiding the AI's response. If you can provide examples of the kind of output you are looking for, the AI will be more likely to produce something similar. After trying on these things, you can see the difference in the outcomes as compared to the previous responses. Now that we have discussed the key points, let's move on to the prompts that you can make while using ChatGPT. Or wait, before that, let me tell you about the idea of the tree of thoughts. It is a technique for improving the performance of large language models. On creative text generation tasks, the basic idea is to use a tree structure to represent the different possible paths that the large language models can take to generate the output text. This allows the LLM to explore a wider range of possibilities and generate more creative and interesting text. Suppose you are asking ChatGPT to write a story on a young boy, but now with the technique, you can change the scenarios, like write a story on a young boy who lives in UK, or something like write a story on a young boy who lives in UK and likes Tom Cruise. So it will connect all of these scenarios. That's really great, right? Again, it depends on the quality of your prompt, how well you are going to be answered. Why not we should also try how it really works and find out if it is useful for us or not. Let me take one example, like write a script for a movie about a group of friends who go on an adventure, but eventually realizes that they are not meant to be together. Let's see what response we get. Okay, now it's generating. We have to wait for the last. Now as we can see, here ChatGPT has told us about 4 friends, Jonah, Calvin, Karen, and Mike, who are sitting at a table laughing and sharing stories, and how the plot changes on the National Park Day. Sounds interesting. Let's try it with the different scenarios, like what if they are all from different backgrounds, or they are planning to go on adventure together, and so on. We need to find out now. I'm really excited for this how ChatGPT is going to respond for the same. Basically, I have tried to add few scenarios that makes the scene more interesting and specific, which is what prompt engineering is all about. The response is a little different now. The title has been changed to Uncharted Realms, and an alternate plot has been formed by 4 different people: Ben, a nerdy coder; Lucia, an ambitious lawyer; Harvey, a laid back musician; and Aisha, a curious anthropologist. As we go down, we can see there are highlights, interior and exterior, along with the theme and places like the airport. So, I'm totally impressed by the output. Well done, ChatGPT. Let's try a few other examples how prompt engineering is going to help developers. I already took an example like this where I have asked ChatGPT to act as an web designer consultant. And here we can see how detailed responses have been generated from platform selection to UI UX design principles to features, SEO and marketing tool, analytics, coding languages. Wow, that's really awesome. And that too with an explanation of where and all what features are needed, how to launch the perfect site by adding customer, what principle one should follow, how to analyze the business data, and also if you need to hire a developer. That's some crazy stuff, don't you think so? Now that we have talked about developers, let's talk about business analytics, or you can say data analytics, and how we are often stuck handling Excel sheets. Not to worry, with the help of prompt engineering and ChatGPT, you have got it covered. We can ask something like act as an Excel sheet and drop your prompt in a precise manner, like how I have done here first. I asked ChatGPT to print an empty Excel sheet. Afterwards, I asked ChatGPT to fill it with the numerical values. As you can see, the table is filled with numbers now. And furthermore, I added a prompt to find the average of data from A1 to A4. And no surprise, ChatGPT came up with the solution. Now I feel even I can be a prompt engineer. I'm just kidding, guys. It's not that easy, but it's also not so tough that we cannot learn. Prompt engineering is still a relatively new field, but it has the potential to revolutionize the way we interact. As prompt engineering continues to develop, it is likely that we will see even more amazing applications of this technology. Who knows? Maybe one day we will be able to use prompt engineering to create AI assistants that are as smart as humans. I will keep updating you with the new technologies like these.
Here's a simple question. Prompt engineering is important for, and the options are A. Creating datasets, B. Structuring AI interaction, C. Writing code from scratch, D. Building user interfaces. If you know the correct answer, please leave it in the comment section below. Having explored prompt engineering, let's now discuss why prompt engineering is important for AI.
Imagine you're developing a virtual assistant application using a large language model such as GPT-3. The goal is to provide users with an engaging and helpful experience by designing effective prompts that generate informative and relevant responses from the model. So let's consider a scenario in which the virtual assistant assists users with the travel planning. So here's how prompt engineering plays a major part. So the scenario is you're planning a trip to Paris and want the virtual assistant to provide recommendations for activities, restaurants, and landmarks to visit during your stay. So let's say you're looking for a help with a traditional prompt and you ask for, what should I do in Paris? And the virtual assistant will assist you here, like, here are some recommendations for activities in Paris. And here's how the enhanced prompt through prompt engineering respond to your queries. So if you input a query that goes like, hey there, I'm super excited about my upcoming trip to Paris. So could you please recommend some must-visit places and activities for me? Then the virtual assistant will generate the response as something like this. So of course, Paris is an amazing city with so much to offer. So here are some must-visit places and activities, and it continues with the explanation about each place. I hope you got the idea of how enhanced prompt provides users with an engaging and helpful experience by designing effective prompts that generate informative and relevant responses from the model. So now let us understand what exactly is prompt engineering. Prompt engineering is a method used in natural language processing, that is NLP, and machine learning. It's all about crafting clear and precise instruction to interact with large language model like GPT-3 or BART. So these models can generate human-like responses based on the prompts they receive. Think of prompt engineering as giving direction to these models. By crafting specific and concise prompts, we guide them to produce the response we want. So to do this effectively, we need to understand the capabilities of the model and the problem we are trying to solve. Fine-tuning prompts allows researchers and developers to improve the performance and usability of LLMs for a variety of applications, including text generation, question answering, language translations, and others. Effective prompts engineering necessitates a thorough understanding of the underlying model's capabilities as well as the problem domain and desired result. Now, let's find out why prompt engineering matters for AI. So, prompt engineering is important in AI because it improves model performance, customization, and reliability. By creating clear and tailored prompts, developers can help AI models produce more accurate and relevant results, reduce biases, improve user experience, and address ethical concerns. In simple terms, prompt engineering ensures that AI systems produce useful and reliable results that meets the needs of users while adhering to ethical principles. So now let's consider an example in the context of text generation for generating product description. Assume you're using an AI model to create product description for an online store. So without prompt engineering, you may issue a generic prompt such as generate a product description for a smartphone. So without prompt engineering, you would get something like this. This smartphone has a high resolution display, powerful processor, and a long-lasting battery life. The given prompt is less effective because it lacks specificity. So it simply says generate a product description for a smartphone. So this may make it difficult to come up with an idea and write something engaging and informative. So having a good prompt can make a significant difference in your writing. They give you a clear idea of what you need to write about and keep you focused and organized, making it easier to generate ideas and express yourself. On the other hand, by using prompt engineering techniques, you can provide more specific instructions or constraints that will tailor the generated descriptions to the target audience or brand style. So with prompt engineering, if you input a query such as create a product descriptions for a budget-friendly smartphone perfect for the young professionals, highlights its affordable, sleek, and packed with the top-notch camera features, and the generated response would be something like this. Introducing our sleek and affordable smartphone designed for young professionals with its stylish design and advanced camera features, capturing life's moments and have never been easier, and it goes on giving its key features along with it. So through this example, we understood that prompt engineering enables the creation of a product description that is useful to the target audience and highlights specific features based on the instructions provided. So this shows how prompt engineering can improve the importance and effectiveness of AI-generated content for specific applications. To help AI models give accurate answers, it's important to create clear prompts. So here are some simple rules for generating effective prompts. First, make it clear. So clearly explain what you want the AI to do. Unclear prompts might confuse the AI and lead to wrong answers, so make sure that the prompt is clear. For example, the unclear prompts is something like write about cars. So where we have not mentioned which type of car or anything much in details. Whereas the clear prompt is write a description of a red convertible sports car. Next, give context. So provide enough information so that AI understands the task. So this helps it give accurate response that makes sense in the given situation. So for example, prompt without context is write a story. Prompt with context is write a story about a girl who discovers a magic book in her attic. Next, show examples. Use examples to show the AI what you are looking for. So this helps it understand the type of response you want. So for example, the prompt without example is describe a beach scene. So prompts with example is describe a beach scene with the palm trees, crashing waves, and the people playing volleyball. Next is keep it short. So don't overload the AI with too much information. Short prompts help the AI focus and give quicker, more accurate responses. For example, long prompts are like this. Write a detailed essay discussing the impact of climate change on biodiversity and ecosystems in tropical rainforest. And short prompts look something like this. Write about climate change effects on rainforest. Next, avoid biases. So make sure your prompts are fair and don't include any unfair assumptions. So biased prompts can lead to biased answers, which isn't helpful. So for example, write about a woman who struggles with her weight. So unbiased prompts are write about a person overcoming challenges. Next, set limits. So tell the AI any rules or restrictions it needs to follow. This helps guide its response and ensures they meet your specific needs. For example, prompt without limits are write a story, and prompt with limits are write a story set in a haunted house with a maximum word count of 500 words. And I hope it's very clear. Next, moving on to some example of prompts for generating text using ChatGPT. For text generation tasks, prompts usually consist of a textual instructions or starting point that directs the model to produce coherent and relevant text. Prompts can be story prompts, questions, or incomplete sentences. Text generation prompts provide context and directions to the model, allowing it to generate human-like text responses. They influence the generated text tone, style, and context. So let's say the prompt is write a short story about a character who discovers a hidden treasure. So by providing a specific storyline and theme in the prompt, the model is guided to generate a coherent and engaging narrative centered around the discovery of a hidden treasure. So the picture illustrates how ChatGPT crafts stories with an engaging touch, making them more captivating and interesting for readers. Next, question answering. So prompt is, can you describe the common signs and symptoms of COVID-19 along with any precautions that can be taken to stay safe? And just like that, it can generate answers to all your questions in mere seconds. So by framing the prompt as a question, the model is directed to provide a concise answer regarding the symptoms of COVID-19, ensuring relevant and informative responses. Next, language translation. Translate the given English sentence, the quick brown fox jumps over the lazy dog, into Spanish while maintaining its original meaning. So by specifying the source and target language in the prompt, along with the input sentence, the model is instructed to perform a precise translation task, ensuring accurate language conversion. Next, code auto-completion. Using OpenAI Codex or ChatGPT, you can perform code auto-completion task. So here we go with ChatGPT. Code generation prompts are usually partial code snippets or descriptions of programming tasks. They specify the desired functionality or behavior that the model should show. Code generation prompts allow the model to generate code that satisfies specific programming requirements, such as implementing algorithms, defining functions, or solving coding problems. So the prompt is, complete the following Python function to calculate the factorial of a number. And here you have also added the function. So, by presenting an incomplete code snippet along with clear instructions, the model is directed to suggest appropriate code completion, helping developers write code more efficiently. Now moving on to the text-to-image generation. Image generation prompts specify the visual sense, objects, or concept that the model should generate. They may include textual descriptions, keywords, or images. So, image generation prompts allow the model on what visual content to generate. They influence the generated image's composition, style, and detail. For example, the prompt is, imagine a tree where the branches are made of stacks of books. So, can you paint me a picture of that? And for the given prompt, we got the image generated as something like this. An imaginative portrayal of a tree with branches composed of stacked books, each book representing a leaf and covers visible. And the next prompt is, picture a cloud in the sky that looks like a huge heart. Can you draw that for me? And here we go. These AI tools leverage prompt engineering techniques to generate text, perform language translation, code auto-completion, and text-to-image generation, demonstrating the versatility and power of prompt based on interactions with AI models. Next, why is machine learning useful in prompt engineering? Machine learning is very helpful in prompt engineering, especially in linguistic and language models, because it helps create better prompts and interactions by analyzing lots of data and finding patterns. So first, understanding language patterns. Machine learning algorithms can analyze large amounts of text to understand linguistic patterns like grammar, syntax, semantics, and context. So this understanding is critical for developing effective prompts that generate desired responses from language models. Next, generating relevant prompts. Machine learning models can suggest or generate prompts based on input data and user preferences. These prompts can be tailored to specific tasks, domains, or user requirements, making them more useful and efficient for guiding language models. Next, optimizing prompts design. Machine learning techniques can be used to optimize prompt design by comparing the performance of various prompts and selecting the one that produces the best result. This iterative process improves prompt engineering practices and the overall performance of language models. And the next is personalizing interactions. Machine learning enables personalized interaction by creating prompts to individuals' users' preferences, history, and context. This personalization increases user engagement and satisfaction with the language model interaction. Next, improving model performance. Machine learning algorithms can be used to fine-tune language models based on prompt response pairs. increasing their performance and accuracy over time. Language model can be trained on a variety of datasets and prompts to produce more relevant and contextually appropriate responses. And next, mitigating bias and misinformation. Machine learning techniques can help identify and mitigate preferences in prompt engineering by examining prompt responses pairs for potential biases or inaccuracies. Language models can produce more fair, inclusive, and reliable results by detecting and correcting for preferences. And I hope it is clear why machine learning is useful in prompt engineering.
Building on our understanding, we'll explore prompt engineering for code generation, showing how AI can assist with programming tasks.
What is prompt engineering for code generation? Prompt engineering is a process that creates a specific prompts or instructions for AI language models to generate a code snippets or scripts. It involves defining objects, using relevant keywords, providing examples, and being specific and concise. This process enhances the accuracy, efficiency, and relevance of code generation tasks performed by AI models. Understanding how prompts LLMs can lead to more powerful and efficient applications. Now, let's understand the principles of prompt engineering. These principles provide a basic guidelines that can create a consistently used to increase prompt engineering effectiveness when it comes to code generation tasks. First one is clarify objective and understand task or goal. And second one is utilize keywords and specificity. And the third one is provide examples for context. Next one is conciseness and relevance. And the last one is encourage creativity and adaptability. Let's understand them in brief. First one is clarify objective and understand task or goal. Here, understanding what you want from code output, including inputs, outputs, evaluation criteria, and any constraints or difficulties is essential before creating a prompt. It is easier to develop prompts that accurately guide the model towards a desired outcome where there is a clarity. And the second one is utilize keywords and specificity. Including an appropriate keyword in a prompt helps to communicate the specifics of the task to the model. By avoiding inconsistency and using a clear language and instructions, you can make sure that the model produces a precise and focused code. Rather than requesting a function to process data, for example, be explicit about the kind of data and expected actions. And the next one is provide examples for the context. The model can better understand the expected output format and functionality by referring to the examples. Prompts are made more understandable by providing a specific examples of the desired code, which helps the models to understand the task. This will increase the probability of producing a code that is in line with the expectation. And next one is conciseness and relevance. The prompts needs to be brief, concentrating on relevant information that is crucial to the assignment and excluding unnecessary informations. Code generation is made more efficient by the model's simplified decision-making process, and clear and concise prompts reduces the confusion. Removing irrelevant information lowers noise and improves the timely efficiency. And the last one is encourage creativity and adaptability. Flexible prompt formulation allows for experimentation with the various strategies, such as linguistic structures, constraints, or templates. Continuous improvements in prompt by tracking a model outputs and iteratively improving prompts. This design creativity maximizes the code generation results by adapting to a various scenarios. Now, how prompt engineering is employed in various tools for code generations. First one is GitHub Copilot. Based on given prompts, GitHub Copilot suggests completions, creates documentations, and suggests new features to help developers write code. And second one is Google AI Code DaVinci. This helps developers to write code in a variety of programming languages by using prompt engineering, producing code snippets in line with the predefined prompts, facilitating a variety of tasks from web development to a natural language processing and machine learning. And the third one is OpenAI Codex. Codex assists developers with the coding task in a variety of domains, such as data science, web development, and game development by utilizing prompts engineering. It creates a code in a number of programming languages based on the precise instructions that users provide. Now, prompt engineering is crucial for guiding AI models in generating code accurately. Let's explore practical examples across different complexity levels. First, we will try for universal starter code, that is hello world program in Java. So for that, we have to give a prompt like generate a hello world program in Java. Hit the enter button, you will get a code of hello world program in Java. Next, we will look into the basics one, that is sum of two numbers. For this, we have to give a prompt like generate a function in Python that takes two numbers as input and returns their sum. So now you can see here the Python code is generated with the function name add numbers. So now we have seen how easy level task works. Let's move on to the medium level examples. We'll try to turn the comments into code. First, we'll create a list of countries and then generate a list of their respective capitals. After that, merge the list to create a dictionary mapping each country to its capital. To get this, we have to give a prompt as generate Python code to create a list of countries and generate their corresponding capitals and combine them into a dictionary mapping countries to capitals. Hit the enter button. Here is the generated Python code for given prompt. Here you can see the country's name and also generated a corresponding capitals. So this function defined generate capital, which gave us dictionary mapping countries to capitals. Next one, complete function or next line. If I want to complete a function to calculate the area of rectangle, then we have to give a prompt as write a Python function named calculate rectangle area that takes a two parameter as length and width and returns the area of rectangle. And to include the comments, we just have to type it as include comments to explain each step of the function. So in this code, you can see the function name which we have given in the prompt, that is calculate rectangle area with the parameters length and width. You can also see the comments here. If you use this code, you can get an area of rectangle value. Next, we will try for MySQL code generation. To get the names of employees, we have to give a prompt like generate a MySQL query to retrieve the names of all employees from the employee table. This also generated a MySQL query with a select statement. You can see here. The last example is about how to get an explanation of generated code. To get an explanation of a code, you have to give a prompt as provide a line-by-line explanation of the Python function named calculate factorial, which takes a parameter n and returns the factorial of n. Here in this code, you can see a function name so-called calculate factorial, which we mentioned in our prompt. After that, you can see a line-by-line explanation of a code. This is how you can get the explanation of a code.
Next, we'll apply our skills by building a chatbot with prompt engineering and creating an interactive AI application together.
Embarking on the creation of AI persona chatbots opens up a thrilling and financially rewarding chapter in the realm of artificial intelligence chatbots. This innovative venture stands out because it normalizes the field of AI, removing the barrier of technical expertise. In other words, you don't need to be a programmer or have any coding background to dive into this creative process. Platforms like Flowise are at the forefront of this revolution, offering intuitive tools that simplify the creation of these sophisticated chatbots. With such platforms, the process becomes accessible to everyone, empowering users to bring to life digital avatars of well-known personalities, celebrities, or influencers. These virtual entities can serve various roles, acting as personal assistant, ready to manage tasks, or offering guidance and tailored advice to users' needs. Hello everyone, Edureka welcomes you all once again to our YouTube channel, and this time, let's build a chatbot using prompt engineering. In this tutorial, we'll craft an AI persona chatbot inspired by Steve Harvey, offering a tailored advice on life motivation and personal growth. We'll start from the ground up with the Flowise, guiding you through each step to build your own AI persona chatbot. But before we begin, kindly consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, visit the Edureka website for training and certification courses, the link to which is in the description box below. So coming back to our video, firstly we need to equip our systems with some tools. So let's proceed with installing Flowise. Now, in order to install Flowise, we need to visit the Flowise official website. So let's check that out. So I'm going to type Flowise. Okay, so here's the official website of the Flowise. I'm also going to add this link to the description. You guys can also access it from there. Then in this official website, you can see the GitHub link over here. So we'll go on GitHub, then we'll scroll down, and here we see the quick start option. And this quick start, we have all the steps to start with the Flowise. So firstly, it says to install Node.js. So we'll do that. So over here, based on your system, you can just download the Node.js. So I have already downloaded the Node.js in my system, so I'm not going to repeat the step, but you guys can follow on that. Then again, over here, these are some commands which we have to type on a command prompt. And over here, the first command that you see on your screen is to install the Flowise. Okay, I have already installed Flowise in my system, but you guys have to follow this step if you are new into the Flowise. I have already installed the Flowise in my system, but for the first timers, you have to put this command in your command prompt. So I will go directly with the start Flowise. So this command I'm going to copy and I'm going to put it on my command prompt. You might have to wait for some time. Okay, so over here we can see the Flowise is listening at port 3000 and data source is being initialized. So after getting these two messages, you can directly go to port 3000. So we'll go into that. And here is the Flowise user interface in front of us. Okay, so very firstly, we have to start gathering the data to feed into our chatbot. Okay, so you can choose any of the mediums. You can refer any blogs, any of the YouTube videos or anything. For us, we are going to take some Steve Harvey motivational videos. So we'll go to YouTube. And over here, I'm going to type as Steve Harvey motivation. So we'll try to look for longer videos because the larger the transcript is, the more accurate your data is going to be. So this is pretty long. So in order to download the transcripts, what you have to do is just copy the link of this video. Copy. I'm going to mute it. Not this one. And then we need to go to the site YouTube transcripts. Then over here, we need to paste a URL. Go. And over here, you have the access to the complete transcript.
So what we're going to do is just copy the transcript from here, and then we need to save it to our system. So I've already prepared a folder called transcripts, and you can see 2 transcripts I have already written. So you can seek the transcripts in any of the documents. I have put it in text documents. You can even prefer as PDFs or docs or anything. Now this was for the previous chatbots that I have prepared. So let's delete those because I don't need them, and we'll prepare a new one. So new text document I need, and let's save it as Steve Harvey part 1. Yes. So over here I'm gonna paste the entire transcript. Control S, it got saved. Yeah, and we are ready to go. For this particular video, I'm gonna take one more video of Steve Harvey. So let's search one more video. This we already took. Any other? Yeah, this one looks good. Just pause it for now. Copy link. Again to the same site. We're gonna paste the URL. Yeah. And we are gonna copy the entire transcript. Then again we're gonna go to our system. New text file. Let's give it Steve Harvey part 2. Open, Control V, Control S. Yeah, and we are ready to go. So after downloading this transcript, let's go back to our Flowise. So here we have Flowise. Then I'm going to click on Add New. And here's the canvas where we are going to make our chatbot. So in order to start that, go to Add Nodes. Go for Chains. And here we have Conversational Retrieval QA chain. Just drag and drop it to the canvas. So this Conversational Retrieval QA chain is a tool that is used in creating chatbots, which helps the chatbot to find and provide answers to the questions in a conversation. You can think of it like a library system inside the chatbot that helps in understanding what you're asking and then search through its knowledge to give you best possible answer. This chain is a sequence of steps that the chatbot follows to make sure it understands the questions correctly and retrieves the right information to help you. And over here in the Conversational Retrieval QA chain, you can see as chat model, vector store retriever and memory as the inputs. And the final output is a Conversational Retrieval QA chain. So let's find the input of these. Okay. So our first input is chat model. So we are going to go to Add Nodes and we'll look for chat models over here. And for this chat model, we are going to choose Chat OpenAI. Again, drag and drop. We are going to put it here. Now, you can check out the output as Chat OpenAI. We are going to connect its output to the input of Conversational Retrieval QA chain, especially to the chat model section. Yes. Now, let's check the second input, which is vector store retriever. So we're going to go to plus nodes. Then we're going to look for the vector stores. And where is it? We need in-memory vector store. This one. So drag and drop over here. Now, this in-memory vector store is actually a database that our chatbot is going to follow through. In this document section particularly, we are going to put our transcripts. So let's connect its output to the vector store retriever input of Conversational Retrieval QA chain. So, as I already told you, in this document section, we are going to store the transcripts that we have downloaded. So how to do that? Again, add nodes, go to document loaders, and then select folder with files. Drag and drop, put it over here, output to the input. Now, in the folder path section, we have to put the path of our transcripts. So over here, Control C, and again to our Flowise, folder path, Control V. Okay. Now, we can also see one input as text splitters. So let's also take care of that. So we go down, here we have text splitters, and we're going to take cursive character text splitter, drag and drop over here. The chunk size is already 1000, which is good enough, and chunk overlap, let's put it to 200. Again, it's output to the text splitter input of folders with files. Yeah. Now we have one more thing called embeddings. So we are also going to add embeddings. So okay, over here we have embeddings, and we have OpenAI embeddings. We're going to put it over here. Yeah. So our chatbot is almost ready. So over here you can see this connect credentials part. So let's also check that. We have to add a credential, and for that we are going to take the API keys of the OpenAI. How to do that? Let's check that out. So we are going to go at OpenAI website. So I'll type just platforms.openai accounts and API key. This one. Now for the API keys, we are going to go to platform.openai. So this particular link, I'm going to paste it to the description. You can get it from there. And here we have the access towards the API keys. So just click on create new secret key. You can type anything like test key or anything like that. Create secret key. And it's going to generate a secret key for you. So I'm just going to copy that. And then I'll come back to the flow wise. Yeah. I'm going to save it. Let's save that as AI Steve Harvey. Save. Okay, our chat flow got saved. Back and go to credentials. Let's set this one. Just go to add credentials. Put here as OpenAI API. No. And here it asks for credential names and OpenAI API key. So just paste your API key and let's put here as OpenAI. Add. Yeah. So here we have our credentials. Now again we are going to go to our chat flow, and over here in the connect credentials part we're going to paste as OpenAI. One in our chat model and another one we have in our embedding section. Again we have OpenAI. So our chat flow is fully ready. So again we are going to save it, and then you can go to the section of chat. So it already shows a message, hi there, how can I help you? Firstly I'm going to say hello. Now it's going to take some time and it's going to show error. Okay, it showed how hello, I can assist you. I'll tell him to introduce yourself. Okay, I'm an AI assistant. I'm here to provide you with information assistant. So our chatbot is kind of working, but we want our chatbot to have a personality of Steve Harvey. How to do that? Let's check that out. Now, in order to give that personality of Steve Harvey, let's go to the additional parameters of the retrieval QA chain. And over here, you have a space. Now, put a prompt similar to like this. So, this is a prompt like you are Steve Harvey, an American television host. All this I have gathered from different sources like Wikipedia or like Steve Harvey personality blogs or anything like that. You can get it from there. So, I'm going to select it all. I'm going to copy. And I'm going to paste it over here. You can also pause the screen and read the full prompt. But what I want you to read is the last line because it's important. So the last line, it's like if you have no relevant information within the context, just say, I'm not sure. Or don't try to make up an answer, never break the character. Again, the same thing, answer the user question as you are Steve Harvey and only answer questions found in the context. If you don't have any answer, just respond with something like, I have no idea. Or could you please rephrase that? Or I'm not sure. So yeah. So this prompt will help a model to stick to the relevant information and answer it as Steve Harvey. So again we are put, okay, so firstly we need to save it. Yeah, we saved it. Chat. Again we're gonna put something like, hello,
there. And again, I will say, introduce yourself. Okay, so here you can see now, I'm Steve Harvey, and television host, producer, actor, comedian. I'm known for my hosting shows like Family Feud and all, like whatever we have given in the prompt. So now I'll tell him to, just tell me a joke. Okay, sure thing. Here's a joke for you. Why did the scarecrow win an award? Because he was outstanding in this field. Okay, let's tell him I need a motivation. What does I need? A motivation. I need some motivation, I'll tell. As I am feeling lazy. So here we have our answer. Don't worry, I've got you covered. Remember, success requires a tremendous work ethic and faith. Imagination is the key to achieve your dreams. So dream big, believe in yourself, and take action to make those dreams a reality. You have the potential within you to achieve great things. Keep pushing forward. Okay, so it is working properly. So our chatbot actually got a personality of Steve Harvey.
Here's a simple question for you guys. What is the key component of building a chatbot? And the options are A, database management, B, user interface design, C, effective prompt engineering, D, video processing. If you know the correct answer, please leave it in the comment section below. With practical application in mind, let's discuss how to become a prompt engineer and outline the skill needed for this growing role.
To become a prompt engineer, you have to follow certain steps. Before that, to accomplish this role, you need to be knowledgeable in a number of fields, which includes artificial intelligence, and then natural language processing, after that natural language understanding, and then programming languages, and finally UI UX design. And here are the steps to become a prompt engineer. First one is educational foundation, and the next one is programming proficiency. After that, AI and NLP knowledge, and the fourth one is networking and continuous learning, and last one is build a portfolio and specialize. Let's explore them in brief. First step is educational foundation. So here you have to obtain a degree in computer science, artificial intelligence or NLP for a quick entry into engineering roles and gain a thorough understanding of basics of NLP and AI concepts. And also, you have to focus on the courses covering NLP, machine learning and also programming languages during your studies. And then, apply theoretical knowledges to a real-world scenarios by engaging in projects and courses related to AI applications and continuous learning to stay updated and handle prompt engineering challenges in the evolving of AI field. And the next step is programming proficiency. For those who want to become a prompt engineers, knowing how to program is essential, especially in languages like Python. And also, gain a hands-on experience by working on coding projects, by implementing prompt engineering strategies and testing models. After that step, we have AI and NLP knowledge. Gain in-depth knowledge of AI, machine learning and NLP to become a proficient prompt engineering. And then, acquire a practical experience by working on projects and apply fundamental concepts and tools in a real-world scenario. And also, utilize the acquired fundamental knowledge for efficient and effective prompt engineering practices. And the fourth step is networking and continuous learning. Connect with AI and NLP professionals to build a network and gain valuable insights. And also, you should participate in conferences to stay updated on the latest developments in AI. And engage in online forums to discuss ideas, challenges and advancements with peers. And you have to stay informed about the latest AI advancements to enhance prompt engineering skills continuously. And finally, you have to regularly develop your knowledge and skills to become a proficient prompt engineering. And the last step is build a portfolio and specialize. Here you have to create a project that emphasizes your abilities, forming a strong portfolio to enhance employability as a prompt engineer. And then showcase your prompt engineering skills through your portfolio by providing tangible evidence of your capabilities to potential employers. And also, strengthen your credentials by obtaining relevant certifications and validating your expertise in prompt engineering. Now, let's understand demand of prompt engineering. The demands for prompt engineering is increasing due to the growing adoption of AI and NLP technologies in various industries. These professionals are crucial in optimizing languages models and ensuring accurate contextual relevant and ethical responses. As AI evolves and finds application in multiple sectors, the demand for skilled prompt engineers is expected to grow as they contribute to the successful deployment of AI technologies. Now, let's see the salary details for prompt engineering. The annual salary range for junior or entry-level prompt engineers with a 0.2 years of experience is between Rs 3 lakhs to 6 lakh. And then, the annual salary range for mid-level prompt engineers with a 2 to 5 years of experience is around 6 lakh to 12 lakhs per annum. The annual salary for senior prompt engineer is 12 lakhs per annum. It completely depends upon the individual skills and the salary policies of the organization. In USA, according to the ZipRecruiter report, the salary for entry-level prompt engineer is $31,000. And then, the average annual salary for mid-level prompt engineer is around $59,500. And finally, for senior prompt engineer with a 5 or more than 5 years of experience, it can exceed up to $91,500. Let us know which companies are hiring for prompt engineers. Amazon, Facebook, Microsoft, OpenAI, and Google.
To support our learning journey, we'll provide a prompt engineering roadmap that guides you through essential steps and resources.
Prompt engineer responsibilities. First of all, prompt design. Prompt engineers develop effective prompts considering factors such as context, language style, input format, and desired output. Second is optimization and fine-tuning. They experiment with different variations of prompts and parameters to optimize their performance. They fine-tune prompts based on iterative testing, evaluation, and feedback to achieve desired outcomes, such as improving the accuracy of generated text. Third, data analysis. They then analyze relevant data sources and data sets to identify patterns and insights for prompt design and optimization. They then try to understand the characteristics of the data to create prompts that capture the underlying context and semantics effectively. And finally, evaluation. They conduct testing and evaluation of prompts to assess their performance across different data sets and use cases. They validate the effectiveness of prompts in generating desired outputs and achieving the intended task objectives using metrics and benchmarks. Now let's explore some basic steps to becoming a prompt engineer. Step 1 is understanding about NLP. Familiarize yourself with the fundamentals of natural language processing. Natural language processing is a branch of artificial intelligence that focuses on enabling computers to understand, interpret, and generate human language in a way that is both natural and meaningful. NLP deals with processing and analyzing text and speech data. Learn concepts such as text processing, tokenization, part-of-speech tagging, and semantic analysis. To design prompts, it's essential to understand how language models interpret and generate natural language text. Step 2 is exploring language models. Learn about different types of language models, including traditional statistical models such as n-grams and hidden Markov models. Understand how these models work. Start experimenting with pre-trained language models such as GPT models developed by OpenAI. Use libraries like Hugging Faces Transformers or OpenAI's GPT libraries to interact with these models and generate text based on prompts. Step 3 is learning Python programming. Python is a go-to language for prompt engineering due to its versatility, ease of use, and extensive libraries for natural language processing as well as machine learning. Libraries such as TensorFlow, NLTK, PyTorch, and scikit-learn are commonly used for implementing prompt engineering tasks. So, learn Python programming and learn to make use of these libraries. Step 4 is machine learning. Gain knowledge of machine learning algorithms, models, and techniques, including supervised learning, unsupervised learning, and deep learning. learn about neural networks, recurrent neural networks, convolutional neural networks, and transformers, which are commonly used in NLP tasks. Step 5 is hands-on projects in practice. Do not miss opportunities to work on hands-on projects and exercises that involve prompt engineering tasks such as fine-tuning language models for specific applications or designing prompts for creative text generation. The last and final step is staying updated and continuously learning. Research the latest advancements in NLP, language models, and prompt engineering methodologies by reading research papers and blogs, and also attending conferences. Engage with online communities, forums, and social media groups focused on NLP and machine learning to exchange ideas, ask questions, and learn from others.
Equipped with these skills, let's explore how to build projects using the GitHub Copilot, enhancing our coding experience with AI.
Imagine how it would be for you if you got a virtual side pair alongside you while you're coding. The side pair is helping you to automatically generate code and improve your code by making it faster and more efficient. You can chat with him, you can ask questions, ask suggestions, and much more. Sounds good, right? Well, GitHub Copilot is that AI side pair of yours that makes it all possible. It is an AI coding assistant that helps you to write code faster and with less efforts, allowing you to focus more energy on problem solving and collaboration. GitHub Copilot is proven to provide 55% faster coding and also proven to increase developers' productivity and accelerate the pace of software development. If we take a look at the industry standards, then we can see that around 50,000 plus businesses have adopted GitHub Copilot. 1 in 3 Fortune 500 companies use GitHub Copilot, and 55% of developers preference GitHub Copilot. So now, very firstly, let's check how you can install the GitHub Copilot into your system. So very firstly, we have opened our Visual Studio Code, and in order to install the GitHub Copilot, go to the extensions, and as an extension, type GitHub Copilot. You can see over here. Now, I have already installed GitHub Copilot in my system, but over here, you can just click on the install button and it will start installing in your system. After that, once you have installed GitHub Copilot, you have to create an account in the GitHub. So over here, you can see the GitHub link. Click on that and it will redirect it to a page of GitHub. Now, I've already installed GitHub. Now, one more thing comes is that this GitHub Copilot needs a paid subscription. So if you want to check the paid subscription for the GitHub Copilot, we can visit this particular website. I'll be putting the website in the description. You can check it out from there. Now, once you come to this website, which is the GitHub Copilot official website, you can scroll down and over here, you can check the subscription plan for GitHub Copilot. For the $10, you can start a free trial over here. Then according to your usage, you can check whichever plan you want. So once we have installed GitHub Copilot and we have subscribed to the GitHub Copilot, it's time for us to use the GitHub Copilot for our coding. So once we are done with the installation part of GitHub Copilot, you can check this icon over here of GitHub Copilot. This icon basically portrays that your GitHub Copilot is active and it's ready to run. And in case if you don't see this icon, just restart your Visual Studio Code. And once you restart, you're going to see this icon over here. Now, I have already created a folder of GitHub Copilot in which we are going to store our files, in which we are going to check the capabilities of GitHub Copilot. So before we jump into the coding part, let me show you something interesting. So for example, let me create a Python file. So I'll put edureka.python. Now, if I put a comment over here, comment, and if I put a question like what is inheritance in Python? So as you can see that it is already predicting my question. I'll put enter and it's gonna generate an answer for me. You can see the answer over here. If I want to accept that answer, I have to just click on tab button, and for the convenience I'll put Alt plus Z. And over here you can check the answer for this particular question. Inheritance is a mechanism in which one class acquires a property of another class, and has also given us an example. Now if I check another question, so see over here it's also predicting my next question. It's already asking an example of inheritance in Python. So if I accept that, I put enter and it gave me the example of inheritance. It also gave me a piece of code. So for now I won't get into the coding part. So this is how you can check that GitHub Copilot is also good in predicting our next questions and predicting our next moves. So this is how you can also put a Q&A with GitHub Copilot. So now let's move to the coding part. Let me make a index.html file. I'm gonna put the tags over here. Then I'm gonna put the title as, let's say, Edureka. And in the body, let's say if I make a container. Now, over here, you can also see the H1 and para that GitHub Copilot is suggesting us for the title Edureka. So, the text which is appearing over here is called as a ghost text. Now, if I want to accept this ghost text, I have to click on the tab. And if you just want to reject, just click on escape button. So, for this, it has already given an H1 and a para for this. I'm going to put Alt plus Z to put it in a better format. Now, let's add a style sheet into that. So if I put style.css, and in style.css, I want h1 tag as, let's say, blue in color. Now I have to link the style sheet into a HTML file. So for that, it's already giving a code for us. So if I click on tab button, it's gonna link the style sheet. And then if we run this whole file, you can see it has applied the style sheet. It has given the heading in blue color, welcome to Edureka, and also given us the text. So here you can see how GitHub Copilot is helping us with HTML and CSS. Now let's check some other capabilities and features of GitHub Copilot. So after playing with the HTML and CSS using GitHub Copilot, let's check some more interesting features in GitHub Copilot. So again, we'll go to the .py file which we created in the initial stages of our tutorial. And you can see this option of Ctrl+I. Now, if you press Ctrl+I, it's going to open an option of inline chat feature in GitHub Copilot. So, let's say we give it a prompt of generate a code for calculating the number of days between two dates. Let's keep it simple. Once you press enter, it will start generating the code snippet for you. Now, if you are satisfied with the code snippet, just click on accept, and you can see the code snippet is appearing in your code editor. Now, let's say there is some error in this particular code. So, let's say if I remove this end date from here, and I don't know what is the error in this particular piece of code, how to find it. Now, in order to find this, GitHub Copilot helps you with this particular feature of fix this. Now, if I select the whole code, right click, I'll go to Copilot, and if I click on the fixes option, it's gonna fix the whole code by giving you the suggestion and giving you the solution for this particular problem that you are facing. So it already says that your problem is with the function is expecting one argument, but two are provided. So if I accept this, you can see again it put it the last argument over here, which is of end date. Now, GitHub Copilot sometimes gives the accurate code snippet which you want, and sometimes it might differ from what you actually want. Now, in order to do that, just select the whole code and put Ctrl+Enter. Now, once you press Ctrl+Enter, you can see GitHub Copilot coming up with a lot of suggestions for this particular piece of code. Now, if you are satisfied with any of the suggestion, you can just accept the suggestions and it's gonna implement the particular suggestion for your code. Now, let's check one more feature. Now, you can even ask GitHub Copilot to explain the whole code separately. Now, in order to do that, again, go to the Copilot and go to this option of explain this. Now, once you click on the explain this option, now you can see in the chat box, it comes up with the whole explanation of this particular code. Now, this chat box is very much similar to the other AI chatbots that you use like ChatGPT or Google Gemini or Google Bard. Now, you can even ask for more questions to this chat box. So, let's say if I ask him, write a code for bubbles.algorithm, let's say. So, here you can see that is coming up with a code snippet of bubbles.algorithm. Now, this is very much similar to what we do in ChatGPT or other AI bots like Google Gemini and all. But the main feature is that this chatbot is appearing in your code editor and you can just directly copy paste this particular piece of code. You don't need to go to the separate browser, then you have to copy paste the whole code from there. So In short, it makes your job more easy. Now, to make it visually more appealing, you can even drag this chat box anywhere in the code editor. For example, if I put it over here, you can see the chat box appearing over here, or you can make it appear anywhere in the code editor according to your convenience. Now, after checking these basic features, let's check how these features of GitHub Copilot actually help us while we build something. So for now, let's try to make a simple chatbot using Python with OpenAI API, and let's see how quickly we can complete building this chatbot. So very firstly, we're gonna start by importing OpenAI library. Now, to install this OpenAI, you have to go to your terminal and type pip install OpenAI. So after that, let's put our API key. And now you can see that GitHub Copilot is already ready with its suggestions in the form of a ghost text. So we're gonna type tab and let me change my API key. Now, in case if you don't know how to generate the OpenAI keys, then you can just simply visit the OpenAI website, and over here in the platforms you can generate your API key. I'll be putting this link in the description. You can go to this website and make your API keys. So I'm gonna copy my API key and then I'm gonna paste it over here. Then let's make a function of def chat with GPT. And you can see once we write the function, it's already ready with the code. And in this case, we exactly want the same code. Response equal to OpenAI completion, create, engine is GPT 3.5 instruct, exactly. Prompt is from, max tokens is 150. Decent enough. Now, what is this code about? What is this function about? Let's understand. Now, this function will generate text based on the input prompt using OpenAI's language model. The parameters for the completion model include the engine, prompt, and the max token. This engine basically specifies which version of the language model to use. In this case, it's using the GPT 3.5 Turbo Instruct engine, and then it comes to the prompt. Now, this prompt is a text provided to the model to generate a response. It's what the user wants to chat about or to get information on. Then we have the max token. Now, this parameter limits the number of tokens in the generated response. Here it is set to 150. It means that response won't be too long. Now, once the response is received from the OpenAI API, the function returns the generated text. The .choice.textStrip part extracts the generated text from the response object and removes any extra white spaces from beginning and the end. Now, let's move forward and create the main function. So, we are going to put f name.main, and you can see again it came with the ghost text, which is exactly I want. Now, what is this main function? Let me explain you. Now, over here, the code first checks if it's being run directly. Then it enters a loop where it continuously prompts the user for input. If the user inputs an exit command, the loop breaks. Otherwise, it prints the user input and the bot responses. So now, let's go and run our chatbot. We're going to run it in the terminal. So over here, I'm going to ask, who are you? So over here, you can see the generated response. It's like I'm OpenAI's GPT-3 language model programmed to assist you with a variety of this. Okay, great. So you can see that our chatbot is working. Let's say one more question of like, what is the difference between a class and an object, let's say. Again, it came with an answer. A class is a template or blueprint that defines the characteristics and behaviors of a type object, while an object is an instance of class. So it typically answers the question which you want. Now, you already witnessed that how easily we built this chatbot with just a few clicks by accepting the recommendations from the GitHub Copilot. Now, after the chatbot, let's also try to make a linear regression model for us. So we'll start off by importing our required libraries. So firstly, I'm going to start by import matplotlib.pyplot as PLT. Then I'm going to import NumPy. It is already showing me over here. I'm going to click on tab. Then I don't need torch, but from scikit-learn, I need to import the data sets and the linear model. And then from scikit-learn, I need mean squared error. Yes, I do need mean squared error, so I'm going to accept that. And then I will start by loading the diabetes datasets, which is already showing me over here. So I'm going to tab
and then it's going to give me a code. So again, I'm going to click on tab. So again, I'm going to click on tab. Now, what I want is, this is exactly what I want. I just wanted to use only one feature of it. So again, I'm going to click on tab, enter. It's going to give me a code for that. It's already did its slicing, and then I'm going to print it. So print diabetes X, and let's check the data set. This is the exact data set which we wanted, or this one feature we are taking to train our model. So I'm going to delete that. I'm going to move forward by building our model. So after that, we have to split the data into training and test. It already knows what we are planning to do. Put enter. Yes. So over here, it is taking the first 80 elements for the training data set. So I was like, so I'm okay with that. And then for testing, it's taking the last 20. I'm even okay with that. Then for target, I need training and testing. Yes. Again, I'm going to split the target into training and testing. So diabetes by train, diabetes by test, exactly what I want. And then I'm finally going to create the linear regression object or the model. So as you can see, I'm just writing the comments and it is already showing me the code for that. So for this particular model, I don't even have to code a single line, or rarely maybe a line or two I have to code. But everything GitHub Copilot is suggesting me. So I'm going to click on tab. Then I have to train my model, exactly what I wanted to do. Enter. So it's going to fit diabetes X train, diabetes Y train. Enter. And after that, I'm going to make some predictions. Again, exactly. Enter. So diabetes Y predict. Good. I'm going to predict the X testing set. So this is exactly what I want. And then I also want the coefficients. It's giving me the code to print the coefficients. And then again, the mean squared error I want. It's giving the code for mean squared error. Tab, enter, tab, enter. And then I'm gonna give the plot outputs. For that, we need the plt.scatter exactly. And then plt.plot for that one straight line. And then I want plot to show plt.show. So a linear regression model is ready, and as you can see how much coding I did it by myself or manually. GitHub Copilot made the job as easy as it can be. So I'm gonna run the Python file in the terminal. So you saw how conveniently and quickly we made these projects using GitHub Copilot. However, these were just the basic projects we built in order to give you an idea about GitHub Copilot.
Now that we know how to build projects using the GitHub Copilot, in our next module, we will discuss the dangers of AI and understand the potential risks involved.
Before we dive into AI and culture, let's play a little game. I like games and I hope you do as well. So the name of the game is Guess the Title of the Movie. So I'm going to show you 4 different movie posters and your job is to guess the name of the movie. I hope that was clear, the instructions were clear. Guess the name of the movie as you see the posters. You can pause the screen and then go down to the comment section below and leave your answers there. So are you ready? 3, 2, 1. So I hope that you left your answers in the comments and I'm going to give you the titles, of course. So there they are on the screen. The point of this game is to see how many of you recognize the movies. And I think most of my viewers will at least recognize 2 out of the lot. Yeah, and all of these movies are based on artificial intelligence. And if you haven't watched any of these movies, I recommend that you find some time for them. They're mind-blowing. The Matrix is my personal favorite from the ones you see on the screen. But why did we play this game? Well, this is the easiest way to show you guys that people get excited when they hear the term AI thrown about. Because it is cool and it's everywhere and there's so much to talk about. People have so many different opinions and perspectives on the matter. So I think it is safe to agree that it's deeply embedded in not just the Western culture, but cultures all over the world. Wouldn't it be cool to look at some of the factors or elements that led to such a widespread adoption of artificial intelligence in cultures? Well, first up, we're going to take a look at advancement in science. Movies like the one you see on the screen came out before World War I. And they inspired a whole generation of scientists who did some amazing work in the field of computer science and AI. So what were the advancements that led to AI? The first computer was made in 1946 and was called ENIAC. It was enormous. It occupied a space of 50 by 30 foot, but could only do simple calculations. But the benefit was that it was reprogrammable, following which in 1950, who is regarded as Alan Turing, who is regarded as the father of modern computer science, wrote in his paper how to build intelligent machines and how to test their intelligence. But as you know, computers weren't advanced to hold any instructions or data. But Turing's test for intelligence is still used today, over a half a century later. Isn't that amazing? Next, in 1956, at the Dartmouth Summer Research Project on Artificial Intelligence is where it all began. I mean for artificial intelligence. As a matter of fact, this is where the term artificial intelligence was first used. From 1957 to 1974, AI flourished. It became the buzzword. And also the computers could store more information, became faster, cheaper, and more accessible. Yet, they were too slow to exhibit any kind of intelligence. Remember the first movie and the game we played earlier? That came out in 1968. Since the computers were too slow and needed to catch up, the AI buzz started to quiet down. And that was until 1997 when IBM's supercomputer called Deep Blue beat Garry Kasparov at chess. And mind you, Gary was regarded as the grand master of chess. Here's a picture of Deep Blue on the right, so you get an idea of how compact the computers got by the year 1997. So I hope you had as much fun as I had by giving you a little bit of a history on AI. So this was the first element, advancement in science and technology, that influenced the culture around AI today. What's the second one? It is books and literature on AI. Literature can range from the ones that deal in facts, such as academic, scientific, or research papers, to the ones that are very imaginative and completely fictional, like comics. Inspired by the advancement in science and technology, written literature is where writers take the most complex and evolving ideas and present them in a way of stories so common folks can understand and relate to them. But the next element that we are about to see does this better than books, in my opinion: movies and television shows. Movies and TV shows have a wider audience than books. And like I said earlier, the right ones inspire the future scientists. And the advancements that they make inspire the next generation of movies. So it's like a cycle, you see. Let's move on to the next one. Different events such as conferences, seminars, webinars, trade shows and expos, awards and competitions, workshops, and others provided a platform to exchange ideas on artificial intelligence and connected like-minded people. They range from highly academic events like the one we saw earlier, Dartmouth Summer Project on Artificial Intelligence, to things like Comic-Con, where people attend as their favorite characters and meet movie stars. Next one is mainstream media like newspaper, news channels, and radio. Across the world, they have provided coverage on artificial intelligence and brought on experts to talk about it. The next one is normal everyday conversations. Yeah, if AI is going to be everywhere, then it will be part of everyday conversations. All of these different elements, and not to forget social media, have made AI incredibly famous in cultures across the world. But in the past few years, the buzz around AI is back, especially with companies like Amazon, Google, Facebook, Apple, Tesla, and 2 or 3 dozen research organizations making incredible progress in this field. So naturally, that will make you wonder, what is AI like right now? In this section, I have another surprise for you. But before we get to it, let's check out what are the different types of artificial intelligence. So there are 3 main categories of artificial intelligence: ANI, AGI, and ASI. So obviously the first thing that popped in your mind if you don't know about these categories is, what are they? Well, let's briefly take a look. Artificial Narrow Intelligence is what ANI is. It is also known as weak intelligence. Artificial Narrow Intelligence refers to AI systems that can only perform a specific task on their own using human-like capabilities. They can learn from past experiences in regards to that specific task. Even the most complex AI that uses machine learning and deep learning to teach itself falls under ANI. This type of artificial intelligence represents all existing AI, including even the most complicated and capable AI that has ever been created to this date.
Let me give you some examples. Google, Alexa, and Siri voice assistants use AI to detect speech and carry out commands. Today's security and surveillance systems uses facial recognition, which is a type of narrow AI. Social media platforms use it to learn about preferences and show you ads and content that you will enjoy. E-commerce websites like Amazon use it to learn about your shopping activities, where you are located, and so much more to recommend similar products. It also helps them figure out inventory for warehouses for different locations and their unbelievable 2-day delivery. Banking and financial sector use it for fraud activity detection, loan approval, and so on. Last, but certainly not the least, autonomous vehicle use it to navigate the roads on their own. So I hope that you got a little bit of an idea of what ANI is. Let's move on to the second category, which is AGI, and it stands for Artificial General Intelligence, and it's also known as Strong AI. So you're probably wondering what it is. First, we talked about artificial narrow intelligence. Now we're talking about artificial general intelligence. Does it give you any idea? If you're thinking that this type of artificial intelligence is good at general tasks, meaning all tasks, instead of a specific task like we saw in the previous category, A and I, you would be right. So AGI will be able to better understand the humans it is interacting with by discerning their needs, emotions, beliefs, and thought processes. It will be able to learn things and apply a broad range of areas, just like human beings can, and unlike narrow artificial intelligence. Right now, AGI is the goal of the field of AI, a place where AI will become part of the physical world and will navigate it like we do. Quite a bit of leading AI researchers think we'll get there in a few decades. There's been a lot of research and development happening on AGI by organizations like OpenAI, DeepMind, Apprente, and many more. So I hope you got an idea about this one. Let's move on to the last type, which is ASI, and it stands for Artificial Super Intelligence. Judging by the name, super, you probably already got an idea that this will be the pinnacle of AI. ASI is where machines will become self-aware like us humans, and they will be overwhelmingly superior than humans at everything. That is, they will have greater memory, faster data processing and analysis, and decision-making capabilities. The potential of having such powerful machines at our disposal seems appealing, but these machines may also threaten our existence or at the very least our way of life. We don't have any examples of AI, thank God for that, because we aren't even ready for artificial general intelligence, the one before this one. Okay, let's switch gears and play a little game because the section after this is going to be a little tense. So let's disperse some tension before we get into dangers of AI. The name of the game is Guess the Type of AI. ANI, which is Artificial Narrow Intelligence, good at specific tasks. AGI is more like human capabilities, but it is not self-aware. And ASI, which is Artificial Superintelligence, which is where the machines become self-aware and get way better than human beings. So I will put up a few pictures or videos and you will have to guess the type of AI. And if you want, you can comment your answers below. Let's see how many of you get them right. Sounds good? Okay, let's begin. First one here is an autonomous vehicle that can drive from point A to point B and even park itself without a human in it. If you guessed ANI, you'd be right. Second one is a Tesla bot. The robot will be able to perform basic repetitive tasks with the aim of eliminating the need for people to handle dangerous or boring work, like getting groceries from Walmart. If you guessed AGI, you wouldn't be completely wrong, but its capabilities will be limited, so it's ANI. These last ones are from Boston Dynamics. They've been making incredible strides in robots navigating the world. And personally, the robots give me the goosebumps. I mean, look at them move. But remember, even though they can navigate the world and obstacles around them, they are not able to understand the humans. So take that as a hint, if you will. So, any guesses? If you guessed AGI, again, you'd be wrong. The point of this game was to show you that everything that we have today is artificial narrow intelligence. All three examples that we saw were artificial narrow intelligence. But there are a lot of companies that are working on artificial general intelligence, and it is around the corner. So I wanted you guys to watch these two clips before we move on to the next section. Freaking goosebumps, right? I mean, imagine one day you go out for a stroll or a jog and you just see this thing just running loose. This is something from your worst nightmare. Robots taking over the world. That must make you wonder, what are the dangers of AI, doesn't it? Well, then let's talk about its dangers in this next section. So what are the near to midterm dangers of AI? And when I say near to midterm, I mean from present day to 20 years in the future. Well, the first one we're going to take a look at is privacy. Imbalances of access to information has been exploited in the recent past and is probably being exploited as you watch this video. Let's see some of the examples to understand how everyone's privacy is always at stake. In 2018, news broke out that a data analytics firm, Cambridge Analytica, had analyzed the psychological and social behavior of users through Facebook's likes and targeted them with ad campaigns for the 2016 US presidential election. Now imagine being able to influence US presidential election. That is crazy. Second example is Clearview face recognition. Clearview is a company that created a face recognition system to help police officers identify criminals. They claimed that it only used publicly available images on social media platforms like Facebook, Instagram to identify criminals. But in January 2020, the New York Times reported that in a demo from Clearview, it scraped personal images from Instagram account of the show's producer. Next example is deepfake, and this is really concerning. Images and videos that are created using deep learning and contain a real person acting or saying things that they didn't do or say are called deepfakes. If you use it for entertainment purposes, deepfakes are fun. But people are creating deep fakes for fake news and information, and worse, deep fake porn. And the last example is mass surveillance in China. China uses over 200 million surveillance cameras and facial recognition to keep constant watch on their people and also mine their behavioral data captured on the cameras. China also implemented a social credit system to rate the trustworthiness of its citizens and give them ratings accordingly based on their surveillance. So on this system, if they rate higher, they get more benefits. And if they rate lower, well, you're out of luck. All of this was done without their knowledge or consent, and that is what is most concerning. As you can see, people's privacy is a big concern right now, and more so in the future years to come. Next one we are taking a look at is AI producing biases. Well, naturally you're going to say, Kevin, how does AI produce biases? Well, AI and machine learning models use parameters and the data it was trained with to make yes or no decisions. There have been many examples in which the parameters don't tell the full story, and the labeling of training data could be done with some sort of bias. So when AI is used for serious tasks like filtering job candidates, giving out loans, accepting or rejecting insurance requests, or even for medical diagnosis, it can have a tremendous impact on somebody's life. Here's just one for example. This image shows how one of these thermometer guns gets classified as a gun when it is held by a person of dark skin and as a monocular when it is held by a person of salmon or white skin. This happened in 2015 where Google's image recognition software made this bias. Now imagine something like this being used by law enforcement in real life scenarios. Ooh, I don't even want to think about that. The next one is centralization of AI. This danger deals with the fact that what if all the AI technological advancements always end up in the hands of a few people or groups? So we are already seeing this now to a certain degree. The amount of time that people spend on platforms like Facebook, Instagram, Twitter, YouTube is so ridiculous. And we're constantly giving data to these companies with each interaction. They all have gigantic oceans of data on their users, which along with their AI enables them to keep making advancement in technology, staying ahead of the curve and always on the top. But it is a very likely scenario that some of these companies will advance to extremely high-tech machines and the rest of the world wouldn't be able to keep up. Will they then become all-powerful like United States with atomic bombs in World War II? Or even worse, because AI can unlock a whole bunch of threats to humanity? Of course, there's this problem of rich getting richer, and also there's this issue of transparency where we don't know how much these organizations know about us and what they can do. Here's another scenario. What if one of these companies, just like in the movie Iron Man, where Tony Stark has his fancy high-tech AI-powered suits, and there's people that are always trying to steal it so that they can reverse engineer. And then there's bad people who want to use this technology to bring mayhem and destruction to the world. So it may not end up being that extreme, but it is entirely possible that these companies may have good motive and good intentions towards the world, but an entity with a bad intention can steal it and use it to cause harm to humanity. So centralization of AI in the hands of few people or group is a real threat. And we need to make sure that we always keep these threats in check. So the next danger is loss in jobs. It's also called AI dislocation. Use of AI in the workplace is expected to result in the elimination of large number of jobs. Though AI is expected to create and make better jobs, education and training will have a crucial role in preventing long-term unemployment. But initially, it will lead to a lot of lost jobs. It is a common misbelief that AI dislocation will only hold true for labor to semi-skilled jobs. But the truth of the matter is that it has already started displacing even high-skilled jobs that require master's and PhD degree. Let me give an example. One such job is consultants for companies to help them make decisions. They are being replaced by AI and machine learning softwares. Let's now talk a little bit about the long-term dangers. And by long-term, I mean 20 to 50 years into the future. So what's the first danger? Well, the first danger that we will talk about is safety and security. AI applications that are in physical contact with humans or integrated into human body could pose safety risks as they may be poorly designed and misused or hacked. Poorly regulated use of AI in weapons could lead to loss of human control over dangerous weapons. So the first example is Neuralink brain implants, and the second one is autonomous weapon system. The second danger, which is very real, and it could happen, and I think it is going to happen at a certain degree at least, is the transformation of society. Remember the times when 3-4 generations would live under the same roof? And since the silicon revolution of 20th and 21st century has broken down families into nuclear units of 2 to 4 people on an average. Today you look around and you'll see everyone with their heads down and eyes glued to their phones. Most of the people prefer to spend their time on their phone than the world around them. And if you want proof of this, you only need to look around. Go to a public space and just observe people. With the AI revolution that we are in, we will see entire realities unfold in real time in augmented reality. And we will be able to interact with an intelligent projection in them that behave like humans. Also, we will be surrounded by robots that human beings will have relations and feelings towards. It is quite possible that on this course, we might forget what it is to be a human. And that brings us to the last danger, that is AI rise to power. I know a lot of people think that singularity or AI rise to power or taking over the world is not a likely scenario, but super intelligent AIs with real world traction, such as an access to pervasive data centers and autonomous robots, could radically alter their environment. Example, harnessing all available solar, chemical, and nuclear energy. If such AIs found uses for free energy that better furthered their goals than supporting human life, human survival would become unlikely. So these were some of the scenarios and dangers that we need to avoid while we go forward with the AI revolution. So let's now find out in this last and final section, what does the future hold for us? An important challenge is to determine who is responsible for damages caused by an AI-operated device or service. In an accident involving a self-driving car, for example, should the damage be covered by the owner, the car manufacturer, the programmer, the person who trains the machines on data? It's really unclear right now. But with that being said, the future of AI is very promising, it's very bright, and it feels like a start of a revolution. World is also taking baby steps towards artificial general intelligence, and it is going to be really, really helpful for humankind. But that also means that we should tread really carefully. And we should take all the dangers as very real, because this isn't something that human beings could control once it gets out of hand, as opposed to every other technology that we had previously. Okay, so how should we prepare ourselves for the future? Educating ourselves about AI or other tech is going to be absolutely paramount if we are going to make this AI revolution a net positive effect for the whole world. So for that, we need to have tough conversation and debates, especially when it comes to developments in artificial general intelligence. Artificial narrow intelligence is not as concerning as what we are trying to achieve right now. And then lastly, we need to ask difficult questions, keep the progress in check by establishing ethics and laws on AI. And if required, there should be licensing and registration of every single tech that we make. So here's my closing remark. With great power comes great responsibility. Just as the world thought that the development of nuclear weapons will wipe out the entire planet. But we now know that if handled with great care, responsibility, and universal cooperation, then it could not only lead to world peace, but resolve energy crisis of the world with nuclear power.
To apply what we have learned, let's brainstorm some artificial intelligence project ideas that can inspire your creativity.
The first artificial intelligence project is Chatbot. Now, Chatbot is an AI software that can start a conversation or a chat with a user through messaging application, websites, mobile apps, or even through calls. Chatbots are increasingly becoming popular. Many companies' websites use chatbots to communicate with their customers. It's been used in almost all the fields, be it education, medical, IT, and even in banking websites, now they're using chatbots. For example, EVA by HDFC Bank. Now, if you're a beginner, then you can program a simple version of a chatbot. There are many chatbots available online. Just learn from them, identify the basic structure, and then build your own chatbot using that structure. You can then enhance it using your creativity and make it better. So this was the first AI project. The next AI project idea is Music Recommendation App. Now, due to AI, Music Recommendation App, which can also be known as Music Recommended Engine, makes it quicker and easier to show the music recommendation that are tailored to each user's interests and preferences. Now, how does this work? So first, it basically collects all the data, which is what the songs the user listens to the most, what is the genre of the song, which language that the user listens to, and so on. Next, it stores all this data and then analyzes it. It then recommends songs from the similar genres and the same language and the songs which have high ratings. You would have seen this in apps like Spotify or Wing, where they have the entire section of songs recommendation for you. So using artificial intelligence, online searching is improving as well, since it makes recommendation related to the user's visual preferences rather than the project description. You can program this music recommendation app by learning from some online blogs or watching some YouTube videos. The next project idea is stock prediction. Now, many people invest in stocks, and they need a stock predictor in order for them to know when to buy the stock. Now, although it is impossible to predict the future, we can make an estimation or guesses and an informed forecast based on the data we have in the present and the past regarding the stocks. This is known as technical analysis, which is used to predict the stock's price direction. Will it increase or decrease after a particular time? So for your project, you can create an application that analyzes the trend of the stock market and offers data-driven insights. You can start off by keeping your stock prediction cycle small and then go on and try for higher values and insights. Also, if you design a good stock prediction application, there'll be a great value and demand for such system and it will make your career. Now moving on to our fourth AI project idea, which is social media suggestions. Now, artificial intelligence has been used in all popular social media networks that we use on a day-to-day basis. Like for example, Facebook uses AI and advanced machine learning to serve you all the content based on your preferences and to recognize people's faces in photos, so you can tag them basically, and also target users for the right advertisement. Also, Instagram, which is owned by Facebook, uses artificial intelligence to identify visuals. Next, LinkedIn uses artificial intelligence to offer job recommendation based on your qualification and interest. It also suggests people to connect with. This also happens in Facebook. So these were just some of the examples of how social media uses artificial intelligence. Now, AI-powered research platform analyze a variety of social media analytics to understand which accounts can provide the most engagement, reach, and influence for a specific industry. So for your project, you can do any of the following tasks, like suggest your users to connect with people they might know, or suggest them some content they might like to watch, or suggest some product they might be interested in, and so on. So this was the social media suggestion project. So now let us move on to the next project idea, which is to identify inappropriate language and hate speech. Now this project sounds easy, but it is quite hard to identify all the hate speeches and inappropriate language. There are many companies like Facebook, Twitter, and YouTube who are trying to create a system like this. So for your project, you can use detection techniques which identify the characters in a context and then compares it to the content
that has already been removed as hate speech. Now, usually this would be used for identifying any hate speech in any post, like Facebook or Twitter posts. So design an artificial intelligence system that looks into things like the text in a post, the reaction and comment to the post, and how closely it matches the common phrases of a hate speech. Also, if it contains at least one appropriate word, then identify those words and report them. So this could be one of your AI projects. Now let us move on to our next AI project, which is lane line detection. Now many of you know that self-driving cars are gaining a lot of popularity. Now as a beginner, it would be very hard to design this, but you can design a part of it which is lane line detection while driving. This lane line detection technique is used by many self-driving autonomous vehicles as well as line following robots. So you can use computer visual techniques and AI to teach the vehicle to go in a particular lane. You can use computer vision techniques such as color thresholding to detect the lane. So usually the lanes are colored in white color, and usually there are double lanes in the middle of the road which separates the direction the vehicle runs in. Then there is usually one white line at the end of the road, after which is the edge of the road. Using all this data, you can design an AI-powered system that detects the lane lines. Now let us move on to our next project idea, which is monitoring crop health. Artificial intelligence has been increasingly adopted as a part of agriculture industry evolution. Using AI, you can perform predictive analysis to determine what is the right date for sowing the seed to obtain maximum yield after the previous harvest. You can also get insights on the crop health, soil health, the fertilizer recommendation, and also the next 7 days weather forecast. So you can create a project which uses artificial intelligence to monitor the health of the crop and check for disease by using various images of the plant that has the same disease. So when a user collects the image of a plant, it will be matched with the images that has already been stored and then diagnose the particular disease, and then even maybe provide an intelligent spraying technique and treatment automatically. Our next project idea is using AI for medical diagnosis. AI has been used in medical industry for analyzing risk, identifying hotspot and chronic diseases, and accounting for social determinants of health. So for your project, you can use artificial intelligence to develop a software that can be programmed to accurately spot signs of a certain diseases in medical images such as MRI scans or X-rays and CT scans. For example, you can design a system that uses artificial intelligence for cancer diagnosis by processing photos of skin lesions. This project can be very helpful to diagnose patients more accurately and also prescribe the most suitable treatment. The next project idea is AI-powered search engine. You can design a search engine which is powered by artificial intelligence, which will scan billions of content available on the web and match the exact search sentence or keyword and will show the relevant information, images, videos, text, and other documents. You can also use ranking algorithms that will rank the content for a particular keyword based on various factors like engagement rate, that is for how long that the user spends on that website, is the content from a reliable website, and so many factors. To do this project, you can refer some online blogs or watch some videos to get started. Also for this project, you need to know a little bit about networks and how the data passes on the internet from one place to another. So this was about the AI-powered search engine. Now let us move on to our next project idea, which is AI-powered cleaning robots. Today's artificial intelligence-powered robots possess no natural general intelligence, but are capable of solving problems and thinking in a limited capacity. You can design a robot that uses artificial intelligence to clean a room by scanning the room size, identifying obstacles, and remembering the most effective routes for cleaning. For starters, you can design a robot that does only one of these things. Then you can enhance it until it effectively cleans the entire room properly. The next AI project idea is house security. Now this is a very interesting project. For this project, you can design a system that uses artificial intelligence to scan and identify the face of the visitor. First, the facial structure of the family members or someone who frequently visits the house can be scanned and stored. So every time a visitor comes near the gate, the system can scan the face, and if it matches the existing facial structure that is stored in the database, it can open the door and allow the person to pass. Else the gate can remain shut and the people living in the house can be notified that the person is waiting outside. The next project idea is handwritten notes recognition. Handwriting note recognition refers to the computer's ability to detect and interpret alphabets and numbers. These inputs could be from various sources like paper document, notes on the phone, photos, and other sources. Note that handwriting characters remain complex since different individuals have different handwriting styles. So you can develop a system that uses artificial intelligence to scan the handwriting notes and convert them into digital format. You can use the artificial neural network, which is a field of study in artificial intelligence, to design the system. The next AI project idea is loan eligibility prediction. Nowadays, one of the major problems banking employees face in this ever-changing economy is the increasing rate of loan defaults. So the employers are finding it difficult to correctly access loan requests and decide whom to give loan and whom not to. So in order to determine whether an individual should be given a loan or no, you can create an AI program that will check a person's loan eligibility criteria by accessing certain attributes of an individual such as the salary, the previous loan details, and so on, and then make a decision to approve a loan or not. This program will make the process a lot more easier by selecting suitable people from a given list of candidates who have applied for loan. So this was about loan eligibility prediction project idea. So now let us move on to our next project idea, which is AI powered voice assistant. So this is one of the interesting artificial intelligence project idea. You can create a voice-based personal assistant using artificial intelligence. So for this, you have to train the system to understand human language, so it can understand and save the command in the database. So next time you give the same command, it will identify the words and perform the necessary action. This can be very helpful, and you can enhance it to do various activities like searching for some information or item on the web, setting alarms, taking down notes, calling someone, playing songs, and many more. The next AI project idea is e-commerce recommendation engine. So in this project, you can build an e-commerce recommendation engine using the similarities among the background information of the items or users to propose the recommendation to the user. So in this project, you can build an e-commerce recommendation engine using the similarities among the background information of the items or users to propose recommendation to the user. So for example, if the user has searched for Apple phones, then you can design a recommendation engine that recommends only Apple phones to the user. Now the other way to do this is you can identify the trends and patterns in the previous and other user item interaction and advise similar recommendation to the present user based on his existing interactions. So an example for this would be if a person has bought a formal shirt, then you can design your recommendation engine to recommend more formal clothing and accessories. You can use artificial intelligence to recommend the user what exactly they need. The next AI project idea is AI-enabled maps. With artificial intelligence, you can create a project that scans the road information and uses algorithm to determine the optimal route to take in order to reach the destination faster. Also to determine which mode of transportation is the best to go to a destination. It could be on foot or in a car, bike, bus, or train. We can also use advanced artificial intelligence in the program by implementing voice assistant that will guide the users about the turns, the potential roadblocks, traffics, and create augmented reality map in real time. The next AI project idea is emotion detection. Now everything that's happening in a science fiction movie could be a future. There are varieties of fields where artificial intelligence is used. One such area of interest is detecting human emotions. There are many top companies investing a lot of money in doing this. So you can design a facial emotion detection and recognition system that can be used to identify human facial expressions. So for this, first the system would have to analyze the facial expression for some time and then perform facial feature extraction and classify the facial expression. For starters, you can design the system to identify only one expression, maybe just happy or normal. Then you can enhance it and try for different emotions. The next AI project idea is AI Health Engine. You can create a project that will use artificial intelligence to give personalized health guidance to a user. The user must provide all the medical reports, and based on that, the artificial intelligence system will check for any pre-existing condition, ongoing health concerns, and gaps in general health knowledge. Then the health engine could be programmed to combine both the personal data of the users and the external health data to provide informed advice to the user. It can also help the users with prescription support, vaccination advice, recommended doctor visits, and specific condition guidance. So this was about AI Health Engine project. Now let us move on to our next project idea, which is trying on online clothes and accessories. Now you would have already seen this feature if you ever visited the Lenskart app. For your project, you can design an artificial intelligence system that takes the input image and computes the person's body model, which would represent their posture and their shape. The segments can then be selected on which the dresses are going to be displayed on, like for example, shirt on the body, gloves for hands, and so on. And then when the user chooses a particular dress, the system can combine them with the body model and update the image's shape representation. Our 20th AI project idea is spam email detection. Spam email detection means detecting emails that are irrelevant to the user by understanding the text content of the email. You can create a project that uses artificial neural network to detect and block spam emails. Also the newsletter or updates or any ad, you can also enhance it. Let's say the newsletters or updates or any ads which are received from emails can be liked by one person but disliked by another. So you can include this feature using artificial intelligence that will filter the email based on the individual user preferences.
Now let's explore the top 10 applications of artificial intelligence, showcasing its impact across various industries.
So at number 10, we have artificial intelligence in artificial creativity. Now, have you ever wondered what would happen if an artificially intelligent machine tried to create music and art. Here's a short audio clip of a classical piece. So this short audio was composed by an AI-based system called MuseNet. Now, MuseNet is a deep neural network that can generate 4-minute musical compositions with 10 different instruments and can combine styles from country to Mozart and to the Beatles. MuseNet was not explicitly programmed with an understanding of music, but instead it discovered patterns of harmony, rhythm, and style by learning on its own. Another creative product of artificial intelligence is a content automation tool called Wordsmith. Wordsmith is a natural language generation platform that can transform your data into insightful narratives. Tech giants such as Yahoo, Microsoft, and Tableau are using Wordsmith to generate around 1.5 billion pieces of content every day. Let's move on to our next field, which is AI in social media. Now, ever since social media has become our identity, we've been generating an immeasurable amount of data through chats, tweets, posts, and so on. And whenever there's an abundance of data, AI and machine learning are always involved. In social media platforms like Facebook, artificial intelligence is used for face verification, wherein machine learning and deep learning concepts are used to detect facial features and tag your friends. Deep learning is used to extract every minute detail from an image by using a bunch of deep neural networks. Machine learning algorithms are used to design your feed based on your interests. Another such example is Twitter's AI, which is being used to identify hate speech and terroristic language in tweets. It makes use of machine learning, deep learning, and natural language processing to filter out offensive content. According to a recent survey, the company discovered and banned 300,000 terroristic linked accounts, 95% of which were found by non-human, artificially intelligent machines. Moving on to our next field, we have AI in chatbots. Now, these days, virtual assistants have become a very common technology. Almost every household has a virtual assistant that controls the home. A few examples include Siri, Cortana, which are gaining popularity because of the user experience they provide. Amazon's Echo is an example of how AI can be used to translate human language into desirable actions. This device uses speech recognition and natural language processing to perform a wide range of tasks on your command. It can do more than just play your favorite songs. It can be used to control the devices at your house, book cabs for you, make phone calls, order your favorite food, check the weather conditions, and so on. Another example is a newly released Google's virtual assistant called Google Duplex that has astonished millions of people. Not only can it respond to calls and book appointments for you, it adds a human touch. It uses natural language processing and machine learning algorithms to process human language and perform tasks such as manage your schedule, control your smart home, make reservations, and so on. Next, we have artificial intelligence in autonomous vehicles. For the longest time, self-driving cars have been a buzzword in the AI industry. The development of autonomous vehicles will definitely revolutionize the transportation system. Companies like Waymo conducted several test drives in Phoenix before deploying their first AI-based public ride-hailing service. The artificial intelligence system collects data from the vehicle's radar, cameras, GPS, and cloud services to produce control signals that operate the vehicle. Advanced deep learning algorithms can accurately predict what objects in the vehicle's vicinity are likely to do. This makes Waymo cars much more effective and safer. Another famous example of autonomous vehicles are Tesla's self-driving cars. AI implements computer vision, image detection, and deep learning to build cars that can automatically detect objects and drive around without human intervention. Elon Musk, the founder of Tesla, talks a ton about how AI is implemented in Tesla's self-driving cars and autopilot features. He quoted that Tesla will have fully self-driving cars ready by the end of the year and a robo-taxi version, one that can ferry passengers without anyone behind the wheel. Tesla's autopilot software goes beyond driving the car where you tell it to go. If you're not in the mood for talking, autopilot will check your calendar and drive you to your scheduled appointment. That sounds pretty amazing. Moving on to our next application, we have applications of artificial intelligence in space exploration. So this is one of the most interesting fields in which artificial intelligence is being implemented. Space expeditions and discoveries always require analyzing vast amounts of data. Artificial intelligence and machine learning is the best way to handle and process data of this scale. So after rigorous research, astronomers use artificial intelligence to go through years of data obtained by the Kepler telescope in order to identify a distant 8-planet solar system. This was accomplished by using AI technology. Artificial intelligence is also being used for NASA's next rover mission to Mars, which is the Mars 2020 rover. The Aegis, which is an AI-based Mars rover, is already on the red planet. The rover is responsible for autonomous targeting of cameras in order to perform investigations on Mars. This proves how far AI has reached. Moving on to our next field, artificial intelligence in the gaming field. Over the past few years, artificial intelligence has become an integral part of the gaming industry. In fact, one of the biggest accomplishments of AI is in the gaming industry. I'm sure all of you have heard of DeepMind's AI-based AlphaGo software. DeepMind's AI-based AlphaGo software, which is known for defeating Lee Sedol, the world champion in the game of Go, is considered to be one of the most significant accomplishments in the field of artificial intelligence. Shortly after the victory, DeepMind created an advanced version of AlphaGo called the AlphaGo Zero, which in turn defeated AlphaGo in an AI to AI face-off. Unlike the original AlphaGo, which DeepMind trained over time by using large quantities of human knowledge and supervision, the advanced system AlphaGo Zero taught itself to master the game. Other examples of AI in gaming include the First Encounter Assault Raccoon, which is popularly known as Fear, is basically a first-person shooter video game. So what makes this game special? The actions taken by the opponent AI are unpredictable because the game is designed in such a way that the opponents are trained throughout the game and never repeat the same mistakes. So basically, they get better as the game gets harder. This makes the game very challenging and prompts the players to constantly switch strategies and never sit in the same position. Moving on to our next application, we have artificial intelligence in banking and finance. We all know that trading mainly depends on the ability to predict the future accurately. Machines are great at this because they can crunch a huge amount of data in a short span. Machines can also learn to observe patterns in past data and predict how these patterns might repeat in the future. An example of this is Japan's leading brokerage house, Nomura Securities, which has reluctantly been pursuing one goal, that is to analyze the insights of experienced stock traders with the help of computers. So after years of research, Nomura is set to introduce a new stock trading system. The new system stores a vast amount of price and trading data in its computer. By tapping into this database of information, it will make assessments. For example, it may determine that current market conditions are similar to the conditions 2 weeks ago and predict how share prices will be changing a few minutes down the line. This will help to make better trading decisions based on the predicted market prices. AI in banking is growing faster than you thought. A lot of banks have already adopted artificial intelligence-based systems to provide customer support, detect anomalies, and credit card frauds. An example of this is HDFC Bank. HDFC Bank has deployed an AI-based chatbot called EVA, which stands for Electronic Virtual Assistant. Since its launch, EVA has addressed over 3 million customer queries, interacted with over 500,000 unique users, and held over 1 million conversations. EVA can collect knowledge from thousands of sources and provide simple answers in less than 0.4 seconds, which is quite impressive. Moving on to our next field, we have artificial intelligence in agriculture. Now, here's an alarming fact. The world will need to produce 50% more food by 2050 because we're literally eating up everything. The only way this can be possible is if we use resources more carefully. With that being said, artificial intelligence can help farmers get more from the land while using resources more sustainably. Blue River Technology has developed a robot called See and Spray, which uses computer vision technologies like object detection to monitor and precisely spray weedicide on cotton plants. Precision spraying can help prevent herbicide resistance. Apart from this, the Berlin-based agriculture tech startup called Peat has developed an application called Plantix that identifies potential defects and nutrient deficiencies in soil by using images. The image recognition app identifies possible defects through images captured by the user's smartphone camera. Users are then provided with soil restoration techniques, tips, and other possible solutions. The company claims that its software can achieve pattern detection with an estimated accuracy of up to 95%. So the next field we're going to talk about is artificial intelligence in healthcare. When it comes to saving our lives, a lot of organizations and medical care centers are relying on AI. There are many examples of how AI in healthcare has helped patients all over the world. IBM's Watson for Health is helping healthcare organizations apply cognitive technology to unlock vast amounts of health data and power diagnosis. IBM has also developed AI software specifically for medicine. More than 230 healthcare organizations worldwide use IBM Watson technology. Google's DeepMind Health is another such example that is working in partnership with clinics, researchers, and patients to solve real-world healthcare problems. DeepMind has successfully developed a system that can analyze retinal scans and spot symptoms of sight-threatening eye diseases. The technology combines machine learning and systems neuroscience to build powerful general-purpose learning algorithms into neural networks that mimic the human behavior. Finally, we have artificial intelligence in marketing. We all know that marketing is a way to sugarcoat your product in order to attract more customers. We humans are actually quite good at sugarcoating, but what if an algorithm or a bot is built solely for the purpose of marketing a brand or a company? It would do a pretty awesome job. For example, let's consider the recommendations provided by Amazon. It's a known fact that 35% of Amazon's revenue is generated by its recommendation engine. Amazon makes use of AI and machine learning to recommend products to their customers. It uses recommendations as a targeted marketing tool to increase their revenue. There are different ways through which Amazon recommends products to you. For example, if you open up Amazon right now, you'll see a few sections like these, right? You'll see something known as your recently viewed items and featured recommendations. Here, Amazon looks at the products that you've been browsing and recommends very similar products to you. You'll also see a section like customers who bought this item also bought this. Here, Amazon studies the shopping behavior of customers who have a similar shopping trend and displays items that have been purchased together in the past. All of this is carried out by using artificial intelligence and machine learning algorithms. Another famous example of recommendation systems is Netflix. Netflix uses machine learning to recommend movies to you based on the data it collects about you, such as your browsing history, your age, your location, and so on. It is also a known fact that over 75% of what you watch is recommended by Netflix. And what is the logic behind Netflix? It is machine learning, artificial intelligence, and deep learning.
Building on applications, we'll look at top 10 artificial intelligence technologies that are driving innovation today.
Now, as we all know, artificial intelligence is expanding and growing every day. It's literally taking over every sector, or it's spreading over every possible industry right now. So let's have a look at the top most trending technologies of AI. So on number 10, we have the robotic process automation, or the RPA. Now, robotic process automation refers to the functioning of corporate processes due to the mimicking human tasks and automate them. Now, in this particular sphere, it is important to bear in mind that AI is not meant to replace humans, but to support and complement their skills and talent. Now, companies like Pegasystems, Automation Anywhere, Blue Prism, UiPath, WorkFusion Focus, etc. work on these. Now, RPA along with AI takes care of customer service, accounting, financial services, healthcare, human resources, supply chain management, and a lot more. But these are definitely some of the important aspects of the robotic process automation. Now let's move on to the next one. So on number 9, we have text analytics and NLP. Now, natural language processing, or the NLP, focuses on the interactions between human languages and computers. It uses text analytics to analyze the structure of sentences as well as their interpretation and intention through machine learning. Now, this technology is widely adopted in fraud detection and for security systems. Many automated assistants and applications derive unstructured data by NLP. Now, some of the service providers in this aspect include the Basis Technology, Expert System, Coveo, Indico, Nime, Mindbreeze, etc. Now, no wonder these terms make it to the top 10 trending artificial intelligence technologies list. So now let's check out what's on number 8. Here we have biometrics. Now, biometrics is definitely a very common term to all of us right now, because we use our fingerprints or the biometrics and also face detection in order to unlock our phones, laptops, etc. Now, biometrics deals with the recognition, measurement, and analysis of the physical features of the body's structure, form, and human behavior. It fosters organic interactions between machines and humans as it works with touch, image, speech, and body language. Also, it is predominantly used for the purpose of market research. Now, VR, Effectiva, Ignicio, Phase First, Sensory, Tazo, all of these provide these technology service. So this was about biometrics. Now moving on number 7, we have cyber defense. Now this is definitely one of the trending technologies AI because it is one of the most important ones with the increasing number of cyber attacks. So cyber defense has become very important in order to save our systems and also our confidential data. Now, cyber defense is a computer defense mechanism that aims to detect, prevent, and mitigate attacks and threats to data and infrastructure of systems. Neural networks that are capable of processing sequences of inputs can be put to use along with machine learning techniques to create learning technologies in order to reveal suspicious user activity and detect cyber threats. So this was about cyber defense. Now on number 6, we have decision management. Now, artificially intelligent machines have the capability of introducing logic to AI systems in order to gear them up to be used for training, maintenance, and tuning. Now, in order to add value to the business and profitable, decision management is already being used by organizations by incorporating it into their applications to propel and execute automated decisions. Some companies that provide this service are the Informatica, Advanced Systems Concepts, Pegasystems, UiPath, etc. Now next up on number 5, we have the marketing automation. Marketing has definitely become one of the most popular strategies for anything that you produce, create, or build right now, because the right kind of marketing can make your product successful. Now, marketing automation just makes this work simpler and better. Now, the marketing and sales teams and divisions have adopted AI and benefited a lot from it in return. Methods incorporating AI through automated customer segmentation, customer data integration, and campaign management are widely used. The 𝐑𝐥𝐻 has grown to become a pioneer in adopting these marketing automation technologies. And in the coming days, definitely most of the companies will only rely on the marketing automation. And that's exactly what makes it one of the most trending technologies in AI. Now next up on number 4, we have digital twin. This is one of the newest and very interesting concept of artificial intelligence. Now, digital twins are just virtual replicas of physical devices that data scientists and IT pros can use to run simulations before actual devices are built and deployed. They are also changing how technologies such as IoT, AI, and analytics are optimized. Now, digital twin technology has moved beyond manufacturing and into the emerging worlds of the IoT, artificial intelligence, and data analytics. As more complex things become connected with the ability to produce data, having a digital equivalent gives data scientists and other IT professionals the ability to optimize deployments, for peak efficiency and create other what-if scenarios. Now moving on to the next one. On number 3, we have the Industrial IoT or the IIoT. Now, IIoT, which is the Industrial Internet of Things, refers to the extension and use of the Internet of Things in industrial sectors and applications. The IIoT encompasses industrial applications including robotics, medical devices, and software-defined production processes. Now, both IoT and IIoT have the same main characteristic of availability, intelligent and connected devices. The only difference between those two is their general usages. While IoT is most commonly used for consumer usage, IIoT is used for industrial purpose such as manufacturing, supply chain monitor, and management system. This technology is definitely for the advanced industries and thus one of the most trending technologies in AI right now. Now on number 2, we have virtual agents. This is definitely very common to all of us because in our everyday life, while booking a flight ticket or ordering a food, anytime we need any help, we are actually talking to virtual agents online. Now, a virtual agent is basically a computer-generated, animated, artificial intelligence virtual character that serves as an online customer service representative. It leads an intelligent conversation with users, responds to their questions, and also performs adequate non-verbal behavior. The introduction of virtual agents have been very helpful as it has reduced the work of human beings and also they provide assistance anytime and anywhere. So this was about the virtual agents. Now moving on number 1 we have augmented reality. This is definitely one of the most fascinating technologies in AI right now. So augmented reality is actually an interactive experience of a real-world environment where the objects that reside in the real world are enhanced by computer-generated perceptual information, sometimes across multiple sensory modalities, including visual, auditory, haptic, and olfactory as well. Now, basically, augmented reality is a technology that superimposes a computer-generated image on a user's view of the real world, thus providing a composite view of what is happening. Now, when we compare a VR and AR, VR implies a complete immersion experience that shuts out the physical world. That's why it's also called as the virtual reality. But in case of AR, that is augmented reality, it adds digital elements to a live view, often by using the camera on a smartphone.
Next, let's discuss the top 10 benefits of artificial intelligence, highlighting how it improves efficiency and quality of life.
At number 1, we have increased automation. Artificial intelligence can be used to automate anything ranging from tasks that involve extreme labor to the process of recruitment. That's right, there are n number of AI-based applications that can be used to automate the hiring or the recruitment process. Such tools help to free the employees from tedious manual tasks and allow them to focus on complex tasks like strategizing and decision making. An example of this is a conversational artificial intelligence recruiter called MYA. This application focuses on automating tedious parts of the recruitment process such as scheduling, screening, and sourcing. MYA is trained by using advanced machine learning algorithms, and it also uses natural language processing to pick up on details that come up in a conversation. It is also responsible for creating candidate profiles, performing analytics, and finally shortlisting applications. It is a known fact that automating the recruitment process reduces time to hire by 50% and helps in finding key hires that impact profitability and growth. Our next benefit is increased productivity. Artificial intelligence has become a necessity in the business world. It is being used to manage highly computational tasks that require maximum effort and time. Did you know that 64% of businesses depend on AI-based applications for their increased productivity and growth? An example of such an application is a legal robot. I call it the Harvey Specter of the virtual world. This bot uses machine learning techniques like deep learning and natural language processing to understand and analyze legal documents, find and fix costly legal errors, collaborate with experienced legal professionals, clarify legal terms by implementing an AI-based scoring system on multiple scales. It also allows you to compare your contract with those in the same industry in order to make sure that yours is a standard document. Moving on to our next benefit, AI helps us in making smarter business decisions. One of the most important goals of artificial intelligence is to help in making smarter business decisions. Salesforce Einstein has managed to do that quite effectively. Following Albert Einstein's dictum that the definition of genius is taking the complex and making it simple, Salesforce Einstein is removing the complexity of artificial intelligence, enabling any company to deliver smarter, personalized, and more predictive customer experience. Salesforce Einstein is a comprehensive artificial intelligence for customer relationship management. Driven by advanced machine learning, deep learning, natural language processing, and predictive modeling, Einstein is implemented in large-scale businesses for discovering useful insights, focusing market behaviors, recommending the best possible solutions, and also automating tasks. Moving on to our next benefit, AI has been mainly used to solve complex problems that cannot be solved through other means. Throughout the years, artificial intelligence has progressed from simple machine learning algorithms to advanced machine learning concepts such as deep learning. This growth in AI has helped companies solve complex issues such as fraud detection, medical diagnosis, weather forecasting, and so on. Consider the use case of how PayPal uses artificial intelligence for fraud detection. Thanks to deep learning, PayPal is now able to identify possible fraudulent activities very precisely. The company processed over 235 billion in payments from 4 billion transactions by more than 170 million customers. Along with so much data, machine learning and deep learning algorithms were used to mine data from the customer's purchasing history in addition to reviewing patterns of likely fraud stored in databases. The derived insights and patterns were then used to predict whether a particular transaction is fraudulent or not. Coming to the next benefit of artificial intelligence, AI is used in strengthening the economy. Regardless of whether you think AI is a threat to the world, it is estimated to contribute over $15 trillion to the world's economy by the year 2030. According to a recent report by PwC, the progressive advances in artificial intelligence will increase the global GDP by up to 14% between now and 2030. It is also said that the most significant economic gains from AI will be in China and North America. These two countries will account for almost 70% of the global economic impact. The same report also reveals that the greatest impact of artificial intelligence will be in the field of healthcare and robotics. The report also precisely states that approximately 6.6 trillion of the expected GDP growth will come from productivity gains, especially in the coming years. Major contributors to this growth include automation of routine tasks and development of intelligent bots and tools that can perform all human-level tasks. Presently, most of the tech giants are already in the process of using AI as a solution to laborious tasks. However, companies that are slow to adopt these AI-based solutions will find themselves at a serious competitive disadvantage. Moving on to our next benefit, which is AI in performing repetitive tasks. So we all know that performing repetitive tasks can become very monotonous and time-consuming. Not to forget, it's quite boring. So using artificial intelligence for tiresome and routine tasks can help us focus on the most important tasks in our to-do list. An example of such an AI is the virtual financial assistant used by the Bank of America called Edureka. Edureka implements artificial intelligence and machine learning techniques to cater the bank's customer service requirements. It does this by creating credit report updates, facilitating bill payments, and helping customers with simple transactions. Edureka's capabilities have recently been expanded to help clients make smarter financial decisions by providing them with personalized insights. As of 2019, Edureka has surpassed 6 million users and has serviced over 35 million customer service requests. Our next benefit of artificial intelligence lies in personalization. Research from McKinsey found that brands that excel at personalization deliver 5 to 8 times the marketing ROI and boost their sales by more than 10% over companies that don't personalize. Personalization can be an overwhelming and time-consuming task, but it can be simplified with the help of artificial intelligence. In fact, it's never been easier to target customers with the right product. An example of this is a UK-based fashion company called Thread that uses artificial intelligence to provide personalized clothing recommendations for each customer. Most customers would love a personal stylist, especially one that comes at no charge. But staffing enough stylists for 650,000 customers would be expensive. Now, instead, the UK-based fashion company Thread uses artificial intelligence to provide personalized clothing recommendations for each of its customers. Customers frequently take style quizzes to provide data about their personal style. Each week, customers receive personalized recommendations that they can upvote or downvote. Thread uses a machine learning algorithm called Thimble that uses customer data to find patterns and understand the likes of the buyer. It then suggests clothes based on the customer's taste. This is how personalization is performed in Thread. Moving on to our next benefit, which is artificial intelligence in global defense. The most advanced robots in the world are being built with global defense applications in mind. This is no surprise since any cutting-edge technology first gets implemented in military applications. Though most of these applications don't see the light of day, one example that we know of is the Ant bot. The AI-based robot developed by the Chinese is an armed police robot designed by the country's National Defense University. Capable of reaching maximum speed of 11 miles per hour, the machine is intended to patrol areas and, in the case of danger, deploy an electrically charged riot control tool. The intelligent machine stands at a height of 1.6 meter and can spot individuals with criminal records. The Antbot has contributed in enhancing security by keeping a track of any suspicious activity happening around its vicinity. Moving on to the next benefit, we have artificial intelligence in disaster management. For most of us, precise weather forecasting makes vacation planning easier. But even the smallest advancement in predicting the weather majorly impacts the market. Accurate weather forecasting allows farmers to make critical decisions about planting and harvesting. It also allows airlines to maximize the use of their planes. It makes shipping easier and safer. And most importantly, it can be used to predict natural disasters that impact the lives of millions. Among companies using artificial intelligence to predict the weather, only a few have invested as heavily as IBM. After years of research, IBM partnered with the weather company and acquired tons and tons of data. The acquisition gave IBM access to the weather company's impressive network of sensors and models, providing a massive pipeline of weather data it could feed into IBM's AI platform Watson in order to attempt to improve any predictions. In 2016, the weather company claimed that their models use more than 100 terabytes of third-party data every single day. The product of this merger is the AI-based IBM Deep Thunder. This system provides highly customized information for business clients by using hyper-local forecasts at a 0.2 to 1.2 mile resolution. This information is useful for transportation companies, utility companies, and even retailers. Moving on to the last benefit of artificial intelligence is that it enhances our lifestyle. Now, we're all aware of how AI is actually enhancing our life and changing our life. In the last decade, artificial intelligence has gone from a science fiction dream to a critical part of our everyday lives. We use AI systems to interact with our phones and speakers through voice assistants like Siri, Alexa, and Google. Cars made by Tesla interpret and analyze their surroundings to intelligently drive themselves. Amazon monitors our browsing habits and then serves up products it thinks we'd like to buy. And even Google decides what results to give us based on our search activity. Artificially intelligent algorithms are here, and they've already changed our lives for better or for worse. But this is only the beginning. And one day we'll look back at AI in 2019 and laugh about how primitive it was. Because in the future, artificial intelligence is going to change everything.
To explore this exciting field, we'll outline an AI roadmap that will help your learning journey in the coming modules.
The first one is face detection and recognition. Using virtual filters on our face when taking pictures and using Face ID for unlocking our phones are two applications of AI that are now a part of our daily lives. The former incorporates face detection, meaning any human face is identified. The latter uses face recognition through which a specific face is recognized. The next use case is text editor and autocorrect. When you're typing out documents, there are inbuilt or downloadable autocorrecting tools for editors that check for spelling mistakes, grammars, readability, and plagiarism depending on their complexity. It must have taken you a while to learn your language before you became fluent in it. Similarly, artificial intelligence algorithms also use machine learning, deep learning, and natural language processing to identify incorrect usage of language and suggest corrections. The next use case are chatbots. As a customer, getting queries answered can be time consuming. An artificially intelligent solution to do this is the use of algorithms to train machines to cater to customers via chatbots. This enables machines to answer frequently asked questions and track orders. Chatbots are taught to impersonate the conversational styles of customer representatives through natural language processing. Advanced chatbots no longer require specific format of input. They answer complex questions requiring detailed responses. The next use case is search and recommendation algorithms. When you want to watch your favorite movies or listen to songs or perhaps shop online, have you noticed that items suggested to you are perfectly aligned with your interests? This is the beauty of artificial intelligence. These smart recommendation systems learn your behavior and interest from your online activities and offer you a similar content. The personalized experience is made possible by continuous training. It is then able to predict your preferences by recommendations that keep you entertained without having to search any further. Moving ahead, let's discuss the AI roadmap for 2021. First, let's discuss based on career. A career in artificial intelligence is not one size that fits all. So if you're interested to start a career in artificial intelligence, here's what you can do. To start off, get a bachelor's degree in subjects like computer science, information technology, mathematics and statistics, or even finance or economics. It's the first step towards achieving your goal of having a career in artificial intelligence. It is important to remember that to have a career in AI, you need to have relevant skills along with your degree. Since artificial intelligence is the buzzword of today's tech world, it is advisable to take up online and training programs to improve your skills. Ideally, a bachelor's degree could only help you land an entry-level job like junior machine learning engineer or junior data scientist. So once you get a job and get into the industry and understand how things work, you can plan your future career. Talking about positions entailing supervision, leadership, or administrative roles, you need to have a master's degree or a PhD. It's best to have a master's degree that offers advanced computer science education with a specialization in artificial intelligence or a master's degree in artificial intelligence. The master's program generally focuses on developing professionals. The robust coursework entails real-world problems and application domain. A relevant master's or PhD degree can help you land a job at senior level like senior machine learning engineer or AI engineer. A relevant master's degree or PhD degree can help you land a job at a senior level like senior machine learning engineer or AI engineer or even robotics engineer with a good salary hike. But even after landing a job, it is important to fine-tune your technical skills. To be an AI engineer, one needs to be up to date with the latest skills and technologies. AI engineers are not just skilled professionals, but have in-depth practical and theoretical knowledge. Having a practical approach towards these technologies will help you gain an edge over other competitors. Additional add-on AI certification programs will win you a brownie point while seeking jobs in AI. Moving ahead, let's see the roadmap based on skills. So let's look at the skills you need to master. The first skill required to become an AI engineer is programming. To become well versed in AI, it's crucial to learn programming languages such as Python, R, Java, and C++ to build and implement models. In-depth knowledge of computer software fundamentals, starting from data structures, trees, graphs, linear programming, and computer architecture, is required, as the role of an AI engineer would be to simulate a machine to behave like a human. Hence, without understanding the working principle of systems, it would be difficult to cope. The next skill is linear algebra, calculus, and statistics. It is recommended to have a good understanding of the concepts of matrix, vectors, and matrix multiplication. Moreover, knowledge in derivatives and integers and their application is essential to even understand simple concepts like gradient descent. While statistical concepts like mean, standard deviation, and Gaussian distributions, along with probability theory for algorithms like naive Bayes and Gaussian mixture, are necessary to thrive in the industry. The next skill is neural network architectures. Machine learning is used for complex tasks that are beyond human capabilities to code. Neural networks have been understood and proven to be by far the most precise way of countering many problems like translation, speech recognition, and image classification, playing a pivot role in AI department. The next skill is signal processing techniques. Competence in understanding signal processing and ability to solve several problems using signal processing techniques is crucial for feature extraction, which is an important aspect of machine learning. Then we have time frequency analysis and advanced signal processing algorithms like wavelets, curvelets, and bandlets. A profound theoretical and practical knowledge of these will help you solve complex situations. The next skill is communication and problem-solving skills. AI engineers need to communicate correctly to pitch their products and ideas to stakeholders. They should also have excellent problem-solving skills to resolve obstacles for decision-making and drawing helpful business insights. Next, let's discuss the roadmap based on job roles. So there are various job roles that you can get with your knowledge in artificial intelligence. So the first one is AI engineer. Artificial intelligence engineers are responsible for developing, programming, and training the complex networks of algorithms that make up AI so that they can function like a human brain. This role requires combined expertise in software development, programming, data science, and data engineering. Though this career is related to data engineering, AI engineers are rarely required to write the code that develops scalable data sharing. Instead, artificial intelligence developers locate and pull data from a variety of sources, create, develop, and test machine learning models, and then utilize application program interface calls or embedded code to build and implement AI applications. The average salary of AI engineer per annum is 8,70,000 rupees in India and $1,14,000 in the United States. The next job role is machine learning engineer. Machine learning engineers must possess strong software skills, be able to apply predictive models, and utilize natural language processing while working with massive data sets. Also, machine learning engineers are expected to know software development methodology, agile practices, and the complete range of modern software development tools, right from IDEs like Eclipse to components of continuous development pipeline. The average salary of a machine learning engineer per annum is 11 lakhs rupees in India and $1,14,000 in the United States. The next job role is as a data scientist. Data scientists are big data wranglers, gathering and analyzing large set of unstructured and structured data. A data scientist role combines computer science, statistics, and mathematics. They analyze, process, and model data and then interpret the results to create actionable plans for companies and other organizations. Data scientists are analytical experts who utilize their skills in both technology and social science to find trends and manage data. They use industry knowledge, contextual understanding, and skepticism of existing assumptions to uncover solutions to business challenges. Average salary of a data scientist per annum is 10 lakh rupees in India and $1,13,000 in the United States. The next job role that we are going to discuss is robotic engineer. Robotics can automate jobs, but they require programmers working behind the scenes to ensure they function well. As a robotics engineer, their primary function is to build mechanical devices or robots that can perform tasks with commands from humans. Other necessary skills required for this role include writing and manipulating computer programs, collaborating with other specialists, and developing prototypes. The average salary of robotics engineer per annum is 6 lakhs rupees in India and $84,000 in the United States.
Finally, to prepare for your interviews, we'll conclude with artificial intelligence interview questions and answers, equipping you for success in the industry.
Let's get started with our basic level questions. So first we have, what is the difference between AI, machine learning and deep learning? I'm sure all of you have this question at the top of your mind because there's a huge confusion between AI, machine learning and deep learning. So let's try to understand how they are different. Now, first of all, AI came into existence at around 1950s. Alright, this was followed by machine learning and then deep learning was introduced. Now, AI basically represents simulated intelligence in machines, which means that it represents any robot or any machine that can mimic the behavior of a human being. Machine learning, on the other hand, is a practice of getting machines to make decisions without being explicitly programmed to do so. Now, if you don't program a machine, how are you going to let it make decisions? Now, the way machines learn is through data. So the most important thing in machine learning is the data. All right, you're going to train machines using data so that they can make their own decisions. Next, we have deep learning. Now, deep learning is basically the process of using artificial neural networks to solve complex problems. So basically, you can think of deep learning as a field that tries to mimic our brain. Okay, so how we have neural networks in our brain, that's exactly how deep learning uses the concepts of artificial neural networks in order to solve problems. Now, AI is a subset of data science. So guys, first of all, data science is the process of deriving useful insights from data. All right, it's the process of extracting information from data that will help you solve problems. So AI is a subset of data science. Now, on the other hand, machine learning is a subset of AI and data science because machine learning comes after AI. So basically in AI, you're going to make use of techniques and concepts of machine learning in order to solve problems. Then we have deep learning. So it's sort of a hierarchy. First we have data science, then we have AI, then we have machine learning, and then we have deep learning. Deep learning is a subset of machine learning, AI, and data science. Okay, I hope this is clear. Now, the main aim of artificial intelligence is to build machines in such a way that they are capable of thinking like human beings. All right, so basically, they must be able to mimic the behavior of a human being. Now, the aim of machine learning, on the other hand, is to make machines learn by providing them a lot of data. Okay, once you make a machine learn through data, it's going to be able to solve complex problems and find solutions. Now, the aim of deep learning is to build neural networks that are able to solve more advanced and complex problems. Okay, now, like I mentioned, deep learning is like an artificial brain. All right, you're basically building an artificial brain that is able to think exactly like how we do. Okay, that's what deep learning is. It's a little more advanced than machine learning. Now, guys, in short, AI, machine learning, and deep learning are used to solve problems through data. So basically, AI makes use of techniques and methods of machine learning and deep learning to solve problems or to draw useful insights from data. So this is the difference between AI, machine learning, and deep learning. I hope all of you are clear with this. Now let's look at our question number 2. The question is, what is artificial intelligence? Give an example of where AI is used on a daily basis. So there are a lot of definitions of AI on the internet. A few of them are: artificial intelligence is an area of computer science that emphasizes on the creation of intelligent machines that work and react like humans. So like I said, basically, a machine that is able to mimic the behavior of a human being is known as artificial intelligence. Another such definition is the capability of a machine to imitate the intelligent human behavior. All right. So artificial intelligence, in short, is basically a machine that we created who can act and think like a human being. Now, where do you think AI is used on a daily basis? There are tons of applications that make use of AI, but one of the most popular applications of AI is a Google search engine. Now, if you just open up Google search and you start typing anything, immediately you get recommendations. These recommendations you derive by using machine learning algorithms, by using deep neural networks, and so on. So on the top of my head, the most general example of AI is the Google search engine. All of us use Google search engine and we know how quick it is with its results and how relevant searches it gives us. All this is because of AI. All right. Now let's look at our next question, which states, what are the different types of AI? Now, a lot of people might not be aware of this because there are a couple of types of AI or a couple of types of machines which are hypothetical. Okay, we haven't actually implemented these machines in the real world. We just have a theoretical definition of these. Okay, let's look at what I'm talking about. So first of all, we have reactive machines AI. Now, these machines are all based on the present actions. Okay, they have no memory or they have no concept of storing memory so that they can learn from their experience. They just react at the moment. Okay, so they're based on present actions and they cannot use previous experiences to form current decisions and update their memory. Then we have limited memory AI. Now, this type of AI has some temporary storage of memory in it. Now, if we have some memory stored in a machine, we know that it can look back into the memory and it can try to make decisions based on previous or past experiences. So limited memory AI makes use of that concept. We have temporary memory here. We do not have permanent memory. But one of the top applications of limited memory AI is the self-driving cars. I'm sure all of you have heard of self-driving cars. They make use of limited memory AI in order to run. Then we have theory of mind AI. Now, like I mentioned earlier, there are a couple of types of artificial intelligent machines which are not actually implemented in the real world. An example of that is theory of mind AI. Okay, this is basically an advanced machine which will have the ability to understand emotions, people, and other things in the real world. We might have come close to this type of AI, but we haven't actually developed something that can understand emotions. Next, we have self-aware AI. Now, this is another such example of a machine that is not built in the real world. This basically includes any machine that has consciousness or that can react just like a human being. Okay, so basically a machine that can take own decisions, that can form own conclusions, and these are machines that have the capability of making their own decisions without any human intervention. Now, this kind of AI is not developed, like I mentioned, because it's going to take up a lot of resources and we still haven't reached that peak of evolution yet. Then we have artificial narrow intelligence. Now, these are the general purpose AI that we see on a daily basis. I'm sure all of you have used Google Assistants, you've used Siri. All of that comes under artificial narrow intelligence. After that, we have artificial general intelligence. Now, these are a little more advanced than the artificial narrow intelligence. Then we have artificial superhuman intelligence. Now, these are one of the most advanced type of AIs that are there. Now, like I mentioned earlier, there are a couple of types of artificial intelligent machines which are not actually implemented in the real world. An example of that is artificial superhuman intelligence. So guys, these were the different types of AI. Now let's look at the next question, which says, explain the different domains of artificial intelligence. Now, AI covers a lot of different domains, starting with machine learning. Okay, so machine learning, like I mentioned earlier, is the science of getting computers to act by feeding them data and by letting them learn a few tricks on their own without being programmed to do so. Okay, so you're not explicitly programming the machine. Instead, you're feeding it a lot of data so that it understands the data and it makes its own decisions. Then we have neural networks. Now, neural networks are basically a set of algorithms, or you can say a set of techniques which are modeled in accordance with the human brain. Okay, like I mentioned earlier, deep learning or neural networks is almost the same thing. Deep learning makes use of neural networks in order to solve complex problems. Now we have robotics. Now, robotics is a subset of AI which includes different branches and applications of robots. These robots are basically artificial agents which act in a real world environment. Okay, so an AI robot works by manipulating the objects in its surrounding, by perceiving, moving, and taking relevant actions. Then we have expert systems. Now, an expert system is basically a computer system that mimics the decision-making ability of a human being. Now, I know all of these domains sound very similar, but they have a very different approach with which they solve a problem. All right, that's the main difference between these domains. Next, we have fuzzy logic systems. Now, traditional systems usually give out output in the form of binary. So usually if you feed something to a machine, it's always in the binary form. The output is also usually in the form of yes, no, true, false, and so on. But when it comes to fuzzy logic, it tries to give an output in the form of degrees of truth. Okay, so it's very different when compared to the traditional computer systems or the traditional programs. Next, we have natural language processing. Now, this is a field of AI that analyzes natural human language to derive useful insights so that it can solve problems. Now, NLP is used majorly in social media platforms. So, Twitter sentimental analysis is done via NLP. Even Facebook uses NLP in a lot of things. Alright, so NLP, fuzzy logic, expert systems, machine learning, neural networks, and robotics are the different domains of AI. I hope all of you are clear with the domains. Now let's look at our next question. Okay, so how is machine learning related to artificial intelligence? There is a huge confusion between machine learning and AI. A lot of people tend to believe that AI and machine learning is one and the same thing. Alright, I would say that you cannot compare AI and machine learning because machine learning is a subset of AI. So basically, AI makes use of machine learning algorithms and machine learning concepts to solve problems. That's the basic difference, or that is where the confusion ends. Machine learning is a technique which is implemented in artificial intelligence in order to solve problems. I hope this is clear. Now let's look at what are the different types of machine learning. So there are three types of machine learning. We have supervised, unsupervised, and reinforcement learning. Now, supervised learning is the type of learning in which the machine learns by using labeled data. Now, to make you understand, let's look at an example. Okay, let's say that you've input images of apples and oranges to your machine and you've labeled them. You've told the machine, like, listen, this is the apple, this is an orange, and the output should also look like this. Okay, so you're labeling the input as apple and an orange, and then you're asking the machine to output an apple and an orange. But when it comes to unsupervised learning, you're not going to label them. You're just going to give them images of apple and oranges, and it has to figure out on its own. It has to try and understand the difference between apple and oranges, try and understand how they look different or how they have a different color. So basically, in unsupervised learning, you don't have a labeled data set. Okay, you're going to give it an unlabeled data set and you're going to ask it to find out and classify which is an apple and which is an orange. Okay, that's the difference between supervised and unsupervised. Now, reinforcement learning is comparatively different. Let's imagine that you were put off in an island. Okay, let's say that you were left in an isolated island. What would you do? Now, initially, we'll all panic and we won't know what to do. But after a point, you'll start exploring the island. You start adapting to the change in the climate conditions. You start looking for food, and then you'll try and understand which food is right for you and which food is wrong for you. You learn from your experience. So in reinforcement learning, basically an agent interacts with its environment by producing actions and discovers errors or rewards. Now, the type of problems that supervised learning is used to solve is regression and classification. When it comes to unsupervised, it is association and clustering. And in reinforcement learning, it solves reward-based problems. The type of data for supervised learning is labeled data. For unsupervised, it is unlabeled. And for reinforcement, it is no predefined data. Now, when I say no predefined data, I mean that the reinforcement learning agent has to start collecting the data. So basically, in reinforcement learning, from data collection to model evaluation, it does everything. In terms of training, supervised learning provides external supervision in the form of labeled data set. In unsupervised learning, there's no supervision. That's why it's called unsupervised learning. Again, in reinforcement learning, there's no supervision at all. The agent has to figure everything out. Now, how supervised learning works is you map the labeled input to the known output. So basically, you teach the machine, like you tell it that this is the input and this has to be the output. When it comes to unsupervised learning, you just provide data to the machine and it has to understand patterns and it has to discover the output. Now, in reinforcement learning, it has to follow the trial and error method. Okay, there's no particular way in which the agent learns. It just has to explore the environment, try out a few things, and learn from that experience. Popular supervised learning algorithms include linear regression, logistic regression. For unsupervised, we have k-means, and for reinforcement learning, we have q-learning. So guys, these were the different types of machine learning, and I also discussed the difference between the three. Now let's move on and look at our next question, which is what is q-learning? In the previous slide itself, I told you that a type of reinforcement learning algorithm is q-learning. So basically here what happens is an agent tries to learn the optimal policy from its past experience with the environment. The past experience of an agent are a sequence of action, state, and rewards. So what happens is, first of all, you take an agent and you put it in state 0. Okay, let's say there's some state known as state 0. Now this agent is going to perform some action A0. On performing this action, it is going to get a reward R1. And if it gets a reward R1, then it's going to move to state S1. But in case the action is wrong, then it's going to get a negative reward, as in some points are going to be reduced. So guys, think of q-learning as a game. You're in state 0 and then you do some action and either you get a reward and go to the next state, or else you lose and you go back to the same state. So until you learn, you're going to be in the same state. But if you keep learning and if you keep receiving positive rewards, then you're going to move on to state 1, and similarly you move on to state 2, 3, and so on. This is what q-learning is about. Now the next question is, what is deep learning? Now deep learning, like I mentioned earlier, basically mimics the way our brain works. Okay, it learns from experience. Now the main concept behind deep learning is neural networks. In our brain also we have neural networks. So what deep learning tries to do is it tries to use the concept of neural networks in order to solve complex problems. So basically we're trying to mimic our brain. Any deep neural network will have 3 types of layers. The first is the input layer. Now this layer will basically receive all the input and it will forward them to the hidden layer. Now in the hidden layer, all the analysis and the computation takes place. Alright, once the computation is done, the result is transferred to the output layer. Now there can be n number of hidden layers depending on the type of problem you're trying to solve. Then we have the output layer. So basically this layer is responsible for transferring the information from the neural network to the outside world. So it's as simple as that. It's pretty obvious. Input layer will take in the input, hidden layer will perform the computations, and the output layer will give out the output. This is a small explanation of what deep learning is. Now, of course, this is much more complex than this, but in short, this is exactly what deep learning is. Now let's look at our next question, which is explain how deep learning works. So basically, deep learning is a concept based on something known as neuron. Okay, neuron is a basic unit of the brain. Inspired from this neuron, they came up with something known as perceptrons or artificial neurons. Now, in this image on the left-hand side, you can see that there is something known as dendrite. These are modules which receive the input. It basically receives all the signals that we send to our brain. Okay, similar to the dendrites are the input layer in our artificial neural networks. Now, in the previous slide, we discussed that the input layer takes in all the input from the outside. That's exactly what a dendrite does. So basically, a perceptron receives multiple inputs, it applies various transformations and functions, and then it provides an output. So basically, guys, just like how our brain contains multiple connected neurons called neural networks, we also have a network of artificial neurons called perceptrons to form a deep neural network. So basically, an artificial neuron or a perceptron, it models a neuron which has a set of inputs, each of which is assigned some specific weight. Okay, all of these inputs will have a specific weight, and the neuron will compute some function on these weighted inputs and give you the output. So the neuron will basically perform analysis and all of that on these weighted inputs to give you some output. This is the basic concept of deep learning. So there are inputs which have some weight on it, and these inputs are then formulated and analyzed in order to give you an output. Now let's look at our next question, which is explain the commonly used artificial neural networks. Now this is a very theoretical question because in order to make you understand how each of them work will take a lot of time. Okay, so I'm just going to briefly tell you what each of these networks are and what they do. Now, feed-forward neural network is the most basic kind of artificial neural network. So basically, the feed-forward neural network is unidirectional. The data passes through the input nodes and leaves through the output nodes. In feed-forward neural network, usually the number of hidden layers depends on the complexity of the problem. Coming to convolutional neural networks, here basically the input features are taken in small sets, okay, or they're taken in batches. This will help the network remember better because you're feeding batches of images or you're feeding batches of input to the neural network. Now, this type of neural network is mainly used for signal and image processing. Next, we have recurrent neural networks. These are also known as long short-term memory networks. So this basically works on the principle of feeding the output of a layer back into the input layer in order to predict the outcomes. Okay, this way it's more precise and it is a little more complex when compared to convolutional networks. Now, one main important point of recurrent neural networks is that they have something known as memory. So basically, each neuron will have some information or some memory stored in them so that they can use this memory in order to take actions in the future. So they have some experiences stored in the form of memory so that they can make their decisions based on previous actions. Now, finally, we have autoencoders. Now, autoencoders are mainly used in dimensionality reduction for learning generative models. Okay, and one more important thing about autoencoders is that the number of units in the output layer and the input layer is the same. This is because the output layer has to reconstruct its own inputs. So these were the different types of artificial neural networks. Now let's look at our next question, which is what are Bayesian networks? Okay, so a Bayesian network is a statistical model that represents a set of variables and their conditional dependencies in the form of a directed acyclic graph. Now, basically, on the occurrence of any event, a Bayesian network can be used to predict the likelihood that any one of several possible known causes was a contributing factor. An example of this is a Bayesian network could be used to study the relationship between diseases and symptoms. So, given a set of symptoms, the Bayesian network can be used to find out the probability of the presence of any diseases. Alright, so the next question is explain the assessment that is used to test the intelligence of a machine. Now guys, this is a very common question and it is sort of a general knowledge based question. Alright, I'm hoping that most of you know the answer to this. So let's look at what the answer is. I'm not sure how many of you have heard of Alan Turing. So Alan Turing was the one who came up with the Turing test. Now this test is basically to determine whether or not a computer is capable of thinking like a human being. So if a machine or if a computer passes this exam, it means that that machine is capable of thinking like a human being. It means that it is successfully an artificial intelligent machine, meaning that it can make its own decisions and interpret data and form their own formulations or form their own conclusions about the data. Now, sadly, I don't think there are a lot of machines that have passed the Turing test. In fact, I'm not sure if there is any machine that's passed the Turing test as of now. But in the near future, I'm sure that we'll see machines who are more smarter than human beings and who have passed this test. Now, for a machine, it might be very easy to do computations, but it might be very hard for a machine to just get up and walk around. Alright, the simple things that us humans can do is very complicated for a machine. They can do computations which we can do in probably a year. They can do those computations in maybe a week or less than a week. But doing simple things such as walking up to the fridge or walking up to the kitchen is very hard for the machines. So to achieve that level of intelligence, we're going to take a while. But in the near future, I'm sure we'll see machines which are way more capable than human beings. Now let's move on to our next level. Now here I'll basically be discussing intermediate level artificial intelligence questions. So let's look at the first question. All right, the first question is how does reinforcement learning work? Explain with an example. Okay, so first of all, reinforcement learning is a type of machine learning. We discussed about reinforcement learning earlier. Reinforcement learning is a type of machine learning wherein there's an agent and you put this agent in an unknown environment. All right, now the agent has to figure out actions, what sort of actions it must take and how it's going to get rewards so that it can move from state 0 to state 1. It's sort of like a video game. If you're in a video game, let's say if you're playing Counter-Strike, you're in level 0 or state 0. Now, if you perform some action and if you get some rewards, you're going to move to state 1. That's exactly how reinforcement learning works. If you perform the relevant actions and the correct actions, you're going to get a reward and you'll move on to the next state. But in case you perform a wrong action, you'll get negative rewards and you'll stay in the same state unless and until you don't learn. All right. So if you learn and achieve, then you'll move to the next state. So basically, a reinforcement learning system will have two main components. It'll have an agent and an environment. Now, the agent, I've been repetitively saying an agent. An agent is basically the reinforcement learning algorithm. It is the model. The model has to learn everything on its own. It has to collect data on its own. It has to draw useful insights on its own. Okay, you're not going to feed any predefined data to this reinforcement learning agent. All right, he has to figure out everything on its own. So let's look at an example of Counter-Strike. Okay, I'm not sure how many of you play the game, but yeah. What happens here is the reinforcement learning agent, or the player one, collects a state S0 from the environment. Okay, so let's suppose that you're playing Counter-Strike and you're in state 0. Now you'll perform some action A0. Right? Initially, it's going to be a random action. So obviously, if you're put in an unknown environment, your first action is going to be random, correct? Because you don't know what's right, you don't know what's wrong. So in your state 0, you'll take an action A0. This will result in a new state S1. And on achieving state S1, the agent will get a reward R1, okay, from the environment. Now, in the case of Counter-Strike games, if you've observed, whenever you win a state or you pass a level, you're going to get some rewards. Maybe you'll get more weapons or you'll get more points. Okay, just like that, in reinforcement learning problem, you'll get some reward R1. Okay, it's basically a plus point. You might get a negative reward or a positive reward based on the action that you take. Now, this loop will go on until the agent is dead or it reaches the destination. So in Counter-Strike, until you have failed the level, you will keep playing the game, right? You'll keep moving from state 1, state 2, state 3, and so on. Or if you've reached the destination, then it's the end game. That's exactly how it works in reinforcement learning. If the agent has explored the entire environment and reached the end state, that's when the loop will end. All right, that's exactly how reinforcement learning works. It is very similar to the games that we play. All right, it's very understandable. Now let's move on and discuss the next question. So the next question is, explain Markov's decision process with an example. Now the solution for a reinforcement learning problem is achieved through the Markov's decision process. This is basically a mathematical approach that maps the solution in reinforcement learning. Okay, so now to understand this, there are a couple of parameters in a Markov's decision process. They're going to be a set of actions called A. Okay, you can name them A. A set of states, there's going to be reward, there's going to be policy, and there's going to be value. To sum it up, what exactly happens in a Markov's decision process is that the agent takes an action A to transition from the start state to the end state. Now, while doing so, the agent receives some reward R for each action that he takes. The series of actions taken by the agent will define a policy or an approach, and the rewards collected will define the value. So the main goal in a Markov's decision process is to maximize the rewards by choosing the most optimum policy, meaning that you're going to choose the best path or the best solution in order to get the most number of rewards. Now, in order to make you all understand this better, let's solve the shortest path problem by using Markov's decision process. I'm sure all of you have heard of shortest path problem. This was, I think, taught to us when we were in 11th or 12th, I'm not sure. Look at the diagram that is over here. This is basically a representation of our problem. Given this representation, our goal here is to find the shortest path between the node A and node D. All right, you can see nodes A, B, C, and D. We have to find the shortest path between node A and node D. Now, the link between these two nodes has a number on it. Okay, for example, between A and C, you can see there's a number 15. Okay, this basically denotes the cost to traverse that edge. So if you want to go from A to C, you'll spend around 15 points. So our end goal here is to travel between node A and node D with minimal possible cost. We should travel between A to D in such a way that our cost is minimal. Now in this problem, if you notice that we have a set of states. Okay, these are denoted by the nodes A, B, C, D. Now, like I mentioned earlier, a Markov's decision process has a set of states. Similarly, in this problem, the set of states are A, B, C, D. The action is to traverse from one node to the other. So going from A to B is basically an action. Going from A to C is another action. Going from A to D is another action, and so on. Now, reward is represented by the cost on each of these links. The policy is the path which is taken to reach the destination. So our aim here is to choose a policy that gets us to node D in the minimum cost possible. So how do you think you can solve this problem? All right, you can start off at node A and you can take baby steps to your destination. Now, initially, only the next possible node is visible to you. Like I mentioned earlier, the initial action taken in a reinforcement learning problem is always random. So at random, you'll choose any node. Let's say you take A to B. Now, if you go from A to B, you can go B to D and you'll reach the destination. So policy is the path which is taken to reach the destination. All right, so it can go from A to B to D, or you can go from A to C to D, or you can go A, C, B, D. All right, now it's up to you to figure out which is the shortest path. All right, you have to choose a path in such a way that the cost between A to D is minimized. So guys, this was a simple problem of how Markov's decision process is used to solve the shortest path problem. Now let's move on and look at our next question. All right, now the next question is explain reward maximization in reinforcement learning. So basically a reinforcement learning agent works based on the theory of reward maximization. Okay, in the previous question itself, I told you that the main aim of reinforcement learning is to maximize the reward. So that's why a reinforcement learning agent must be trained in such a way that he takes the best action so that the reward is maximum. Okay, this is exactly what reward maximization means. He has to choose the best policy in such a way that the reward is maximum. Now let me explain this with a small game. So in the figure, you can see a fox, you can see some meat, and you can see a tiger. Now our reinforcement learning agent is the fox. His end goal is to eat the maximum amount of meat before being eaten by the tiger. Okay, so he has to explore around, eat the maximum number of meat that he can eat before the tiger kills him. Since the fox is a clever fellow, he eats the meat that is closer to him. Okay, so rather than eating the meat which is close to the tiger, he eats the meat which is only close to him. This is because the closer he gets to the tiger, the higher are his chances of getting killed. So as a result of this, the rewards near the tiger, even if they are bigger meat chunks, will be discounted. So because the fox is not going closer to the tiger and eating the meat chunks closer to the tiger, this reward will get discounted. Now I know you all are wondering what discounted is. Now this is done because of the uncertainty factor that the tiger might kill the fox. So what is discounting of reward? Okay, how does it work? To understand this, we define a discount rate called gamma. Okay, this is a parameter and the value of gamma always ranges between 0 and 1. So the smaller the gamma, the larger the discount and so on. So guys, this was reward maximization. So here basically the fox will try to get as much as meat chunks as he can, and he'll also try to avoid getting killed because that will end the reinforcement learning loop. We also discussed the discounted factor. Alright, now that is not needed to understand reward maximization, but I just thought I'll add on some extra info. Now let's look at the next question, which is what is exploitation and exploration trade-off? So basically exploration is, like the name suggests, it is about exploring and capturing more information about an environment. Now on the other hand, exploitation is about using the already known exploited information to heighten the rewards. So consider the same example that we discussed in the previous question. Here the fox only eats the meat chunks which are close to him. Okay, he does not eat the bigger chunks because even though the bigger chunks would give him more rewards, it would get him killed. Okay, he does not go towards the tiger itself. Now, if the fox only focuses on the closest reward, he will never reach the big chunks of meat. Okay, this is what exploitation is. He's sticking only to the information that he knows and he's trying to get the most number of rewards from it. But if the fox decides to explore a bit, it can find the bigger rewards. Okay, the bigger rewards are basically the big chunks of meat which are near the tiger. And this is exactly what exploration is. Okay, exploitation is about using the already known information to heighten your rewards. Exploration, on the other hand, is about exploring and capturing more information about an environment. Alright, so that was about exploitation and exploration. Now let's move on to our next question. So this is a difference question which asks the difference between parametric and non-parametric models. So a parametric models basically uses a fixed number of parameters to build the model. Now first of all guys, what are parameters? Now, parameters are basically predictor variables that are used to build a machine learning model or build any predictive analytics model. Now that we know what parameters are, let's try to understand the difference between a parametric and a non-parametric model. Now, parametric model basically uses a fixed number of parameters to build the model. A non-parametric model uses flexible number of parameters to build the model. When it comes to a parametric model, the assumptions about the data are very strong. In a non-parametric model, there are fewer assumptions about the data. A parametric model has the fixed number of parameters. Everything is defined over here. So the computation is very fast. Okay, you know what sort of variables you'll need to predict the outcome. Okay, you have a defined set of variables or a defined set of predictor variables that will compute your outcome. So that's why the computation is a bit faster. When you compare to non-parametric models, there are a lot of parameters taken into account. Now, when it comes to a non-parametric model, you do not have a fixed number of parameters. Right? You do not have a fixed number of predictor variables that will help you get to the outcome. So the computation is a bit slower. Now, parametric models require lesser data and non-parametric require more data. Example of parametric models include logistic regression and naive Bayes. And for non-parametric models, we have KNN and decision tree models. Now, logistic and naive Bayes models are very stern models because they have a fixed number of parameters or a fixed number of predictor variables, and they will give you an immediate output. Okay, when it comes to non-parametric models like decision tree models and KNN, you might even observe a little bit of overfitting. Okay, this happens because you have a fewer number of assumptions about the data and also because your parameters are not fixed. And that's not the reason for overfitting, but it's seen that in some of the non-parametric models, overfitting occurs more often. Now let's discuss the next question, which is what is the difference between hyperparameters and model parameters? Now, model parameters are the predictor variables that I was speaking about earlier. Hyperparameters, let's discuss what they are. Okay, model parameters are the features of training data that will learn on its own during training, whereas model hyperparameters are the parameters that determine the training process. Now, let's say that you want to determine the height of an individual depending on his weight. The height and weight will become your model parameters. But your hyperparameter is basically the learning rate. It's the rate at which your model is going to learn this correlation between the height and the weight. So this is the difference between model parameters and hyperparameters. Model parameters are the ones that you find in your data. These are all the variables that you use to predict your outcomes. Hyperparameters will define your training process. There is a huge difference between model and hyperparameters. Another difference is that they are internal to the model and their value can be estimated from the data. Hyperparameters are external to the model and their value cannot be estimated from data. Now, like I said, model parameters are derived from your data itself. Okay, these are the parameters that are there in your data. Hyperparameters are the ones that you define in order to train your entire data. So that is the difference between hyperparameters and model parameters. So the next question is, what are hyperparameters in deep neural networks? So guys, like I mentioned in the previous example, hyperparameters are variables such as the learning rate. This will define how your entire data training process goes. For those of you who don't know, in order to build a model, you first need to train the model and then you need to test it. Okay, now while training the model, you're going to make the model learn a lot of things. You're going to give it a lot of data. It has to figure out relations between various variables and how these variables are affecting the output. All of this training will depend on a few variables such as the learning rate. Okay, these are basically called hyperparameters in deep neural networks. So these parameters will define the number of hidden layers that are present in the network. Okay, and more the number of hidden layers, the more accurate your network is going to be. Whereas if you have lesser number of units, you may cause underfitting in your data. Underfitting will also result in inaccurate predictions. So that's why you need to make sure that the number of hidden units in your hidden layers are perfect, are ideal. Okay, and this is determined by your learning rate or by your hyperparameters. Not by your learning rate specifically, but by the number of hyperparameters you have. These number of hidden layers are determined by the hyperparameters. Okay, that's why hyperparameters are very important in deep neural networks. I hope you all are clear with this. Now let's look at our next question, which is explain the different algorithms used for hyperparameter optimization. We'll discuss the three methods, which are grid search, random search, and Bayesian optimization. Okay, now grid search basically will train the network only on the two sets of hyperparameters, which are learning rate and the number of layers. Okay, so it's going to use every combination of these two sets in order to train the network. Okay, after that, it will evaluate the efficiency of the model by using the cross-validation techniques. Cross-validation is the best improvement method. Okay, it's the best way to check if your model is optimal or not. Then we have random search. Now, this will randomly select samples and it will evaluate sets for a particular probability distribution. Now, in random search, there is no fixed number of hyperparameters that it's going to evaluate. So, it'll randomly select a set of hyperparameters. Okay, for example, now instead of checking your entire sample or your entire, let's say that you have 10,000 samples, instead of checking all of these samples, it'll randomly select 100 parameters that can be checked. Okay, and then it'll use this to build the model. After that, we have Bayesian optimization. Okay, now Bayesian optimization basically uses something known as the Gaussian process. Basically, the Gaussian process will help in model tuning. Okay, model tuning, or you can also say parameter tuning. So parameter tuning will help you tweak the parameters a little bit in order to improve the efficiency of the model. Okay, so Bayesian optimization basically makes use of the Gaussian process, which will provide model tuning to your algorithm and thus improve the efficiency. Now guys, one of the most important ways to improve the efficiency of a model is by hyperparameter optimization. Okay, if you're tuning your hyperparameters and if you're trying to check in which way these hyperparameters will give you the most accurate outcome, that's when your result will be very good. Okay, so that's the best way to improve the efficiency of the model. All right, now let's look at our next question. The next question is, how does data overfitting occur and how can it be fixed? Now guys, this is a very common question in a machine learning or in an artificial intelligence interview. Okay, people expect you to understand what data overfitting is and how you can fix these problems. Okay, because data overfitting occurs pretty often, especially if you're using decision trees or if you're using random forest. Okay, random forest actually reduces overfitting, but sometimes with these complex models, you can get data overfitting. Now, to answer this question, first of all, let's understand what overfitting really is. So, overfitting occurs when a machine learning algorithm captures the noise of the data. Okay, this causes an algorithm to show low bias but high variance in the outcome. Now, what overfitting really means is you have trained your model way too many times on the training data. Okay, so basically the model has memorized the training data. It has memorized the noise in the training data. Okay, so if you feed new data to the model during the testing stage, it will not be able to recognize the noise or it will not be able to recognize any sort of correlation in that data. Okay, that's why it won't be able to get a proper outcome. Okay, that's when overfitting happens. You have trained the model way too much with the training data, and this has resulted in inaccurate outcome during the testing phase. Okay, that's what overfitting is about. Now, how do you avoid overfitting? First of all is cross-validation. Now, before this also I mentioned that cross-validation is the best way to obtain a more optimal solution. Now, the general idea behind cross-validation is to split the training data in order to generate multiple mini train test splits. Okay, these splits can be used to tune your model. Okay, so you're basically splitting the training data in such a way that, the model does not just use the entire training data and memorize it. Instead, it's going to check the different sets in the training data and the different sets in the testing data and learn from it. Okay, so cross-validation is one of the best ways to prevent overfitting. Another method to prevent overfitting is by training the model with more data. So feeding more data to the machine learning model will help in better analysis and classification. However, this method is not always going to work, but yeah, this is also one of the ways to prevent overfitting. Okay, next we have removing features. Now, many times the dataset contains irrelevant features or predictor variables which are not needed for analysis. Such features will only increase the complexity of the model. Therefore, it will lead to possibilities of data overfitting. Okay, so if you have irrelevant data, like for example, if you're trying to understand the weight of a person depending on its height, and you have another variable, let's say you have a variable like the name of the person. Okay, now the name of the person is not relevant in understanding the height of an individual. So if you have irrelevant predictor variables, then it will just increase the complexity of the model because you have an extra irrelevant variable. All right, this will only increase the complexity of the model. It will not help the model in any way. So make sure you remove irrelevant features or you remove redundant features. Okay, the next method is early stopping. Now, a machine learning model is trained iteratively. This will allow us to check how well each iteration of the model performs. But after a certain number of iterations, the model's performance starts to saturate. Further training will only result in overfitting. Okay, so like I mentioned, if you train the model with the same data and you make the model memorize the data, then it'll just saturate. It won't be able to predict any outcomes after a point. What you have to do is you have to understand where you need to stop training the model. So this can be achieved by using a mechanism known as early stopping. So at this point, you know that you have to stop training the model because this might result in overfitting. Now, regularization is one of the most common ways to prevent overfitting. Regularization can be done in n number of ways. Okay, the method will always depend on the type of learner you're implementing. For example, pruning is performed on decision trees. Now, pruning is a type of regularization. Similarly, the dropout technique can be used on neural networks. And also there are other methods like parameter tuning, which can help to solve overfitting. The next way to prevent overfitting is by using ensemble models. Now, ensemble learning is a technique that is used to create multiple machine learning models, which are then combined to produce more accurate results. So basically, if you have one problem statement in machine learning, you're going to use like 5 to 10 different models, and then you're going to calculate the accuracy depending on the average of the result from each of these models. By this way, you will reduce overfitting. Now, ensemble models is one of the best ways to prevent overfitting. An example is the random forest. Random forest uses ensemble of decision trees to make more accurate predictions and to avoid overfitting. So basically, random forest is a set of decision trees. So here you're going to train the model by using a set of decision trees, and this way you'll have different data sets, and on each of these data sets you'll have a different decision tree model. Okay, this will reduce overfitting to a very large extent. That's why in most of the cases when you see a decision tree having overfitting issues, you'll be asked to use random forest. So guys, those were the different ways to prevent overfitting. Now the next question is, mention a technique that helps to avoid overfitting in a neural network. Now the most famous method to prevent overfitting in neural networks is dropout technique. Okay, now dropout is a type of regularization technique which is used to avoid overfitting in a neural network. So here what you do is you randomly select neurons and you drop them during the training phase. Right, so the dropout value also has to be chosen very carefully because a higher dropout value will result in underlearning by the network. So if you're dropping out too many predictor variables or if you're dropping out too many neurons in a neural network, then the model will not learn enough, okay, because there's not enough predictor variables and not enough neurons. But if you have too much of a low rate for a dropout value, then this might have a very minimal effect. So make sure your dropout value is very optimal depending on the problem you're trying to solve. Okay, so dropout is the technique which is used to avoid overfitting in a neural network. Next question is, what is the purpose of deep learning framework such as Keras, TensorFlow and PyTorch? So Keras is basically an open source neural network library which is written in Python. So basically it is designed to enable fast experimentation with deep neural networks. Now, TensorFlow is another open source software library for data flow programming. TensorFlow is mainly used in machine learning applications. Similarly, PyTorch is again an open source machine learning library for Python. Its applications are mainly in the field of natural language processing. Now, I'd say that these three deep learning frameworks are the most important when it comes to machine learning and deep learning because they have a varied set of functions in them which help in building a better machine learning model or a better deep learning network. Now let's look at question number 24, which is differentiate between NLP and text mining. So guys, NLP stands for natural language processing for those of you who don't know. Now, first of all, let me clear out a confusion between text mining and natural language processing. A lot of people tend to think that text mining and NLP are the same thing, but text mining is the broader field and NLP is basically an application of text mining, or it's basically a technique used in text mining. So the aim of text mining is to extract useful insights from structured and unstructured text, whereas the aim of NLP is to understand what is conveyed in these texts. Now, text mining can be done using text processing languages like Perl, and NLP can be achieved using advanced machine learning models such as deep neural networks. Now, the outcome for text mining is you'll calculate the frequency of words, you'll understand the patterns between different words, you'll understand the correlations between two different words, and you'll see how these two words occur together more frequently and why they occur together more frequently. So text mining basically will give you a more understanding about the words that are used in a document. Whereas in NLP, you will understand the grammar behind the text. You will understand in more depth about the language that is used in the document or in whatever you're trying to analyze. So that is the difference between NLP and text mining. NLP is a little more advanced field because you use deep neural networks to perform this. Text mining, on the other hand, makes use of NLP. Next question is, what are the different components of NLP? Now, there are two components of natural language processing, which is natural language understanding and natural language generation. In natural language understanding, you'll basically map your input to some useful representation. This means that you'll try to understand the correlations in your language, and it'll also include analyzing different aspects of the language. All right, so this is majorly about understanding your text. When it comes to natural language generation, here you'll understand how to generate text by having a brief plan about the text. You'll have sentence planning and you'll have text realization. Now, natural language generation will basically break down sentences or will break down text in order to understand it better. Okay, that's what natural language generation is. Natural language understanding is more about analyzing your language or analyzing the text that you have at hand and predicting some useful outcome out of it. Generation is more focused on the planning aspect of your text. So these are the different components of natural language processing. Now let's look at what is stemming and lemmatization in natural language processing. Now, what is stemming? It is an algorithm which works by cutting off the end or the beginning of the word and only taking into account a list of common prefixes and suffixes that can be found in inflected words. Now, for example, on the screen you can see that there is detections, detected, detection, and detecting. Now, if you apply stemming on these four words, it will lead to detect. Okay, because at the end of the day, detections, detected, detection, and detecting is the same thing as detect. So stemming will help you remove all of these unwanted prefixes and suffixes. This way you can analyze the importance of the word. Alright, you don't have to have extra suffix or prefix before the word. Now, sometimes during stemming, cutting off the ends of the words will form an inaccurate result. Okay, that's why we have lemmatization. In lemmatization, the most important thing is the morphological analysis of the word. Okay, so here, in order to perform lemmatization, you have to have a detailed dictionaries which the algorithm can look through and it can form back to its lemma. So the main difference between stemming and lemmatization is that stemming will just crop the prefix and the suffix, whereas lemmatization will try to understand the word in a grammatical way and give you an actual word as the output. Next is to explain the fuzzy logic architecture. Alright, so the fuzzy logic architecture looks like what is shown on the screen. Okay, so basically the input is fed into something known as the fuzzifier. Okay, the fuzzifier or the fuzzification module will transform the system's input into a number of fuzzy cells. Okay, after that it's fed to the controller. Now the controller will have knowledge base and the inference engine. Knowledge base is basically a set of rules, or you can say it's an algorithm which is provided by experts. Inference engine, like the name suggests, will basically infer meaning out of these rules. Okay, so once you've applied the rules to your input, you'll have to draw some useful insights or you'll have to infer these inputs. Okay, for that you use the inference engine. After that, whatever inferences and analysis you've formed from your inference engine is passed on to the defuzzification model. Now the defuzzification will just give you a crisp output. Alright, it will give you a clear and cut output. That is the whole fuzzy logic architecture. Now let's understand the components of an expert system. Now there are three important components in an expert system, which is knowledge base, inference engine, and user interface. Now, like I mentioned in fuzzy logic, the knowledge base and inference engine will play the same part. The user interface is basically to provide interaction between the users of the expert system and the expert system. Okay, the expert system is basically a program that helps in decision-making process. Okay, so here the knowledge base will contain some high quality knowledge, or it'll contain rules and algorithms. The inference engine will acquire all the knowledge that is needed to solve the problem, and the user interface is just for the users to interact with the expert system. Okay, this is the whole expert system component. Now, obviously, this is a little more complex than this, but let's stick to how this works. All right, I'm just going to tell you the working of expert systems and fuzzy logic. If I start to explain each and everything, it's going to take a lot of time. All right, so let's move on to our next question, which is how is computer vision and AI related? Now, computer vision is a field of artificial intelligence that is used to obtain information from images or multidimensional data. Now, computer vision is basically the concept behind the self-driving cars that you see these days, right? Computer vision involves a lot of image processing. So machine learning algorithms like k-means can be used in image segmentation. Support vector machines can be used for image classification. Okay, that's how computer vision and AI are related. Because most of the things that happen in computer vision, like image processing and segmentation, make use of machine learning algorithms like k-means and support vector machines. So to sum it up, computer vision makes use of artificial intelligence technologies to solve complex problems such as object detection, image processing, and so on. That is the relationship between computer vision and AI. Now, question number 30 is, which is better for image classification? Is it supervised or unsupervised classification? So guys, earlier in the session, we discussed what supervised learning is and what unsupervised learning is. In supervised learning, the images are interpreted manually by the machine learning expert to create feature classes. Now, what this means is you're manually going to feed a label set of data to the supervised learning model. All right, that's how supervised learning works. You're manually going to feed a set of images which are labeled to the classifier. In unsupervised learning, the machine learning software creates feature classes based on image pixel values. So basically, in unsupervised classification, the model itself has to figure out what to do and what not to do. Okay, so it'll create a own feature class based on some values such as image pixels, or it can also use the image color, or it can use intensity factors in order to classify. So if you ask me, it is better to opt for supervised classification because you're manually inputting images with a lot more information. Okay, whereas in unsupervised learning, you're totally letting the model perform everything. Okay, so in image classification, I think it's better to go for supervised learning. Now let's look at question number 31. The next question is, finite difference filters in image processing are very susceptible to noise. To cope up with this, which method can you use so that there would be minimal distortions by noise? Now, the noise in an image can be due to high intensity or high contrast. Okay, so if you increase the contrast and increase the intensity of an image, you won't be able to understand each pixel. Okay, so each pixel will have a value associated to it. And if the intensity and the contrast of that pixel is a little too much, it'll be hard for us to understand the image properly. It'll be hard to perform image analysis because we don't have a clear image. Contrast and intensity will just cause noise in an image. So the best method to remove this is image smoothing. Okay, it is used for reducing noise by forcing pixels to be more like their neighbors. Okay, this way you'll have a faded image or you'll have a more equalized image. Now the next question is, how is game theory and AI related? So guys, AI is actually applied in a vast number of fields. Okay, so a lot of fields from computer vision to game theory to machine learning. AI is always a concept behind these fields. Most of the game examples that we see make use of reinforcement learning or deep neural networks. Now, deep neural networks and reinforcement learning are very closely related to AI because they are branches of machine learning. So machine learning is majorly involved in game theory. An example of this is in Dota 2 also they make use of machine learning. So game theory is just a very logical approach to solving a problem. And machine learning is the best way to implement game theory. Now question number 3 is, what is the min-max algorithm? Explain the terminologies involved in the problem. Now guys, min-max is one of the main algorithms which is used in game theory. Alright, it is used to choose an optimal move for a player, assuming that the other player is also playing optimally. Meaning that both of these players are playing in order to win. And you're going to use the min-max algorithm on one of these players so that they choose the optimal move. In order to understand the min-max algorithm, you need to know what are the components in a game. Okay, there's something known as game tree. it is basically a tree structure which contains all the possible moves in a game. If it's up, down, right, left, any strategy, everything is mentioned in the game tree. Now, initial state is obviously the initial position of the player on the board. Alright, the successor function, it defines all the possible moves that a player can make. We'll understand this in the next question itself, so don't worry if you haven't understood this properly. Terminal state is obviously the end of the game. It's basically the state which will lead to the end game, or it will lead to your destination. Utility function is a numerical value for the output of the game. So guys, these were the terminologies, and this is what the min-max algorithm is. It is basically a game theory algorithm which helps a player choose the best optimal policy in order to win a game. Now I'll explain this in more depth in the upcoming slides. So let's move on. Now the next couple of questions are going to be scenario-based questions. Now such questions are very important in an interview because this is where the interviewer will understand how well you know the concepts. So the first question is, show the working of the min-max algorithm using the tic-tac-toe game. Now, one of the major applications of the min-max algorithm is the tic-tac-toe game. Okay, you can understand and analyze all the possible outcomes of the tic-tac-toe game by using the min-max algorithm. Let's see how this happens. Now, first of all, in a min-max algorithm or in a game, there are two players involved. Okay, the max is the player that tries to get the highest possible score, and min is the player that tries to get the lowest possible score. So this algorithm is designed in such a way that, assuming that there are going to be two players, and obviously one player is going to win the game, and that is the max player, and min is the player which loses the game and has the lowest possible score. Now the first step in the min-max algorithm is to generate the entire game tree. Okay, the game tree is all the possible outcomes that can happen in tic-tac-toe. Okay, in the figure you can see that first X is aligned in the first box, then in the second box, third box, and so on. All the possible actions that you can take in a tic-tac-toe game are put in this game tree. And then step number 2 is to apply the utility function to get the utility values from all the terminal states. Getting utility value is important because this is how you'll understand your outcome. Okay, you'll understand if you're going to win or lose. Now in the terminal states, whatever numbers you see over here, these are the utility values. Now step 3 is determine the utilities of the higher nodes with the help of utilities of the terminal nodes. Now in this diagram you can see that in the terminal nodes we have the utility values. The step 3 is to get utility values in the higher stages, which is the min stage. Alright, these two circles you need to fill in the utility values by using the utility values which are in the terminal state. Now how do you calculate the utility value? Let's start by calculating the utility value of the left node. Okay, this red color node, we'll start by calculating this. Now you calculate that by finding the minimum of the 3 nodes that it's leading to. Now this red node is leading to 3, 5, and 10. And the minimum out of 3, 5, 10 is 3. So the utility value for this red node is going to be 3. Okay, similarly for this green node, it's going to be 2 because the minimum value between 2 and 2 is still 2. Now step 4 is to fill in these utility values that you've calculated. So now we have a min-max algorithm which has all the utility values filled in. Now the only utility value which isn't filled is the one with max. Okay, the one on the root node. Here we haven't filled the utility value. Again, to fill this value, you're going to check the nodes which are directly connected to it, which is 3 and 2. You'll find the maximum between these two because this is the max function. Alright, so here you'll get a value of 3. So that's why the best opening move for max is the left node. Okay, you can make use of the left node in order to win the game. This is the first step that the max player has to take in order to get to the path of winning the game. So guys, by doing this for each and every step, you can win the game. Okay, so you'll have to calculate the utility value at the terminal nodes. You'll have to move up to the other hierarchical nodes above it, calculate the utility values there until you reach the root node. Okay, once you reach the root node, you'll get a utility value, and that utility value will be connected to some move or some node. You'll have to take that node or you'll have to take that move in the game in order to win the game. So this way you'll have to calculate the utility value for each and every move that the player makes so that the player will win the game. So guys, min-max algorithm is quite easy and it's very understandable. All you need to know is a little bit of math in order to solve this problem. Question number 35 is, which method is used for optimizing a min-max based game? Now, this is not a scenario-based question, but this question is usually asked if an interviewer asks you about a min-max game. Now, the best way to optimize a min-max game is by using something known as alpha-beta pruning. Now, the main thing about alpha-beta pruning is that it will remove all the nodes that are not affecting the final decision. It's just a faster way to reach your outcome. That's what alpha-beta pruning is all about. So let's look at an example to understand this. Okay, let's say there was another node over here. Okay, here you can see that this is going down to a terminal state with utility value 2. Okay, now you don't know the value of the other two nodes, but if you use min-max to calculate the utility of the other two nodes, you'll get a value of 3. So in this example, again, we'll start at the terminal nodes. So 3, 5, 10 are the utility values here. So this will give us a value of 3 because we're calculating the minimum over here. Now here you have 2 and you have 2 unknown values. You have A or B. Okay, I've named them as A and B. Okay, let's leave this for now. Let's go to the next node. Okay, here the possibilities are 2, 7 and 3. So the minimum between 2, 7, 3 is 2. Okay, so here there's going to be 3. There's going to be a value, let's say C, and here there's going to be a value, let's say 2. Now we know that the maximum between 3, C and something else will be 3. Okay, that's because 2 is the minimum value over here and the maximum will obviously be 3. So the hint here is in the 2AB node, we know that the value or the utility value will obviously be equal to 2 or it will be less than 2 because you're calculating the minimum in this step. Now, if you calculate the max out of these 3 values, we'll obviously get the answer as 3. So this way, this entire node itself is removed because you don't need it to get to the final answer. Okay, that's what alpha-beta pruning is all about. It'll identify the nodes which are not going to affect the final decisions and it'll just remove those nodes. So guys, this is how the optimization for a min-max game is done. It's done using the alpha-beta pruning. So that's it for today, guys. I hope all of you enjoyed the video. Have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!